It's happening.
I'm still vibing to the music, honestly. Who made this playlist? I need to have this playlist.
I'm sure it was Teresa Giacomini and Isaac Alves. I mean, they must have done it. I don't think they actually performed the music, though. I think they found it somewhere. Anyway.
Sounded is good enough for me. I just need it, and it needs to be shared in Discord.
Well, welcome everybody to Posette, an event for Postgres. This is our 4th year. And
Congrats.
I'm so happy to be here with you, Floor, to be the MCs for today's extravaganza. And there is, of course, a virtual hallway track that we'll give you a link to in a moment if you're just here with us on the live stream. Should we dive in? Are you ready to go?
Yeah, let's kick this thing off.
Okay. I'm joining from California, and you are
in the Netherlands, Europe time zone. That's where I'm at. I know that it's morning for you. It's basically end of working day for me. So we couldn't be in more different places in the world right now. I don't think so.
Well, I'm sure that's going to be the case with a lot of people who join us as well. Some people will be like you in Europe at the end of their day. Other people will be here in the Americas just starting off. There are 42 talks total in Posette this year, 4 different live streams. Each live stream is unique, with the exception of the 2 keynotes. The 2 keynotes each play twice. So today's keynote will play again in live stream 4, for example, Charles Feddersen. And then Bruce's keynote will play in both live streams 2 and 3, but all the other talks are unique each time. So if you have to leave early today, be sure to come back tomorrow because there'll be more. Yeah, and you can look at the schedule online. And here we are. My name's Claire Giordano, and...
Oh, yeah. Hi, my name is Floor. Yeah.
And are you going to tell people how to pronounce your last name? Do they need to know to do their jobs?
Do they need to know? I don't know. It is a difficult one. It's Drees. I like it's a short one, so you don't think it's that difficult. But I think people have difficulties with my name in general. I mean, explaining to people that it's really Floor, like the ground, is always a fun experience. Yeah.
And there are some awesome live stream hosts for the upcoming live streams as well. So you'll get to meet them if you come back for any of the other shows. Posette is brought to you by the Postgres team at Microsoft. I work at Microsoft on this Postgres team, and we have people who work on contributing to the upstream open source project, as well as people who work on our Azure managed service. And it's the whole team together that is organizing today. And why are we doing this, Floor?
Because it is really great to do these events that are virtual and online, that everybody with an internet connection can just dial in and enjoy and connect with the community and get some awesome content, and they don't even need to leave the house or the office for it.
All right, so we have a code of conduct. And it's fairly straightforward, right? It's about being friendly and welcoming, thoughtful, patient, and respectful of all the other people. There is a link on the right-hand side to the code of conduct. You can get to it on the PosetteConf website. And if you run into any issues at all, there are instructions there about what to do. So important part of in-person events, but also an important part of virtual events as well. And I know, Floor, you've served on a lot of code of conduct committees yourself. So this is something that is true, I think, across the Postgres community.
Yeah, very near and dear to my heart. Not only teams for different events, but also on the Postgres Code of Conduct Committee since last year summer.
Thank you for doing that. All right. Accessibility, captions. This stuff's important. It's really interesting. There's this thing called the curb cut effect where things are done for a particular class of people and they end up benefiting everybody. And I feel like captions are a lot like that. So we do have today's live stream that is going to be captioned in English. And then the videos all get published online after the show is over. So in other words, after live stream 4, everything will be up and available to watch on YouTube at 2x speed if you want. And in addition to those English captions there'll be translations in 16 different languages as well, including Dutch, Floor. Just saying.
Including Dutch. That's funny. Okay, cool.
Okay. Fun. Well, no, it should be including Dutch, don't you think?
Sure.
Okay. All right.
But that's great. That's a great service that you're offering. 16 languages is a lot. That's cool. And then, yes, of course, like we're all tuning in for this event and potentially on our phones or, on our computers. Maybe you want to be live posting about the event and let everybody on the internets know that they can also check in for this conference. We're live on Discord. We are on LinkedIn, on X, formerly known as Twitter, Blue Sky, and Mastodon. So definitely connect with us there and let everyone know that you're following along with the live stream using the PosetteConf hashtag.
Yeah, so we've got accounts in all these places if you would like to follow. And I'm pretty sure Teresa will have posted pictures of each of the speakers in each of the talks across the board as much as possible. So that's important. And speaking of speakers, we want to say thank you.
Look at all of these beautiful faces. I'm very excited about all of these talks. That is a great group of speakers.
So 45 speakers this year from 21 different companies. So there is a lot of participation from people at Microsoft. We are the hosts after all. We should be participating in this conference, but is a lot of participation from the Postgres community around the world from lots of different places. So yeah, you can go check out who they are, what their bios are. A lot of people did interviews, written interviews before the fact, so you can find out more about their background and what they're expert in. And of course, more information about the talks that are coming up. Now, if you're having trouble deciding, okay, I'm free today and tomorrow, what talks are going to be interesting to me or what you want to watch after the conference is over, I did write this blog post. And maybe I was being a little dramatic when I titled it The Ultimate Guide. Maybe that's a bit hyperbole, maybe. But it did categorize all the talks, subcategorize, tag them to try to help you get a feel for what might be relevant to you. So there are 18 of the talks are about the Postgres core technology. And then 12 of them about the ecosystem. So extensions, tooling, and then 10 of them are about the Azure database for Postgres managed service. So if you're a customer of that, there are absolutely talks for you as well. And then the two amazing keynotes, one from Charles Feddersen and one from Bruce Momjian. So what have I missed? Anything else that people need to know?
I don't think so. Hit that QR code and make sure that you read it and figure out what are the talks for you, when you need to tune in for sure.
Okay, and then the virtual hallway track. So this is important. If you're not already there, if you're not already on Discord, you should go to Discord. I mean, in person, I was just at PGConf Dev in Montreal a couple of weeks ago, which is an amazing contributor conference for everybody interested in the development of Postgres. And the hallway track was incredible. There was so much going on, so many conversations, negotiations, discussions. It was really, really fun. We can't replicate that exactly in a virtual event, but it can be fun. And you can do it with your slippers on or from your office or from your desk and chit chat with others, regardless of where they are in the world. And so that's what we're trying to do. So please join us on the virtual hallway track on Discord.
Exactly. Claire and I will be there and we'll pull up some of the nice comments that you place or interesting questions that you pose. We'll pull them up during the live stream as well.
And then most of the speakers will be there live on Discord while their talks are being live streamed because their talks are pre-recorded. So I think I know of one example where that's not true. He's going to be on an airplane during his talk, but most of the folks are going to be there. So it's a good chance to ask questions live as they happen. And if you can't see the screen, it's aka.ms/open-source-discord is where you can join. And then you want to go to the #PosetteConf channel. All right, this is yours, Flor.
Yeah, so we have some fun swag to give away during the live streams. So we'll distribute some codes in Discord and on the live stream during the conference. And following that, you can get some great swag, such as the stickers and some of the socks. The socks are great, by the way. Like I still have socks from last year. I wear them a lot. Get a lot of great compliments on them. So you definitely want to pick up some socks. So make sure you keep your eyes peeled for those codes.
And the socks themselves are only if you do a survey this year? Is that how it's working?
I thought we were getting another, yes, exactly. We were getting another slide so that I could talk to the surveys.
Okay.
Yeah, so completing a survey, you'll get socks, limited edition though, so as long as they're available. But just by filling out one of the surveys, you'll get a pair of socks sent to you. So definitely make sure that you give that feedback, not only because you get the socks, but it's really great for speakers and for us also to get the feedback on the event and make sure that it's even better next year.
And we will pop this slide up again throughout the day. So if you can't get to your camera right now and scan that QR code or write down that URL fast enough, don't worry, we'll bring it back. Speakers love feedback. And obviously the organizers for the event, they love feedback as well. So, and it helps us get better year over year. This is unlike what we did last year. Last year for the talks, we had one survey with like 42 talks in it, and it involved quite a bit of scrolling. And so people asked us, can you make it easier for us? We don't want to scroll through so many talks. And that's why the talk surveys, there's going to be a separate one for each live stream. So that way you only have to scroll as far as 11 talks, which we felt like everybody could handle.
That's doable. Yeah.
Yeah. It's totally doable. All right. So now I think it's almost time to get going. Let's look at the schedule for today. We've got 11 amazing talks from 12 speakers, and we're really excited to dive in and get going. Rather than kind of try to walk you through it verbally, we have a trailer. So let's get a peek of what's coming up in today's schedule.
Hi everyone, and welcome to the 4th year of Posette and event for Postgres. My name is Charles Feddersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hi, my name is Robert Haas. I work at Enterprise DB, where my current job title is VP Chief Architect Database Servers. And my talk is about incremental backup, which is a new feature that I developed for PostgreSQL 17. I'm hoping that this feature will be of particular interest to people who have large databases and they're looking for some new backup and restore options.
Hey, hello, my name is Boriss Mejias in the role of Monica de Bea.
And I'm Sarah Conway in the role of Evelyn Cates.
And the reason that we are saying in the role of is because this is going to be storytelling. We are going to tell you the story of a developer who comes and seeks help from a DBA who knows a lot about databases, and together combining their knowledge, they are going to be able to provide data integrity through data modeling.
As you can imagine, if you're an application developer or a DBA or anyone in between, even if you're just interested, you can definitely benefit from this talk.
So hello, my name is Tomas Vondra. I work at Microsoft. I'm a long-term Postgres contributor, developer, and also a committer. And I'm here to talk about performance archaeology, which is an overview of how the performance of Postgres changed over the many years of development. So if you are interested in performance and are a user or a developer, this talk might be interesting for you.
I'm Pamela Fox, and today I'm talking about building modern Python web apps with Postgres. If you've ever thought about building a Python web app and you're trying to pick the technology stack, then this talk is for you.
Hey everyone, I'm Matt McFarland, and I'm an engineer at Microsoft and a contributor to the new VS Code extension for Postgres that's just been released to public preview. Please join this talk if you're interested in learning about a new tool in VS Code that can help manage and you develop Postgres applications using both standard database management tools and also more advanced Copilot AI capabilities.
I'm Lukas, Fittl, founder and CEO of PG Analyze. We're going to talk about how to optimize slow queries in Postgres, specifically when you have an explain analyze output and you don't know how to interpret it. I'm going to give you a few tips and tricks and a better mental model for working with slow queries in Postgres and how to fix them.
Everyone, I'm Bohan Zhang. I'm a member of technical staff at OpenAI. In this talk, I will discuss how we scale Postgres to the next level at OpenAI. Specifically, we will talk about how we operate Postgres and the lessons we learned and the challenges we face and how we address them at OpenAI. If you are a DBA operating production Postgres at a very large scale, who might be interested in this talk.
Hi, I'm Vinod. I'm a partner software engineer at Microsoft and one of the committers of Microsoft's DocumentDB. And today, I'll be talking about designing document databases for PostgreSQL, aka how we leverage the awesomeness of Postgres' extensibility model to build Microsoft's DocumentDB.
Hi all, my name is Gayathri Paderla, working with Microsoft as a PostgreSQL performance expert. Boosting the PostgreSQL server's performance using Azure Advisor recommendations is the best way to identify any vulnerabilities your server is going through. You will be informed proactively, and anyone who is moving from Oracle, who is not aware about the internals of the PostgreSQL, for them this is the best approach to identify their server's vulnerability and get it fixed.
Hi, my name is Philippe. I'm one of the founders and the CEO of ParadeDB. Today, my talk is titled Elasticsearch-Quality Full Text Search in Postgres using Tantivy. We're going to be talking about how you can do full text search in Postgres today, what it's amazing at, what it's perhaps not so good at, and then some of the ways in which the work that we do at Parade with an extension called pgsearch is lifting the limitations that full text search in Postgres has to make it competitive with Elasticsearch and other search engines.
Okay, that was so much fun.
I love these trailers, honestly. Like, I get really excited. I took some notes about which, like what I really want to pay attention to for all of these talks. So I guess we should just get started, shouldn't we, Claire?
Yeah, let's do it. Our keynote speaker for Livestream 1.
Yeah, absolutely. So Charles is joining us, and Charles is the Director of Product Management at Postgres on Azure. So in this talk, we'll get a bird's eye view of everything that Microsoft is building for Postgres. That includes some of the significant contributions, of course, that Microsoft is making to Postgres 18, as well, of course, as organizing this event, organizing Posette, now in its 4th year, as you already mentioned, Claire. What else they're working on? Let's hear it from Charles.
Hi, everyone, and welcome to the 4th year of Posette, an event for Postgres. My name is Charles Feddersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025. Over the past few years, Microsoft has continued to invest more and more into open source Postgres. This includes both code that goes into the open source project and the investments that we're making to sponsor community events or hosting events as we do with Posette. We're pleased to be able to put on this virtual conference for the community, and we want to share some data on how Posette has evolved over the years. Posette stands for Postgres Open Source Ecosystem Talks, Training, and Education. And as we enter the 4th year of running this event, we're pleased to see such a strong response from the community. This year, we received 230 talk submissions, which is a 25% increase over last year, and content from the Posette 24 conference has been viewed over 42,000 times. Of course, conferences, even virtual ones, take a lot of work. And as we have an amazing team at Microsoft who make this event happen every year, I'd like to thank the 2025 Conference Organizing Committee of Aaron, Abe, Amu, Bilge, Jeremy, Linda, Pooja, and Teresa, who have done an exceptional job to develop and run this fantastic event. I'd also like to offer a huge thanks to our talk selection team. As I mentioned, this team was given the daunting task of working through 230 submissions and selecting down to only 40 talks for the conference, and I know there were far more than 40 great submissions that they wanted to accept. In early May, Claire Giordano published our annual blog covering all the Postgres work that we've done at Microsoft for the past 12 months. It's a massive aggregation of our work over the last year and encompasses investments in open source, the features we've shipped in the cloud in Azure Database for Postgres, and of course, the investments into the community. If you haven't taken the read, I encourage you to do so when you have some time. And if you don't have time, Copilot will do a great job summarizing it for you. You can get there quickly from aka.ms/blogpg at Microsoft. Now, Postgres 18 is coming a little later this year. And as with Postgres 17, Microsoft has been a significant contributor. To date, Microsoft engineers have made 456 pre-release commits to Postgres 18, and this includes work done solely by the committer, co-authored by the committer with somebody else, or committed on behalf of another author in the community who authored the patch. Let's take a look at some of the key contributions that Microsoft is making into Postgres 18. We'll start with asynchronous I/O, which has been a multi-version investment to incrementally add this complex feature. Postgres 18 adds significant new infrastructure to perform efficient file system I/O with modern operating system features. In Postgres 18, all read streams will now use true asynchronous I/O, and in future releases, other types of I/O, perhaps most notably writes, will also support async as well. The chart on the screen shows the relative improvement of Postgres 18 performance over a variety of functions using both local and cloud storage relative to Postgres 17, which is the baseline of 1, which here is effectively the y-axis. And you can see there are some significant performance improvements coming in Postgres 18. Now, we've contributed a bunch of performance improvements for query processing as well. And this includes patches to enhance memory management for materialized window aggregation, common table expressions. We've contributed patches to improve performance of hash group by and hash joins, and also the performance of fast path locking that reduces contention between Postgres sessions that obtain a large number of locks. And finally, we've contributed an optimization for group by performance with subplans and unique indexes. Currently, Postgres does not support native cloud-based authentication, and changes are required to support enterprise identity. In Postgres 18, our team contributed to bring OAuth 2.0 authentication to Postgres, allowing users to log into the database using secure token-based credentials from identity providers. Now, this feature will enable third-party identity for Postgres while remaining more aligned to the upstream Postgres project. We've learned a lot from customers about bottlenecks they've encountered with table partitioning and co-authored patches in Postgres 18 to improve the performance based on these learnings. Almost everyone using partition tables will benefit from these improvements, and our initial benchmarks with 56 partitions show that the planner is now 3x faster in scenarios of thousands of partitions, and the benefits will be even greater. One of our favorite topics for everyone is vacuum, and one of the main items our team contributed to in Postgres 18 is enhancement to reduce the impact of aggressive vacuum. Now, aggressive vacuums can incur large amounts of extra I/O at the expense of workloads to reduce the cost of aggressive vacuums. This contribution enables Postgres 18 to eagerly scan all visible pages during normal vacuums with greater efficiency. And finally, moving on to multi-threading, I think most people know that Postgres currently utilizes a process-based architecture, and the topic for introducing threading has long been discussed in the community. Now, as Postgres is being applied to more demanding applications, multi-threading will enable PostgreSQL to run these events more effectively. Our team is working on some early groundworks that enable the future work to bring multi-threading to Postgres. Very early, but we're getting started. Now, switching gears, I'd like to talk about one of the major announcements we just made at the Microsoft Build Conference in May, where we announced the availability of an entirely new Postgres extension for VS Code. It's no secret that Postgres is the preferred database for building new apps, and its popularity is growing each year. We've spoken to so many developers who are building or occasionally just maintaining Postgres applications. And what we've learned and heard is that although Postgres is great, developers could definitely benefit from better tooling. Application developers tell us that they consistently break out of their flow from writing app code into specialized Postgres tools like pgadmin or a pSQL terminal, but they find this a little clunky and inefficient. So to help developers who are building in VS Code, we've released a new Postgres extension that works with any version of Postgres running anywhere. It's IntelliSense enabled, deeply integrated with Copilot, and free to download and get started today. And to give you a sense of some of the functionality, I've asked my friend Rob from our engineering team to do a quick whirlwind tour of just some of the new functionality. Take it away, Rob.
The extension allows me to quickly create a local instance of PostgreSQL inside a Docker container, allowing me to get started developing quickly. Or I can quickly connect to an existing Azure database for PostgreSQL flexible server directly from my Azure resources. With built-in Entra authentication, there's no need to store passwords locally. The extension seamlessly manages token refreshes, making secure, password-free connections effortless. Once connected, I can browse database objects and launch an integrated query editor. The extension's IntelliSense helps me quickly find the right tables, views, and columns, and the formatter keeps my SQL tidy. After executing a query, I can browse the results in the results viewer, filter for column values, and export them directly to Excel, JSON, or CSV. The extension also lets me quickly open a pSQL terminal connected directly to my database, bringing the power of this popular Postgres tool to any database connection, including those using Entra authentication. Here I have a database that contains a sample dataset representing a DVD store. I select Chat with this database, bringing up a chat addressing our @pgsql copilot. The copilot has the full context of my database and can easily construct complex queries, execute them, and interpret their results. Here I ask about top revenue films per category over a period of time. Copilot has no problems answering my question directly. If I want to see how Copilot got the answer, I can go to the query history and find every query Copilot has executed against my database. This example demonstrates Copilot's Azure-specific capabilities when working with an Azure PostgreSQL instance. I can ask Copilot to describe my server's resources, check when the most recent backup occurred, and have it add the disk-ANN extension to the allow list of extensions for my instance. Here I have Copilot help me set up a disk-ANN index on a table storing embeddings of archived paper abstracts. Copilot guides me through configuring disk-ANN using the latest documentation and confirms the details before creating the index. The extension works great with any Postgres database, and even better with Azure. Whenever I want to spin up a new Azure database for PostgreSQL Server, I can do it directly from VS Code.
We've had a ton of positive feedback on this new extension, as well as an ever-growing backlog of features that developers would like us to deliver. We're going to continue to add new features fast and keep new versions rolling out, so stay tuned, and we'd love your feedback on this tool as well. Now, let's talk about AI. In May, we announced the general availability of disk-ANN, a state-of-the-art vector indexing algorithm developed by Microsoft Research and available on Azure Database for Postgres. Disk-ANN offers exceptional performance and accuracy for similarity search tasks, making it a powerful choice for developers building high-scale generative AI and semantic search applications. Disk-ANN significantly outperforms traditional vector index methods, such as HNSW or IV-flat, in terms of both query latency and retrieval accuracy. In our performance tests, we found that disk-ANN outperforms HNSW under common workloads while maintaining higher query per second throughput and using less memory. We've also recently added a new feature called product quantization. One of the key innovations behind disk-ANN's performance is product quantization, or PQ, which compresses high-dimensional vectors into compact representations and significantly reduces the memory footprint. And by enabling more vectors to fit in memory, PQ minimizes I/O operations and enhances the overall throughput. And unlike other quantization approaches, PQ allows for efficient approximate nearest neighbor search with minimal accuracy degradation. Whether you're building RAG pipelines, recommendation systems, semantic search, or real-time personalization engines, developers can now leverage this powerful disk-ANN index directly in Azure Database for Postgres for building better apps. Now, semantic operators. Vector search is a fundamental requirement for modern Gen AI apps, and it enables these agents to provide proper business context by retrieving relevant pieces of information from the database. But it scratches the surface of what's possible. Semantic relationships between elements of data are not visible to vector search, and this is where the new semantic operators that we announced in May come in. These operators add semantic understanding directly into your database and bring the reasoning power of language models to your queries. The most generic operator is Azure AI Generate, which can generate arbitrary ChatGPT-style responses in SQL queries and be used to generate test data or generate structured output. Is true returns a Boolean, resolving a natural language statement into a binary outcome that can be used for filter conditions or joins. Extract is a powerful operator for unstructured to structured data conversion. And this operator can be used to extract semantic relationships hidden in your data and act upon them to bring additional intelligence to generative AI agents. And finally, rank is a highly accurate semantic ranking operator, which is effective at boosting the accuracy of vector search. Now, to give you a quick example of how these work, I've asked my friend Abe to provide a quick demo. Take it away, Abe.
Hey folks, my name is Abe Marbe, and I'm a PM on the Azure Postgres AI team. Today, I'll be using semantic operators to enrich shop content and improve queries in my e-commerce database. Semantic operators allow me to use large language models in SQL. For example, I can use Azure AI Generate to generate descriptions for each product based on its name. This is super useful, especially for test data generation. Next, I can use semantic operators to find semantic relationships in the data using natural language expressions. Here, Azure AI is true operator returns true when it finds reviews that mention a particular feature. Now that I've identified features mentioned in reviews, you can then use the extract operator to get the sentiment about this particular feature. In this case, we define sentiment as positive, negative, or neutral. Lastly, let's flip to the rank operator, and I'll show you how you can use Azure AI Rank for re-ranking in Azure Postgres to improve queries. Let's run a normal vector search query. The results seem a bit off. I asked for the highest playtime, and I know we have headphones with better playtime than this. Here's a version of the same query, but now with re-ranking using Azure AI Rank. Much better results. The top results are now much more relevant. Semantic operators are a powerful addition to your database. You can utilize generate, is true, extract, and rank to greatly enhance the data in your database and improve query accuracy.
Thanks, Abe. We're incredibly excited about this new functionality and can't wait to see what application developers will be able to build with it. Now, when new technology waves such as AI come along, one of the largest challenges for everyone is learning how to apply it to real-world scenarios. To help with this, our team has developed 3 advanced solution accelerators that are designed to show how to build new AI apps using Azure Database for Postgres. The first one is Agentic Shop, which is a modern retail experience powered by multi-agent orchestration. It uses Llama Index, Mem0, pgvector, Discain, and our new semantic operators to deliver a dynamic and personalized shopping experience where each shopper gets custom layouts and AI-created content with memory of prior interactions driving smarter recommendations. It's a great example of how to build agentic systems using Postgres. The second one is to build your own copilot using Postgres. This one is a deep dive into building intelligent copilots using RAG, where it combines vector search, semantic re-ranking, and LangChain to deliver context-rich answers from structured and unstructured data, such as statements of work or invoices. And it also includes GraphRag using Apache Age for more complex knowledge grounding. And it's backed by a practical hands-on lab guide to help teams learn to deploy faster. And finally, there's Chat with Your Data in Postgres, which creates a natural language interface to your data using Azure OpenAI. Users can upload documents, index web pages, and query everything through a chat UI. It supports flexible RAG configurations and prompt engineering, which makes it a great starting point for teams experimenting. Let's now switch over and look how we can scale Postgres out. Elastic clusters are a new feature for Flexible Server, which enable modern applications to scale out across a cluster of Postgres servers without application layer sharding. Built on the open source Citus extension, Elastic clusters enable horizontal scaling of a database using either row or schema-based sharding, which makes it easy to manage large data sets using online rebalancing, tenant isolation to avoid these noisy neighbor scenarios. These clusters are well suited to applications that require high elasticity and scalable performance, where queries can either fan out or execute on a single node. Scenarios include multi-tenant SaaS applications, which can benefit from either schema or row-based sharding to spread tenants across a cluster, or microservice architectures where schema-based sharding enables independent scaling of different surfaces. Another great fit is IoT data processing, where row-based sharding can efficiently handle large-scale IoT workloads by distributing massive tables across multiple nodes. Now, the last topic I'd like to cover today is performance and how we're investing more in Azure Database for Postgres. So let's start with performance and scale. In the coming months, we'll introduce new V6 compute SKUs in GA from Azure that enable 192 vCores and up to 1.8 terabytes of memory. These servers not only increase the maximum number of cores and memories that the servers can deliver, but also improve the per-core performance. This new infrastructure raises the bar for the scale of workloads that Flexible Server can support. For high availability and disaster recovery, we recently announced the general availability of on-demand backups to provide greater control over backup schedules, with retentions of up to 35 days. We've also enhanced point-in-time restore of backups to provide an RPO of up to 5 minutes. For security, we've released versionless customer keys in April to provide simplified management of encryption keys by eliminating the need to manage specific versions. And for improved manageability and monitoring, we've released task automation in late 2024 to reduce operational overhead by automating routine tasks like server start and stop, scaling, and cost notifications. Today, we now support over 70 monitoring metrics, and we're consistently adding new metrics based on customer feedback. Monitoring is integrated into any of Power BI, Grafana, or Azure Monitor, and Azure Postgres now supports over 70 extensions as well, including pgvector.8 for AI workloads, PostGIS for geospatial, and timescale for time series. The Azure AI extension I mentioned before integrates with Azure Machine Learning and OpenAI, allowing enterprises to leverage AI models directly within Postgres for semantic search and anomaly detection. And finally, we've built new integrations to Microsoft Fabric to support mirroring from Postgres into OneLake for analytical scenarios. And we've also provided new transformations into the data flow so that you can add Postgres into your data integration pipelines. It's a great innovation into Fabric, and we think it's going to be a great way for you to make Fabric work with your existing Postgres implementations. Now, we've covered a lot, and we're working on so much more. At Microsoft, we're deeply committed to contributing to push the open source project forward into Postgres 18 and beyond. We're working on some of the largest multi-version features that are available in Postgres, and we're going to continue to push into new versions. And at the same time, we're continuing to innovate at a rapid pace in the cloud. And this is at both ends of the customer spectrum, from enterprises to developers. Over the next 6 months, you'll continue to see more scalability, security, and high availability improvements coming to Azure, while at the same time, we'll continue to invest in VS Code tooling and new AI capabilities that empower developers to build the next generation of apps more efficiently than ever. Thank you very much for your time today, and thank you again to the organizers of the conference. It is a packed agenda with exceptional speakers and amazing content. I'm looking forward to joining quite a few of the sessions myself. Thank you again, and enjoy the conference.
That was fun. A lot of information. And for some reason, I can't hear you. And I don't know why, Floor. I wonder if people can hear me. Well, let's just keep going. We're going to try to keep going. Okay, people can hear me. So if you want to give feedback on that talk, we're going to keep popping up these QR codes and the survey links so that you can go ahead and give feedback along the way. People appreciate it. So that's the reminder for that. And if you just joined late and you're not yet on Discord, there is a virtual hallway track. Floor's taking off her headset, which is great. We'll get your microphone working again. What?
That might mean that you can hear me.
Yeah, I can hear you now.
Well, excellent. Well, we'll see how we can fix it during the next talk that we have coming up. But yeah, definitely go into the hallway track. I've also learned in the hallway track that we have another VS Code extension talk coming up in a little bit on this live stream. So definitely stay tuned for that one as well.
I know you're always into anything relating to developer tools. That's up your alley.
It's like you know me, Claire. It's like you know me.
Well, I've never been to one of the conferences that you help organize in Europe, but it's Developer Days. Is that what it's called?
DevOps days, but yes, anything developer tooling will have my interest, and yeah, I can't wait to check that one out.
Okay, but please join us on the virtual hallway track on Discord. The link is on the screen, aka.ms/open-source-discord. And the speakers should be present during the live streams of their talks. So you can ask them questions, which is great. And of course, there's opportunities to get swag as well. I get the honor of introducing our next speaker. His name is Robert Haas. Robert is a Postgres committer. He's a longtime major contributor. His official title is Chief Architect and Vice President at EDB. And I know, Flora, you know some people who work at EDB as well, including yourself. Before Robert became a PG contributor, he was an application developer for many years, I think almost a decade, running on top of Postgres. So he's been in both chairs, both as a user and now as a contributor and developer. And he's also very involved in the Postgres community. So he gives a lot of talks at conferences. And in fact, last year, he started up a new mentoring program for Postgres contributors, which I think is wonderful to kind of help the next generation of developers who are going to push this database forward. And today, Robert's talk is on something he knows a lot about because he introduced this new feature in Postgres 17. It's about incremental backup in Postgres. Let's go.
Hi, my name is Robert Haas. I work at Enterprise DB, where my current job title is VP Chief Architect Database Servers. And my talk is about incremental backup, which is a new feature that I developed for PostgreSQL 17. I'm hoping that this feature will be of particular interest to people who have large databases and are looking for some new backup and restore options. So in fact, the problem of really large databases and the difficulty of doing backup and restore of really large databases was actually the main motivation for trying to create this feature. I have heard of cases where people had a database that was so large that it actually took more than one day to perform a full backup of the system, which then means that you can't actually have a daily backup because it just becomes not technically possible. So the idea of this feature is that instead of copying the entire database when we make a backup, let's try to copy only the portions of the database that have actually changed. And by doing that, we hope to reduce the size of the backup, possibly quite drastically, but more importantly, we hope to reduce the time it takes to complete the backup because the data that isn't copied doesn't need to be transmitted over the wire to wherever the backup is going to be stored. Now, this is not a new idea. Obviously, there are non-PostgreSQL implementations of this type of feature. And even in the PostgreSQL space, there are various out-of-core tools and proprietary forks of PostgreSQL that have offered this type of functionality in the past. But we have not had anything in PostgreSQL itself that does this. So that was really my goal here. Before I go on, just a brief disclaimer. This is a new feature, and so it might have bugs. In fact, even old features have bugs because pretty much all code has bugs. And the bugs in this feature, if there are any, which is likely, are particularly scary because they are probably data corrupting bugs. So do please try out this feature and let me know how it goes for you. But please also be careful because, it is brand new and things could definitely go wrong. Let's start by looking at what you need to do if you want to take an incremental backup. There is one piece of configuration that you need to do in order to use this feature, and that is that you need to set the new parameter summarize wall to on. The default is off, and this parameter only supports this particular feature. You don't need to enable summarize wall for any purpose other than incremental backup. But if you do want to use this feature, you need to turn it on. And then you need to either reload the configuration, or if you prefer, you can restart the whole database server. Now, once you've done that, you can go ahead and take a full backup, which works just the same way that it normally would. here in this example, I've used the -c fast option, which you would not necessarily want to do on a production server, but I've done it here because this is just for testing purposes. And I've set the name of the directory that will be created by this command to Sunday. Once we've got that backup done, we can go ahead and take an incremental backup based on Sunday's backup. And you see an example of that here in the third bullet point on the slide, where I specify the new -- incremental option to PG-based backup. And as an argument to that option, I provide the path name to the backup manifest from the previous backup on which the new incremental backup will be based. So in this case, Monday's backup is going to be an incremental based on Sunday. So I provide Sunday's backup manifest as an argument to -- incremental. If we then roll forward another day to Tuesday, we now have some options because we now have two previous backups. So Tuesday's incremental backup could be taken relative either to Sunday's full backup or to Monday's incremental backup. We can decide which one we want to do. Now, in this example here, and throughout the talk, I'm going to be showing you examples that are assuming that we are using PG-based backup directly. But that is most likely not what you actually want to do, because this tool only provides the raw functionality of taking a backup and, as we'll see later, also being able to sort of get back to a full backup from the incremental backups that you may have. It doesn't provide all of the other infrastructure that you're going to want to have around the backup and restore process. For example, there is no backup catalog. There is no backup retention here. There is no tracking of dependencies between backups or where any of your backups are stored. And this can all be quite tricky. So I strongly recommend that you don't try to write your own backup tool, but instead you use a high-quality backup tool that supports whatever it is that you want to do with PG-based backup, whether it's this feature or whatever. I'm not completely familiar with all of the backup tools that exist in the PostgreSQL ecosystem. I do know that Barman, which is maintained by some of my colleagues here at Enterprise DB, has added support for this functionality. So that's one option if you want to use this feature. If the backup tool that you're using doesn't support this feature, then you could rethink using this feature, or you could rethink your choice of backup tool, or maybe you want to encourage the maintainers of that backup tool to add support for this feature. But do be careful about rolling it completely on your own, even though all of the examples that I'm going to be showing you in these slides work in exactly that way. Let's talk a little bit about how this works. I just showed you how we can take an incremental backup, but what is really happening there? What is the technical problem that needs to be solved in order for us to successfully take an incremental backup? Well, the core issue is figuring out which data has changed. And we have a few requirements here. The first one, and the most crucial one, is that we need to be accurate. We need to be accurate in both directions, but one of them is especially important. So the really, really important direction is that if we think some data has not changed when it actually did, then the result of that would be that we would not include it in our backup, and so that data would be lost. If we later did a restore from that backup, it wouldn't contain the data that was changed, and there would be no other copy of that data, and that data would simply be lost, which would be very likely to result in a corrupted database. The other direction is slightly less critical, but still pretty important. If we think that some data has changed when it really didn't, that's not going to break anything. It's not going to corrupt our database, but it will make our backups larger. So if that happened occasionally, I guess that would be all right. But if it happens too often, it defeats the whole purpose of creating this feature. So our first requirement here is accuracy. Accuracy is really important. But our second requirement is almost as important, which is that we want this to be efficient. It is going to be really, really important that we're able to determine what data has changed and what data has not changed without too much effort. So, we can't afford at the time that you're trying to take an incremental backup to go grovel for a possibly really large amount of data. We can't afford to look through the contents of the entire database to decide what needs to be backed up and what doesn't, or we can't afford to go look through the entire write-ahead log to figure out what needs to be backed up and what does not, because it will just require too much time and access to too much data on disk. A third requirement that I had here is that this system should be something that is easy to implement. It should reuse as much existing code and infrastructure as possible, partly for my benefit because I wanted to finish the feature in a reasonable amount of time, but even more for the benefit of users, because the more new code and infrastructure has to be introduced in order to support this feature, the more bugs we're likely to have. By relying as much as possible on existing things that are hopefully already well tested and well debugged, we reduce the risk for everyone who's using this feature. And my fourth requirement, a little bit more debatably, is I wanted something that was not going to rely on operating system features. I wanted something that was going to give everybody the same experience, regardless of your choice of operating system, your choice of file system, your choice of hardware, any of those kinds of things. I didn't want to depend on anything special there. I wanted to assume a generic PostgreSQL environment and create a feature that was going to work the same way for all PostgreSQL users. Now, as I thought about these requirements, I realized that the write-ahead log satisfied almost all of them. PostgreSQL's write-ahead log already contains all of the information about which blocks have been modified. And the write-ahead log has a very long track record. It's used for crash recovery. It's used for physical replication. It's used for logical replication. You can use it for point-in-time recovery. You can do all sorts of cool things with it. And it has existing debugging tools like pg-wall-dump and pg-wall-inspect. And it has a very long track record of people finding and fixing problems with it. So it's pretty battle-tested at this point. And it really ticks just about every box that we need to tick in order to be able to have this feature. But it has one very large problem, which is that the write-ahead log is very, very big, which means we really cannot use it directly to power this feature. Between the time that you take one backup and the time that you take a later incremental backup based on that earlier backup, you might generate hundreds of gigabytes of write-ahead log records, or even terabytes of write-ahead log records. And going through all of that data is simply going to take too much time. So that's not really an option. So what I chose to do is add a new wall summarizer process, which will read the write-ahead log as it's generated and produce very, very small wall summary files containing only the information which is absolutely required to drive incremental backup. It turns out that the overwhelming majority of what's present in the write-ahead log isn't actually needed in order to power this feature, because the write-ahead log will tell you exactly how each data block was changed, and it will tell you in exactly what order blocks were changed, and it will make a record of each time the same block was modified, even if that block was modified over and over again. And we don't really care about any of that for our purposes here. The only thing we need to be able to do is answer the question between one backup and a later backup, was there at least one modification to a particular data block at any time during that window? So by taking advantage of that, we're able to go through the very large volume of data that's present in the write-ahead log and essentially compress that down to the much smaller amount of information that we need to power this feature. So the point is that those wall summary files, which are created by this new wall summarizer process, taken together with the backup manifest, gives us everything that we need in order to identify changed blocks and files. And that's how we're able to take the incremental backup both quickly and also correctly. Now, the next challenge is, how do we go ahead and restore that backup once we have it? Let's revisit the scenario that we looked at earlier, where we've got a full backup on Sunday, an incremental backup on Monday, and then another incremental backup on Tuesday, which we're going to say is based on Monday's backup. If we think about the state of the world at this point, where is our data? Or to put the question differently, if we want to restore the backup from Tuesday, where do we need to go to find the data that we need for that purpose? Well, everything that has changed between Monday and Tuesday is in the Tuesday backup. And everything that changed between Sunday and Monday is in the Monday backup, and everything else is in the Sunday backup. So we're going to need all three backups to restore, but we don't need the entirety of all three backups. We just need to sort of combine pieces of what is in each of these three backup directories in order to get what we need. And so that's the motivation behind the naming of this new tool, PG Combined Backup, which combines the data that you need from each of the input directories into a single output directory. You can see we run it here with all three of our backups in order from the first one taken to the most recent one taken. And then you use the -O option to provide an output directory, which in this case I called Tuesday full. And I called it Tuesday full because the output of PG Combined Backup is actually a synthetic full backup of the PostgreSQL data directory. And that means that all of the steps that you would need to perform with any other PostgreSQL full backup still need to be performed. And in particular, that means that database recovery is required, and we need to replay all of the write-ahead log records that were generated during the backup, in this case, during the Tuesday backup, since that's the one that we're restoring. All of those write-ahead log records need to be replayed. And there are different ways that you can do this depending on what makes sense in your setup. You can stage those files in the PG wall directory, or you can set primary con info or restore command to either stream those write-ahead log files or recover them from an archive. The details here depend on exactly what you're trying to do and what your environment is. And a good backup tool is going to manage this for you, which is another good reason to use one. But the point I really want to make here is that incremental backup does not let you skip any step that would otherwise be required. It's just an additional step that needs to be performed before you get started with the things that you would normally do as part of a recovery. So just to sum up what I've said in this talk very briefly, if you configure summarize wall equals on, that will run the new wall summarizer process, which will read the write-ahead log and write out small wall summary files. Once you've done that, PG base backup -- incremental can use the data in the backup manifest that you provide in combination with the wall summary files on the server to create an incremental backup. Once you've done that, PG Combined Backup can reconstruct a synthetic full backup from your incremental backup and the earlier backups on which it depends. And then you'll still need to perform recovery as usual. And finally, a backup catalog, backup retention policies, and all of those kinds of things are out of scope for this feature. It only handles the taking of the backup and the reconstruction of the synthetic full backup. For everything else, you do need to rely on tools external to PostgreSQL. So that's all I've got. Thank you very much for watching my talk, and I will be answering questions in the chat. Thank you.
Well, that was awesome. And now
I wrote it in Discord, and I remember sitting in one of the first iteration of this talk and just thinking like, oh, I gotta really pay attention to follow along. And then Robert just explains it in a way that it's so easy to grasp, you know. And I remember me sitting there and watching his slides and go like, okay, it's now Wednesday, so we go back to okay, and sort of like making the mental model in my head. Yeah, really great talk. Thanks.
Yeah, it helps. Some people are good at explaining things. It really does. All right. If you want to give feedback on Robert's talk, there's the URL and the QR code on the screen. We'll keep putting it up after each talk. And you can also go to the Discord, and I'm sure people will be sharing the URL there. And I also wanted to give a shout out to, I host a monthly podcast called Talking Postgres, formerly called Path to CitusCon, but it's now Talking Postgres. And Robert was a guest a couple of months ago on the show, and we spent a whole episode dedicated to talking about mentoring in Postgres and the new mentoring program that he kickstarted about a year ago now. And so it's obviously important, and it was really fun because he walked through his origin story and how he got started. And I got to get to know him a little bit better. So it's over an hour long. You know, we meander all over the place, but quick shout out there. Had to share it. All right. Oh, and more faces of guests. And Flor, you're on there because you've been a guest on the show as well.
Look at that. Like a couple of hairstyles ago, but it's still me.
All right. Yeah, I'm very privileged. A lot of people have come on the show and shared their stories in Postgres, which is pretty cool. Okay, so we have another trailer to share with you, and this is for all of the talks that are going to be in Livestream 2, right?
All
right, let's do it.
Hi, I'm Bruce Vomjan, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hi everyone, my name is David Rowley and I'm a Postgres committer at Microsoft. And today I'm here to talk to you about what's new in the Postgres 18 Query Planner. And this talk is going to be useful for anyone who's thinking of upgrading to Postgres 18 when it's released later this year, or anyone who's thinking of migrating to Postgres and wants to check in on the latest features.
Hi, I'm Jelte, and I work at Datadog, and I'll talk about how PGDB can make your analytics queries in Postgres faster and easier to write.
Hello, my name is Heikki Linnakangas. I am going to talk about how we made Postgres serverless at Neon. Stay tuned if you want to hear how do cloud providers run services in behind the scenes.
Hello everyone, thank you for joining my session today. My name is Shinya Kato and I'm a database engineer at NTT Data Japan Corporation. Today I will talk about Postgres extensions. The title of my talk is Can We Use Fast to Develop Extensions for Postgres? If you're someone who's passionate about Postgres extensions development or curious about how Rust fits into the picture, this presentation is for you.
Hi there, I'm Johannes from Mercedes-Benz R&D in Sindelfingen, Germany. In my session about Azure PostgreSQL, I'll dive into details how you can make your database more secure. And I will focus about network security and access management. I'll cover all the basics and explain how it works together. So no prior knowledge is required. I want you to be ready to build your own solution in this space.
Hello everyone, myself Palak Chaturvedi. I am a software engineer at Microsoft.
Hi everyone, myself Nitin Jadhav. I'm a senior software engineer at Microsoft. Today, myself and Palak are going to talk about debugging data corruptions in PostgreSQL, a systematic approach. We will explain our experience on handling corruption problems first, and then we will summarize with the approaches to handling corruption cases, including best practices. The attendees can apply these techniques to avoid corruptions at first place and also learn how to detect and recover from the corruptions if it happens.
Hello, I'm Ashutosh Bapat, major contributor to PostgreSQL. I'm part of PostgreSQL contributors team at Microsoft. Today, I will talk about logical replication, which is a relatively new PostgreSQL feature, and it receives a lot of improvements in every release.
Hello, my name is Polina Bungina. I work as a senior software engineer at Zalando, a European e-commerce platform. But I'm also a co-maintainer of Patroni project, and today I want to share with you some insights about how it works, which might be helpful for everyone who is building or operating high availability for PostgreSQL.
Hello, my name is Silvano. I work on Postgres in Microsoft Azure, and I'm here today to talk about .NET and Postgres as the next open source application development stack for your solutions that can run on your on-prem, cloud, mobile, and many other platforms and interacting maybe with the next-gen AI models that Azure is providing.
Hi everyone, my name is Noël Portillo. I'm a Principal Technical Product Manager in the Azure Database for PostgreSQL team. In this session, I'll be introducing a fantastic feature in which we keep investing to extend its scope and evolve its functionality. You're interested in this session if you're a system engineer, a developer, or a database administrator who is struggling with performance issues.
I love these trailers. I feel like I'm in the cinema, and it really gives you a taste for what we can expect for the second live stream. Yeah, and actually one of our next speakers is going to be a host with you, Claire, for the second live stream as well.
Tonight.
Yeah,
live stream too.
Tomorrow, tonight, depending on where you're based in the world, I guess. Yeah, so let's get right into it. So Boriss is a Postgres solution architect at EDB, my esteemed colleague. He has more than a decade of experience in distributed self-managing systems and software and systems engineer. Boriss absolutely loves music. If you've ever seen any of his talk, he talks about music a lot, makes a lot of references to all kinds of music, especially metal music. But he also enjoys playing the air guitar and the actual guitar with his band Trascendinos. And I was lucky enough to witness that once, and that was quite an experience. Definitely can only recommend. But we're not here to talk about music today. This also isn't Boriss's first Posette rodeo. Like he talked at previous editions as well, like what's going on with synchronous replication at last year's conference and support in the darkest hour 2 years ago. And he appeared on the Talking Postgres podcast that you just talked about as well, Claire, to talk with Alvaro about why one would even give talks at Postgres conferences. So if you're curious about the answer why, then you can listen to that on talkingpostgres.com. All right, and then his co-speaker is Sarah Conway. She's a DevRel specialist and technology evangelist with over 12 years of experience in that field, with a significant focus on anything open source and, of course, Postgres in specific. She's currently working as the head of developer relations at DataBena, and has also her own DevRel agency, Talk to Me About Tech. Sarah is also the founder of an animal nonprofit, To Rescue, super cool, and is a musician as well, for over 20 years playing the violin. So that's really pretty cool. Sarah is a big fan of virtual conferences. We're talking about it in the Discord channel as well, that it's so great that we're giving out swag, even though this is not an in-person conference. And the three of us, actually, Boriss, Sarah, and I, are all conference organizers as well. So PGDay Lowlands, that's coming up in September in the Netherlands, is something that we all help organize. Anyway, back to the talk. We're going to talk about Cunning schema design with creative data modeling, and through storytelling, which both of them are incredibly good at. We'll learn some data modeling principles that you can start applying to your current and future project right away, or so they say. So let's get started.
Hey, hello, my name is Boriss Mejias in the role of Monica de Bea.
And I'm Sarah Conway in the role of Evelyn Cates.
And the reason that we are saying in the role of is because this is going to be storytelling. We are going to tell you the story of a developer who comes and seeks help from a DBA who knows a lot about databases, and together, combining their knowledge, they are going to be able to provide data integrity through data modeling.
As you can imagine, if you're an application developer or a DBA or anyone in between, even if you're just interested, you can definitely benefit from this talk.
And we promise that no animals were damaged during this story. Hey, hello, and thank you for joining us in this storytelling. I'm a solutions architect at EDB, and I'm here together with Sarah Conway.
And I'm a DevRel at DataBin.
And we're going to tell you a story that is being supported by the fantastic illustration of Scarlett Ricks. And this is going to be the setup to investigate how people collaborate, actually. And one of the things that's, for me, it makes this presentation kind of very interesting is that I was listening to a podcast recently targeting developers, and there was somebody saying, well, I know that this is going to be very unpopular, but I think databases are cool, which kind of surprised me because apparently within the IT world, we are kind of considered boring and too static. So therefore, we believe that this kind of stories is also going to help people to see that development is not just the application part, but it's also integrating the stuff together with the database. What do you think, Sarah?
I think it's something that I've seen quite often, which is why in this story, we're going to be starting out with Evelyn, who believes that everything can be done accurately and reliably at the database level, at the application level, not the database level. She's actually done several projects exactly like this. However, as she starts putting together this particular application, she realizes it's a little bit more complex than she initially thought, and her code is quickly growing out of hand. So because her manager tells her that she should be using Postgres and she has no idea really how to get started, she goes forth and sets out to meet the DBA team, where she's expecting to meet your typical grumpy support engineer. And what does she find? Just Monica.
So Monica is there and she finds Evelyn, and hearing that she needs to be using Postgres, she said, well, I'm very happy that you actually don't have to use this legacy database that we have, because then you will really need to have to deal with these grumpy DBAs.
Yeah, I need to implement a web page to track the scores of a chess tournament. It's super simple. I already have a design and everything should be able to be handled within the application itself, but I'm being told that I have to use the database for this. Do you know why? Like, is there a particular reason?
Well, do you want to have some coffee?
Would love some. I just ran out.
Okay, good. So let me tell you, for me, everything is super logical at the level of the database. And actually, I have a friend who said that whenever she looks at the definition of the objects, how they are related inside the database, she can tell you exactly how the business logic of the application works just by looking at the data definition. So maybe this is actually what you're looking at, not just functions and calls and stuff like that, but also how the data actually is connected and integrated together. So tell me more about that chess tournament that you mentioned.
I guess that makes sense. So I'm basically just looking to store data for the chess tournament in the database. I think that's all it needs to be, right? Just like a data dictionary. Typically, I would have been putting this in a couple of different arrays and JSON files, and then just manipulating things from the application level. But I'm not sure how to design this thing so it actually works in the database and actually take advantage of why I'm using it in the first place. From what I've been able to figure out, I need to store at least the player information like the names and contact details, and then all matches and results.
Okay, so let's look together at these objects that you are mentioning. So this is what you see when you refer to the fact that you want to put like the player's information. And what else do you need?
Yes, also games.
All right. Okay. So yeah, I mean, look, Postgres is actually an object relational database. So we also think about data as objects and how they relate to each other. So there is going to be a lot of similarity about the way that you are thinking. It's just that we call them tables and columns instead of objects and attributes. But let's look at a few problems that you have here with your JSON object. And it's not because it's JSON, but it's just because there is no guarantee here in this game that those, by the way, I really love the players that you put here as an example when you're building your first proof of concept. So how do you know that Judith and Maya are actually real players? I mean, you have the other objects that are defined here, but then there is no actually guarantee that the values are actually matching what you're putting there. So what about the unicity of the players? What about if they have duplicate names and everything? I see a few problems there.
I could technically just add on some unique IDs, just code is right in that.
I like that. Unique ID. So let's go to the board. Don't forget your coffee. So I making drawings to understand things, because when we put them visually, it's going to be easier to understand. So let's look at this first object, a chess player. A chess player, as you say, we can have a unique ID. Let's call it a primary. And it can be just an integer to identify it. So every time that we talk about that integer, we're talking about this chess player, which actually has a name. And that name kind of have to be unique. So there is something called a constraint in a database, which is kind of like a negative name, because a constraint sounds like it's something limiting you, like it's not giving you the freedom that you need, which is what the promise of a JSON object, for instance. However, the thing is not really something to limit you, but it's actually to guarantee that a certain property of your data is going to be respected. No matter how much you try to put bad data on it, this is going to be respected. So let's call it a guarantee. And we're going to say that a name have to be unique. How do you feel about
That's pretty handy. I like that.
Yeah, because otherwise you need to do the checks at the application level. Now, in this case, we check the integrity at the database level. And then we are also going to have some games between players, you said, right?
Yes.
Okay. So
yeah,
we
we need to be able to
identify
handle at least white and black.
exactly, yeah, 2 players, white and black. That refers to actually the real player. So we are going to have here what we call a foreign key. So this number has to exist. And this is how we are going to guarantee that whoever is playing the game, it is already in the database registered as a player for the tournament. And then you have a result, probably, right?
Yeah, I was thinking at least text, since we have to accommodate, I think at least, obviously winning and losing, probably a draw, a tie.
Yeah, okay, yeah. Well, we don't have to define that specifically right now. Let's see how we start with these 2 tables already. And then my impression, and this is also from feedback from friends, because I always go to conferences and talk to my friends, they say that a solution is not the best one just because you get it perfect from the beginning, but it's one that allows you to delay some of the decisions for when the problems appear. So it's going to evolve together with your understanding of the business logic and also how the application itself evolves. So let's see. How would you code this? First of all, it is a big important advice to not use the default schema called public, because then that will give you a possibility of organizing your objects in different namespaces. So let's call it chess, because it's a chess tournament. And then it also reads most nicely your objects. In this case, we're going to create chess players. So the chess player is going to have an integer, which is the primary key, and a name. And then we're going to add this unique guarantee to say that you cannot put 2 players with the same name. You want to try it out?
Yeah, let's give it a try.
Okay, so how do you insert the data? You go, this is SQL code, but there's definitely something that can transform your application to SQL code. You insert into the chess players the values 1 and Judith, and then the values of 2 and Maya, and then you have your 2 first players. Now let's try to put a duplicate. If we insert, for instance, a 3rd player called also Judith, then you're going to have a violation of this constraint, which means that it's guaranteeing you that you cannot put bad data on it.
Nice. I can see why that would actually save quite a bit of code and prevent problems, a lot of them.
Yeah. Okay. So let's look at now at the things that you can do with this first code. I'll let you go and figure it out a little bit later. And then whenever you need some help, just come and let me know. But
cool.
Anything else you want to check first?
I think the next thing would have to be defining the results, right? So we have to figure out, is that going to be text or integer, or what's the best way to handle that?
Oh, yeah, that on the table, of course. So we do have the, again, it reads naturally in the same schema, chess. We have chess games, and then we're going to have a primary key to identify it, a timestamp with the time zone so that we know maybe if you have the tournament in different places. And then the foreign keys here, it says, this white number is going to reference a chess player, its ID, and the black player is also going to reference in another player over there, and then you get the result. And like this is going to allow you to score your games. Okay, at this moment, Evelyn went to have some fun with the code and started to see that she needed to just insert some of the data and with that, she will be sure that the data will be guaranteed to have some certain rules of integrity. But after some tested, she realized that she had some issues, some problems, and also that she had some new requests coming from the people who requested her to work on the chess tournament. Yep. So she came to talk to Monica and says, I have a problem and I have a request. So Monica said, before we go to the request, let's see the problem. And before we see the problem, let's have some coffee. Once the coffee was ready, they investigated the problem. So Evelyn, what is the problem?
So I tried inserting the same name, but in all lowercase. And guess what? I can actually find that the duplicate names are now fine in this case. Why isn't that constraint working anymore?
Oh, that's true, because we just say unique in terms of a value of a text, which means that we don't actually verify the lower cases. It's not case insensitive. Well, there are two ways of fixing this. One would be to use a different data type, which is called case insensitive text, but then we need to have a function. But there is another way of fixing this. Okay, anything else that you would like to fix here in this particular part?
I think just the request, unless we should wait on that.
No. Okay, let's see. So, because I was thinking that I let you put the numbers explicitly, so you need to know which one is the number 1, 2, and 3. Whereas in this system, you have the possibility of actually saying that you want to have the numbers automatically generated by the system. This is called a serial. Yeah, like that, you don't need to put the name yourself. You just say insert a new player, and it's going to get its own identifier.
That is not something I normally would work with.
Okay,
Definitely
good.
would be nice. Okay.
Cool. So instead of having this constraint that we had before, we cannot actually say a constraint with a function like lower, because it's just going to put everything in lowercase. We can create a unique index, and that unique index is going to be built using a function, and that function is going to be lower the value of the name. And we are going to say that that index have to have unique values. So we are adding the unique guarantee into the index, which uses a function. So as you can see here, we say create unique index, unique player name on chess players, and we say lower than the name. And this is going to guarantee that you cannot add Judith with lower cases. You want to try?
Yeah, let's give it a try.
Okay, first of all, the insert doesn't require the numbers anymore. So we wipe out the data and we start all over again because we're just at the beginning of the phase of the development. And then you can see we just add values Judith, Maya, and now we want to try to add Judith with lowercase, and we get an error. You see, again, violates a unique constraint saying that the lower name, it already exists.
Okay, nice.
Cool. We fixed your problem. Now, you said that you had a new request. What is it?
Yes. So they added some rules that the score has to be only white, black, or draw. Apparently they were having some issues with mistaken names and similar things like that, just mistakes, spelling errors. So they want to have some way to verify that that is actually what it's supposed to be, right? And then besides that, they did also establish another rule that players can't play against each other more than once. And if they play a second game between them, they have to switch colors.
Okay. So you know already the type of scores that you want to have, and you also want to restrict the amount of games that two players can play. Okay. All right, let's go to the whiteboard. This is what I like. I really like whiteboards. Okay, so there is a way of defining data types in Postgres, so you can create your own type, which is called an enum, and then you list the possible values that you can have. Like that, nobody can put a misspelling of the word black, or put it sometimes in lower cases and upper cases, or inventing results like putting rock, paper, scissors in a game of chess. So to avoid having all the code, you can define your type. You say, my score is going to be an enum type, and it can be only white, black, and draw. And then when you define your object again, or your table, what we're going to say is that the result is not text anymore or an integer, but it's a score. And actually store this very, very efficiently in a 4-byte integer, actually, which refers to the position that they have on the enum type. So what do you think about that?
Pretty nifty. I think that makes sense.
Okay. And what was the other request? I forgot. It gets too much into data types sometimes.
No worries. So players can only play against each other just once when they're the same color, but they can switch colors and then play once again.
Okay, so that means actually that the combination of white and black have to be unique, which means that, again, we are back to the unique constraint or unique guarantees. So we can create one that says that in this data that is going to be stored in this table, there can be only one repetition of white and black. And like that, you cannot play more than one game between the same players in the same roles. Okay, let's look at the code. So first of all, let's create the type. So we say create type score as an enum, and then we put black, white, and draw. And because in transactions, we do have like commit and aborted, and sometimes we also have still running transactions, so it's still not resolved. I guess that in a game, you would like to have a game that is unfinished yet, which can still happen. Yeah. So I'm going to give you that for free. And then we have our column result that now becomes a score. And then we are going to add this constraint, which is very simple. You see, you just say limit the games to be a unique combination between the white and the black.
Yeah? Okay, that makes sense.
Yeah, let's test it. So here we have two inserts of games. So we're inserting the timestamp. We don't need to insert the identifier because it comes from the application itself. We are going to say who is the white player, in this case, number 1. Number 2 is going to be the black player. So we have Judith against Maya, and they are playing on the 13th of March of 2025. And the result is a draw. And this is going to validate actually that is a draw. If that would have been a draw with a capital case, for instance, would have complained that this value doesn't belong to the type. Okay, so we are good with one game. Now let's add another game, and we are again trying to play Judith versus Maya in the same combination. And now white wins. But now it's not complaining about who wins or not. It's complaining that this combination, Judith playing white against Maya playing black, already exists. So you actually put the business logic in a single constraint with a DDL, just like that. And now you don't need to write all this logic on the application code.
That saves me a lot of code.
Good. Excellent. Happy for that. Another coffee?
Yes, definitely.
Okay. So after we have tested the fact that you cannot add 2, let's see what happens if we add the other way, the same players, but now playing Maya playing black against Judith playing white. And in this case, it is accepted because it's the same players, but it's a different combination of colors. All good.
Okay.
All right.
Cool.
Perfect. I'll let you play a little bit with the application now. So Evelyn went there. She had the application working pretty fine. She did the small demo to the people who requested her to have the tournaments registered here. The problem was now that it became a little bit too interesting for other players, saying like, hey, I also have my tournaments. I also want to score them in this database because I want to track everything. Until now, we just have everything in a spreadsheet. So Evelyn, you have more work, they said. So Evelyn came back to Monica and she said, I have a little bit of more requests. I have to put more tournaments and something else.
Yes, they want me to add historical data actually from previous tournaments. And they also let me know that the rule of the maximum 2 games between players is per phase of the tournament because they have to play against each other again in the semifinals and the finals. So yeah. And then besides that too, we need to make sure that we're actually tracking the winners, right? The champion, second, third.
Okay. Got it. Okay. So a tournament then have to be part of the objects that we have, and a game have to belong to a tournament. It cannot be just a game like that. Let's go to the whiteboard again. I like this. Okay. So we have a tournament again with an identifier, very useful. The tournament probably has a name, a start date and an end date. And then, as you were saying, we need to track who is the champion and the runner-up and the third position, right? Yeah. Okay. And so those numbers are going to be what? Just testing whether you're getting this. Are going to be, how do we know that these are players?
I'm assuming we tie this in with foreign keys again, back to the test.players table?
Exactly. The same technique, so we don't need to kind of run code to verify that this number exists on the other side or not, because this is going to be guaranteed by the foreign key of the table itself. and it have to be respected. It's part of the ACID properties of the database. Okay, so we do have a tournament now, and now it changes the nature of the games because the games now also belong to a tournament. And because they belong to a tournament, they need to have a foreign key that refers to that tournament that they belong to. And you were saying that the rule for the games that have to be unique is only per phase, right? So we need to add the phase there. Okay.
Okay.
Good. We keep the relationships between the players as a foreign key to the players table. And then as we see here, let me show you the draw arrow, we can see that the tournaments refer to the players for the champion, runner-up, and the third position. Good. We still keep the same type for the enum. And then the thing that we're going to add now is that this constraint that we set for the uniqueness between white and black, it is actually per phase and per tournament. So only one occurrence for these 4 columns. So the 4 columns combined are going to be your business logic. You just have to say, as you see, this is, instead of being a how to do stuff, imperative programming, it is declarative. You're saying, this is the integrity that I expect. These 4 values have to be unique. And then the database is going to guarantee it for you.
Okay, yeah. That makes sense.
Good. Okay, excellent. So let's look at the code. So you define the tournaments, a serial number for the keys of the tournaments, and then all the rest is just text, date, because we don't need a timestamp. It doesn't have to be as specific as the time of the game. But then we also have references to chess players for the champion, runner-up, and the second and the third place. Now, what we need to do, instead of creating the table again of games, let's do it more dynamically. So we just need to say, alter the table of games and add 2 columns. The first column is going to be a tournament, which just refers to an ID in the other table. And the last one is going to be text for expressing which kind of phase, because some tournaments are going to have maybe multiple phases. We will see if later you need to have also a enum type or something like that. But for the moment, just let's keep it like that. And let's let the database evolve afterwards. Okay, so for the constraint, what we are going to do, in this case, we need to drop the first one that we have for limiting the games, because otherwise we're going to have some conflicts between the 2 constraints, and we are going to add the next one. Yeah, it's a guarantee, where we just put all the columns there. White, black, phase, and tournament have to be only 1 occurrence. And like that, your logic is there. Yeah.
Okay. Wow.
Good.
Pretty handy.
Anything else that you would like to add that you forgot or something now that we are here? Because it's almost the end of my day as well. So
I guess the last thing that I can think of is just, how do you prevent a player from actually playing against themselves?
Okay, that's a good one. We haven't put a constraint there. So instead of solving it myself, I'm going to give you as a homework to do it. And then you come up with a constraint or the index that you think is going to be necessary. So like that, you're learning now SQL, Evelyn, so you can do it. I'm pretty sure that you can do it. Now, let me think about something else, because one of my friends, she plays a lot of chess, and she said that sometimes there is kind of a frozen situation and it's not a real draw. She says that is called a stalemate. So why don't we add this extra value so we can see that the type actually can also be a little bit dynamic, in the sense that we can add things. Unfortunately, we cannot remove things from this type. There are some limitations, but as soon as we discover that there are possible values, we can add some stuff. So there is something called a stalemate in chess that we can just add it to the system. All right. So I'm thinking we have done a lot of integrity. We have done dynamic evolution. Why don't we just put all the computation also for your tournament to define who is the winner, who is the runner-up, and everything, and how to count the points for the games if they receive either 1 point or 0 points or 3 points, and we can have a view maybe, or a materialized view, or a function, or a stored procedure, so that everything is computed into one single query. Do you want to do that, Evelyn?
Weren't you just saying you're almost at the end of your day? That kind of sounds like a lot. I technically already have logic for this. So the main part that I was struggling with was just guaranteeing the integrity of the results and just preventing any kind of mistakes, especially as the application receives input. But in terms of actually figuring out all of that, I can do it in just a few if statements, just a couple lines of code. So if it's unless it's going to simplify things more, I think we could just handle that directly in the application itself.
Well, if you're sure about that, I think that's yes, okay. We can keep it on the data integrity on the database, and you figure out how to do all the other calculations that I guess are much easier in the application level. Fine. Okay, fine. Okay, good. All right. I think that we have a nice data integrity anyway in the data model. And if I look at the tables that we have created or the objects, and I see the relationship between the objects and how we guarantee some properties of the attributes of the object, I think I can, without looking at your code, understand a lot from your application just by looking at the data model design. I think this has been a nice experience. I'm super happy with it.
Yeah, I learned a lot more than I thought, and I definitely am feeling a lot more open to using databases now and understanding that they can actually save me a lot of time and risk and code.
Yeah, a lot of code. So the code will be there, but then not all the code probably, because there's some stuff that are also might be easier just to do on the application level. Right.
It's always good to have a balance.
Exactly. Good. Talking about balance, do you want to have a good balanced coffee with the right amount of acidity and the right amount of caffeine on it?
I think so.
Good. Thank you very much for listening to our story. And I hope that you enjoy with us the dynamics of collaborating with people from other teams and understanding from each other the requirements and how we can build a better application, not just at the application level or not just at the database, but in a combination of them.
Yes, and you can always find us on LinkedIn afterwards. Connect with us, especially if you have any questions about that bit of homework or anything else related to the talk.
Yeah. Thank you very much.
Thank you. Bye.
That was such a nice collaboration between Sarah and Boriss. I loved it.
Yeah, it's super fun. Definitely want to have more coffee after this. And I was debating whether or not to do it since it is approaching 7 p.m. my time, you know? Yeah.
So the artwork by Scarlett Riggs, have to give that a shout out.
Yeah, that was incredibly nice. Yeah, very good looking.
And as you mentioned when you did the intro, Boriss has done this storytelling style of teaching people about Postgres and about SQL, in this case, data modeling before, and always with the Scarlett Riggs artwork, which I think is pretty beautiful. So, but this is the first time partnering with Sarah to do this, as far as I know.
Yeah, I think so too. I wanted to just shout out some of the things that are happening in Discord. I really hope, by the way, there is a Postgres chess club that either Boriss or Derek or anyone else involved in the chess club, make sure that they drop a link in the Discord so other people can join as well. I really enjoy seeing people at Postgres conferences play chess tournaments against each other. And now, as it turns out, we might have an app to track all of that too. So that's pretty good. I saw someone in Discord also already thinking up the schema design for a 3D chess from Big Bang Theory. I'm a little scared, to be honest. I'm really hoping that's not going to make like a second edition of this talk for next Posette, but I don't know, who knows. And then one more thing is, well, while Sarah and Boriss are my co-organizers for PGDA Lowlands, during this talk, actually, the schedule for Lowlands went live. So you can go to pgda.nl right now and find out what kind of talks we have lined up for that conference. But that's only in September, and we have a couple of live streams to go still.
Yes. So there's more to learn from here today. And I'm guessing there might be a little bit of overlap because, obviously some people present at more than one conference. So, but I'll have to go peek at the schedule. I haven't seen it yet, so I don't know. I put the links and the QR codes on the screen. If you're looking to give survey feedback, speakers love it. Event organizers love it. So that's there as a reminder. And I think we're going to roll another trailer. Now, this is the trailer for Livestream 3, which is happening this same time zone, this same time on Wednesday, the 11th. So starting at 8 a.m. PDT. We've got 11 talks again. Let's see what we're going to get tomorrow.
Hi, I'm Bruce Vondra, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hello, so I'm Chris Ellis, the head of technology at Next Team, and I'm going to be talking about fun with UUIDs. So this is a talk about the kind of pitfalls and advantages of using UUIDs as primary keys instead of just standard database sequences. So this kind of talk is really for any kind of application developers who might be working on multi-tenanted, say, SaaS applications, where the advantages of using UUIDs will probably be out benefiting the kind of problems that they cause.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and today I'm presenting Managing Postgres at Scale, Challenges, Tools and Techniques. So I'm going to be talking to you about some of the things that you might encounter as you work with Postgres at scale, whether that's managing huge databases, whether it's managing many databases with large numbers of users or high transaction throughput. And we'll look at some of the things that you can do, some of the tools that you can employ to make that easier. So please stay tuned.
Hello everyone, my name is Alexander Kukushkin and I work as a principal software engineer at Microsoft. I'm a Postgres contributor and today I'm going to talk about synchronous replication in Postgres and some myths and truths about it. If you are application developer or DBA, this talk might bring very interesting insights about these topics.
My name is Varun Dhawan. I'm a principal product manager here at Azure Database for Postgres team at Microsoft. Me and my team, we work on building Azure Database for Postgres Flexible Server, which is our flagship managed server offering. If you are using Azure Database for Postgres Flexible Server or planning to use it, this will be a great talk, to stick around. So see you there.
Hey everyone, I'm Jimmy Zelensky. Today I'm going to be talking about implementing strict serializability with pgexact. If you're interested in correctness and the internals of Postgres, this is the talk for you.
Hello everybody, I am Krishna Kumar. I work as a group engineering manager at Microsoft, working on PostgreSQL open source as well as the managed service side of things. Today, I bring to you a talk called PostgreSQL and Linux kernel interactions. In this, you will learn a lot about the internals of how Postgres interacts with the Linux kernel and how to look at this, how to debug this, and a lot more. Welcome and come watch my talk.
Hello everyone, my name is Sarath Balajapalli. I'm a Principal Engineering Manager at Postgres, Azure Postgres team. Today I'll be talking about Postgres partitioning challenges. My talk would be useful for database administrators and database developers. So let's get started.
Hi everyone, I'm Neeta Goyal, CEO at Newt Global.
And hi everyone, I'm Sandeep Rajiv. I'm the Sales Director at Newt Global.
Today, we will be talking about migration considerations to go from Oracle to Postgres. If you are considering migration from Oracle to Postgres, this talk is for you.
Hey everyone, my name is Abe, and today I'm going to be talking about building intelligent applications with graph-based RAG on Postgres. If you're someone who's already built a RAG application or want to learn more about making your RAG apps more accurate, this is a great talk for you.
Hi everyone, my name is Toyo Valley. I'm a Microsoft MVP on Data Platform. Today I'll be talking about Azure Database for PostgreSQL, 15 essentials for compliance and security. If you are using Azure Database for PostgreSQL, doesn't matter if you're a veteran or if you're new, you should be listening to this talk.
Okay, so I just like trailers, I guess.
I do like when Bruce says like, I have many slides. And I'm like, yep, you're known for having many slides. Let's go.
He's a prolific presenter and a brilliant presenter too, Bruce Momjin. All right, our next speaker is Tomas Vondra. I get to do the introduction this time. Tomas is a longtime Postgres major contributor and committer. He works at Microsoft, and it's fair to say he's expert in lots of things, including performance. He also gives a lot of Postgres conference talks. He's pretty generous with sharing his expertise. He is an organizer of the P2D2 annual Postgres event that happens in the Czech Republic in Prague. And at the recent pgconf.dev conference in Montreal, he was actually one of the organizers for the advanced patch review session, which I thought was pretty awesome. And his talk today is about performance archaeology and 20 years of improvements. And with that, drum roll, let's dive in.
So, hello, my name is Tomas Vondra. I work at Microsoft. I'm a long-term Postgres contributor, developer, and also a committer. And I'm here to talk about performance archaeology, which is an overview of how the performance of Postgres changed over the many years of development. So if you are interested in performance and are a user or a developer, this talk might be interesting for you. Okay, so let's go to the slides. The agenda of this talk is very simple. First, I will do introduction. I will explain why I'm actually doing this, why I'm interested in this topic. And then we will go through two different types of benchmarks and results, where I will actually show you some charts with the results and compare the different releases of Postgres on the same hardware. So you can actually make judgments of how the performance changed. And in the fourth part, at the very end, I will maybe speculate a bit based on the results that you will see, what might happen in the future, right? What possible improvements to expect or not to expect. So let's go. So first, why I'm actually doing this benchmark? Because I think the topic is actually interesting for developers, right? If you are developing a database and maybe even focusing on performance like me, you might be asking, how did we actually improve the performance over the many years? And that's actually quite tricky question to answer for long time periods. Because typical development benchmarks that we do for patches as we work on them, we usually only compare like two commits, right? Before the patch and after the patch. And even those benchmarks may be actually very focused on small piece of code. Like it might even be like a micro benchmark only. So it's difficult to combine these like small measurements into something covering a long time period, right? Because the improvements may not actually just combine by simple addition. Sometimes people actually do large benchmarks after the release, right? But even those are only comparing like two releases, right? The old release and the new release. So it's not just for a single patch, it's for all the changes between those releases. But it's still difficult to combine that, because if you have tests for many releases, those will be on different hardware, right? So it's not really easy to combine those. And sometimes people actually use application performance, right? What they observe in the application monitoring to make judgments about performance of the database. But that also has issues, because the application also changes over the years, right? You are also likely to do hardware upgrades and so on. So it still has all the problems of actually getting a good overview over long time periods. So that's why I decided to do this benchmark, to kind of like inform myself about the performance improvements over the, last 20 years of development of Postgres. And that's what I'm going to present here. And I mentioned that it's not entirely fair
even if I do like completely new set of benchmarks, it in principle, it can't be fair to all the releases, right? Because the development happens in the context of the current hardware. So 20 years ago, we had much less RAM available, fewer cores. We didn't actually have flash drives back then, right? We had the spinning drives. And that means that no one actually optimized for that kind of hardware, right? So if I take the old releases and run them on completely new hardware, that just can't be completely fair. There's a lot of stuff that actually improved outside Postgres, right? So for example, we are not on kernel 2.6 anymore, right? The file systems that Postgres relies on also improved significantly, and so on. So in the benchmarks, we actually see all the, and users, when running the applications, they all see the compounded effect of all those improvements, right? So it's important to keep this in mind. So for the benchmarks that I will show in the next sections of this talk, I have used like two machines that I have at home that I use for benchmarking quite often. The first one for OLTP is roughly 10 years old, 2-circuit machine with 44 cores, 88 threads. So it's like reasonably powerful machine, especially for high concurrency workloads, which for OLTP is important, right? It's like a mid-range server from that time period. And it's also roughly halfway through the time range that I want to cover, right? I mentioned that I want to show results for the last 20 years of Postgres development, and that's like 2016 is halfway through. And it's running, of course, like the current version of Debian. It's running on EXT4 and so on. The machine that I will be used for the OLAP benchmarks, for the analytics workload, is a bit older and it's also a bit smaller. And the idea is that I don't need such concurrency, right? I don't need that many cores to actually analyze improvements in analytics. So it also is using like SSD drives, the same type of operating system and all of that. And it's of course also like roughly halfway through the time period. So let's do some benchmarks. And I have to warn you, there's going to be a lot of numbers and charts. You can go to the slides later, of course. So first, I'll talk about OLTP. And for OLTP, I use the traditional dataset, traditional benchmark implemented by pgbench, which is TPCB. And I did test that on a range of different configurations, right? I tested that with like small data set, medium data set, large data set. The small one fits into shared buffers, medium fits into RAM. The large one has to do a lot of I/O actually, right? And I did that in like read-only mode, read-write mode. I'm going to present here only a couple of those results that I think are clear and can, illustrate the points I'm trying to make. The runs were quite short, only a couple minutes, because exactly there have been so many combinations that I've been testing that I couldn't do longer runs, right? One thing I need to mention is that I started with Postgres 8.0, and back then we didn't actually support shared buffers larger than 2 gigabytes. So I needed to use a configuration which is like the same for all the releases, right? But the pgbench that I'm using to run the benchmarks were always from Postgres 18, from the development version that at that point. And the reason for that is that we are also improving the pgbench tool, but that's not what I want to benchmark, right? I want to benchmark the database, so I'm using the newest version with not as many bottlenecks. So the first chart I want to present is for read-only PG bench on the small data set, the scale 100, which means roughly 1.5 gigabytes on disk, which fits into 2 gigabyte of share buffers. And this is like read-only benchmark. And you can see, and each of those lines is the throughput for certain client count, right? So for example, the blue, which is almost horizontal with the x-axis, that's for a single client. The yellow one, for example, is for 32 clients. So the first thing you can notice is that for the older releases, and we are starting with Postgres 8, and then there's 8.2, 8.3, and so on the x-axis, that was quite bad, and we didn't actually get much scalability from higher client counts, right? The throughput kind of got stuck at 32 clients, and we didn't actually get better throughput with more. And the machine actually has like far more cores, right? So that's not great. But this actually improved significantly in 9.4 and 9.5, right? And it also fixed a couple strange behaviors in like 9.2, 9.3, where you can see this. The thing you should notice there is that there are actually inversions, right? By increasing the number of clients, the throughput actually completely craters, right? So the best throughput you get with 32 clients, and then if you increase the number of clients for the database for pgbench, it just drops to, I don't know, 10% of that. And that's a clear sign of concurrency issues, right? Locking or something like that was happening. But we fixed that in 9.4 and especially 9.5. So that's the first thing you should notice. And then since 9.5, the throughput is actually quite stable, and there are no significant improvements since then, simply because we improved, we got most of the improvements back then, right? If you look at the largest data set, which needs to do a lot of I/O, you will see something like this. You will also see some significant improvements early on between like 8.0 and 8.4. And since then, we didn't get much speed ups, right? There are some small improvements or like noise in the results, but that's mostly because of the short runs, right? Each run had only a couple of minutes, which is not enough to get like perfectly stable results from the benchmark. Of course, the results, the absolute numbers are much lower than for the read-only benchmark, right? For the small data set. For the read-write, and this is like the smallest data set, only 1.5 gigabytes fits into shared buffers. But you can also see significant improvements between 9.4 and 9.5, and especially 9.6. We are doing much better in each of those benchmarks than we did 20 years ago. It would be strange if we didn't, right? In this case, there are no clear inversions of the throughput. Like, you usually get at least the same throughput as with the lower client count, which is good. So those were results for the usual like TPCB workload, but that's extremely simplistic and not really representative of OLTP applications that actually are executed or operated on Postgres, right? Because, for example, TPCB doesn't even do joins. It's essentially just lookups by primary keys and nothing else. And I would bet that even if you are running OLTP applications, they do joins or small aggregations, or like accessing data by secondary indexes and stuff like that. So one thing I tried during the benchmarks is actually to do something more complicated, right? And the thing is OLTP star join. If you are familiar with star join from analytics, where it usually joins like a fact table and multiple dimensions, like small tables, then this is almost the same thing, except that there's also a clear restriction on the fact table, like usually by primary key. So you can imagine that something like this. It's a large table, which in this case is called T, and then a number, in this case 10 dimension tables that are joined by like primary key, foreign key relationship. This is actually a very, very common query pattern, right? It usually means you are looking up something about a customer or a transaction or something like that, and then you are enriching the result with additional information, but you are not placing conditions on the dimension tables themselves, right? Those are just like lookups. So if you assume an OLTP workload doing this kind of query, looking up in the primary in the fact table by primary key, and then adding information from other tables, you might see throughput which looks like this. It's also executed by the PG bench, but it's a custom script executed through the tool. It's not the built-in workload. And you will see throughput something like this. The first thing you should notice is that the throughput is actually unexpectedly bad. It only does like 2,000 transactions per second. And it only does that no matter what the client count actually is, right? Like with 16 clients, you get 1,000. Then with 32, you get like close to 2,000, and it doesn't actually scale very much. The other thing you should notice is that it doesn't really change over like significantly over the 20 years, right? The throughput that we've been able to do 20 years ago on this hardware is roughly the same, in the same ballpark that we can achieve today. So there's no significant improvement. This is, however, the simple query mode, which means that each execution of the query needs to do planning, right? So first, what if we did a prepared statements? And you will see something like this. You will see significant improvements over the years, and also much better throughput over compared to the simple mode. In this slide, I highlighted a couple of the biggest improvements and associated them with the patches that actually improved that. In between 9.1 and 9.2, we have seen some locking improvements. Between 13 and 14, there's a question mark, but that means there are multiple patches that contribute to this, and those are related to scalability of snapshotting, right? Snapshots determine the state each session actually sees the database, right? So they are essentially the MVCC view of the database. And then between 17 and 18, there's another improvements to the fast path locking. So we did actually improve this, but the simple mode on this chart did not improve. That tells us that the bottlenecks are in the query planning, right? Which the prepared mode doesn't need to do. So to sum the OLTP benchmark, we have seen some massive scalability improvements over the many years. It's often in the 20 to 50 times improvement for many clients. There are some small regressions with only a few clients. That's a trade-off between scalability and throughput for a single client, for example, right? The main improvements were fast path locking in 9.2, many improvements in 9.5, 9.6, and so on. There have been some weird inversions in 9.4. Those are mostly gone, and it's mostly clean. But we seem to be out of low-hanging fruit, right? I do expect like mostly small improvements for especially these simple workloads like the TPCB. Right. So that was OLTP. Let's look at OLAP. And for OLAP, I used TPCH, which is a well-known benchmark. I used a very small data set, like 10 gigabyte size. It actually expands to much more on the disk, to maybe twice the size, with indexes and overhead additional. If you don't know TPCH, it does 22 queries, stressing different parts of the query execution. And I also tested, of course, like the data loads, right? Ingestions of large amounts of data. If you want to learn more about TPCH, look at the paper that I mentioned on the slide. It's a very nice explanation of an analysis of the TPCH queries. So first, let's look at the data load. And in this case, it's not throughput, it's the actual total time for each step of the data load in seconds, right? On the x-axis are, again, versions of Postgres. The special labels with P means parallel, right? In Postgres 9.6, we introduced some sort of parallelism, and then we improved and extended the support for that in following versions. And that also helps, for example, index builds, right? So first you can notice that it's much better than it was in 8.0, right? In 8.0, it took almost like an hour to load 10 gigabytes. Now it takes maybe, I don't know, 1,000 seconds, right? So it's like 15 minutes to load the same thing. So it's like 4 times faster, roughly. And you can also see which parts of the data load are responsible for the improvements, right? So you see that the copy got much faster. That's the blue. Then the yellow, which is like the most expensive part, is building indexes. And we can see that actually improved significantly too. The parallel index builds introduced in Postgres 11 also like improve. They remove like 1/3 of the duration, right? And since then, it's mostly stable. Like we don't see any significant improvements in that. Of course, if you are running an application, you have been probably upgrading hardware, right? Getting more powerful stuff. So that's what you would see also. For the queries, and this is the total duration of all the 22 queries just summed together, right? You can see that there have been some significant improvements between 8 and 8.2, where the duration dropped to like 50%. Like so, it got twice as fast. Since then, there have been some significant improvements over the years. I also again labeled some of the steps to associate them with the improvements that I think are responsible for that, right? So we have seen some improvements from prefetching. We have seen some improvements from index-only scans that have been introduced in 9.2, and so on. Parallel queries, is what was introduced in 9.6. You can see again some small improvements from that. And since then, it's mostly stable, right? So we haven't seen like significant improvements for these 22 queries since Postgres 9.6, 10, something like that. So when benchmarking this, I also saw, I noticed a couple like what I call apparent regressions, where the performance actually got a bit worse. Those are actually not regressions. They are caused by changes in, say, default values, right? And suddenly you need to adjust that during an upgrade. And I have on the slide, I have listed a couple of those that happened over the years. Whenever we modify a default value, this is a risk that we need to face, and you need to be aware of this when upgrading the Postgres to a newer version, right? So you need to go through the release notes. So to sum the OLAP, we have seen some massive improvements over the years. I have listed a couple of the main ones with the associated version. It didn't actually improve. We haven't seen significant improvements since Postgres 11, roughly. I think there are some possible incremental improvements in like small gains, but I think that for actually significantly improving the performance with OLAP, I think we need to do some fundamental changes to how Postgres executes queries and stores the data, right? Like there is a reason why the column stores are much faster. They just use and execute the queries very differently. And we need to adopt some of those ideas to be competitive with those databases. So to sum the talk, I think we have seen some pretty substantial improvements. I do think that we will see some incremental improvements in the future, but for like significant improvements, we need to start to think differently about at least some of the database engine. I'd like also to mention that the performance is not like everything, right? Like the raw throughput is not everything. We also need to worry about ease of operation, especially in the age of cloud, where people are running dozens of engines or of instances and need to operate that efficiently. So for OLTP, there's a number of questions. I'm not going to discuss those. This is more about stuff that you might actually look into, right? So for example, there's a lot of NUMA stuff that you should look into. There is a really nice talk by Andres Freund from PGConf EU from October, listing a lot of those improvements. For OLAP, I think that's what I already mentioned. I think a more radical rethink of the execution needs to be considered. And I think complex plans can get wrong easier, right? We need to update the defaults more carefully. I don't know, but we may need like more better tuning advice, automated testing, something. And that's all for me. So if you have any questions, please write them in the chat.
He did it. And he's on a plane right now too, but somehow he was able to participate in the virtual hallway track on Discord. Thank you, Tomas, for that dedication.
Yeah, and I'm sure he will get back to the Discord too once he lands too.
And if you have feedback, survey links are on the screen, like we've been doing after every talk. Hope it's not getting annoying, but it is important to share feedback. So dropping those links up there.
And it's important to get a new pair of socks too. So, We're actually doing people a favor by repeating this message.
These socks are popular. I need to before one of the next in between interstitial sessions, I'll go grab the ones from last year and show them to everybody.
Oh, I thought this year where you could like really show them.
I don't
while
have
also showing off your beautifully painted nails at the same time. See how I did that? Now
yeah,
we can see them. I love
Yeah.
it.
Okay, I just did Posette colors. Thank you for embarrassing me there. Appreciate that, Floor.
What am I here for otherwise?
Yeah, all right. Well, let's keep going. Obviously, join the Discord. That's where the virtual hallway track is. Ask questions, give compliments, get to know other people in the Postgres community. So speakers are showing up when their talks are broadcast. And speaking of speakers, it's time.
That was a very smooth transition. Yeah, so next we'll have Pamela Fox, who is a cloud advocate at Microsoft. And at Microsoft, she helps developers use Python with the many Azure offerings that are there. So Pamela has taught computer science at UC Berkeley and volunteered in Bay Area classrooms as part of TEALS and Girls Who Code and Coder Dojo organizations. She also started the San Francisco chapter of Girl Develop It, where she taught a dozen of web development workshops. So super cool there. And in building modern Python web apps with Postgres, Pamela will talk us through an opinionated architecture discussing benefits and trade-offs of every decision along the way. Really excited about this one. Let's get started.
I'm Pamela Fox, and today I'm talking about building modern Python web apps with Postgres. If you've ever thought about building a Python web app and you're trying to pick the technology stack, then this talk is for you. Let's get started. So I am a Python cloud advocate at Microsoft, and that means that I spend a lot of my time these days helping Python developers use Microsoft technologies, one of them being Azure Postgres. But I just generally love to play around with technologies and learn new things and share what I've learned with everyone else. So I've actually been building web apps for quite a long time. I dug way back into the Internet Archive, the Wayback Machine, to find my original website from 1998. And it is a classic. I've got a web ring. I've got it optimized for tiny screens. It's called Pammy's Place. It's everything you ever wanted out of a 1998 website, right? Now, don't worry, I did get much classier a year later, as you can see, with my bright yellow website and the declaration. This is not a homepage, more of an online filing cabinet, with lots of fun stuff on that website. So I've always loved building websites. It's one of the first things I discovered how to do on computers. And once I realized I could create websites, share them with the world, I've been hooked ever since. So I, of course, also have worked on professional websites. I was one of the first developers at Coursera in the first year that Coursera came out. Coursera is a online website where you can take university courses. And it was really cool to get to work on that, to get to work with professors in order to deliver their vision. And then from there, I went to Khan Academy. And at Khan Academy, I actually was both a full stack web developer and I was the content developer for computer programming. So there I was both programming the website and teaching people how to program. And that was super fun as well. And both of these did actually use Python as a backend. And that's where I, started really learning about how to build websites using Python. And as it turns out, these days, in 2025, most developers are building web apps. This is a survey I found from JetBrains that they put out each year. And they asked, what are you building? And what we see is the majority of people are building websites. Some people are building a few other types of applications. But at least 42% of people are building websites. It's still a very popular form of software since it works on your, on your laptop. It works on your phone. You could have it be a progressive web app that's, mobile friendly. Just web apps are so ubiquitous. So it's still a very relevant question of how do we build web apps? And this is a question that I actually get quite a bit. Like, okay, Pamela, I want to get into web app development. how do I get started? What technology stack do I pick? There are just so many options, right? So my goal today is to step you through my decision process for how I would build a web app, now in 2025. And hopefully that helps you with your decision process when you're developing web apps. So here we have a basic web app architecture, okay? There's a front end, there's a back end, and there's a database. Now, on the front end, that is going to be coded with HTML, CSS, and JavaScript because those are the languages that browsers understand. Of course, we can use a front-end framework like React or Svelte or Vue or Angular in order to generate HTML, CSS, and JavaScript, but ultimately, that's what it'll be coded in. I'm not going to talk about front-end frameworks in this talk because we really want to go into the back end. And that's really a whole other talk that I've given in the past of how to pick a front-end framework. And it's a hard choice as well. But let's just assume that we're going to use HTML, CSS, and JavaScript in some form. So then on the back end, I am going to use Python. There are many other languages you can use on the back end. You can really use any language on the back end. Some are more popular than others. But since this talk is about building Python apps, we're going to use Python. And then, of course, for the database, we're going to use Postgres. This is a Postgres conference. We all love Postgres. It's a fantastic open source relational database, and it's a really popular and great pick for a database. So we're going to start with this architecture here, but we still have more decisions to make. So we see these, arrows back and forth that shows, we're communicating back and forth between these different components. So how are they going to communicate? Now, the back end with the database, it's going to be sending SQL queries and getting back, SQL results from the database. We know that much. For the front end communicating to the back end, there's actually different ways that you can have front ends communicate with back ends. You can have, back ends render templates. You can have them communicate over APIs. We're going to go with APIs for this architecture. So that means the front end is going to send a request like, hey, give me all the items from the items API. And then the back end is going to return JSON that says, okay, here's all the items. And then the front end will render that data. So we're going to go with what I'm going to call an API-centric backend. So that's how they're going to communicate. We've made that decision, but we still have more decisions to make. Specifically, we need to decide, are we going to use a web framework for that Python backend, and which web framework are we going to pick? Are we going to use an ORM in order to communicate with the database? And what Postgres driver is are we going to use to communicate with the database? So those are the three big decisions that we're going to focus on in today's talk. Let's start with the framework. That's the one that most people start off with as a decision, and it will affect our other options. There are three really popular frameworks that if you're in the Python ecosystem, you've probably heard of. So the three most popular are Flask, which is a fairly lightweight and flexible framework. Fast API, which is also fairly lightweight, but a little more opinionated, and it's very focused on API first development. And then there's Django, which is a very opinionated framework. It's the batteries included framework. So it actually comes with an ORM, it comes with an admin, it comes with lots of things. So very opinionated, but can be really great if you need all of that stuff. And as you can see this is from the 2023 survey, they're all quite popular. Django and Flask have been around for longer than Fast API, so generally more people are using them. But I think if I check 2024, I'm sure the Fast API stats would be even higher now. It's really growing quite a bit in popularity. So those are the top three that you'll hear about the most. But there are other frameworks in that are definitely worth considering. So the two I want to talk about today is Quart, which is an async version of Flask. So it is actually even based on Flask. So if you bring in Quart, you'll get Flask as a dependency. And then there's Starlet, which is the async framework that underlies the Fast API framework. So if you are already using Fast API, you're actually using Starlet because Fast API is dependent on Starlet. So these are two frameworks that we could be using instead of these other three frameworks. So now we have even more decisions to make because there's 5 possible frameworks that we could be picking from. And what you'll notice is that for a lot of them, I mentioned this word async. What is async and why does it matter so much? Let's dive into that because it ends up being actually very important and is going to affect all of our decisions. So async is it's something that we can use in many languages. Here we're going to see how we can use it in Python. And basically, if we're in Python, we're writing a function. What we do is we put the word async in front of a function in order to mark it as an async function. And in this case, we would actually call it a coroutine. Once it's called async, we call it a coroutine. So this is now a coroutine. And if we are calling a coroutine, we need to put the await keyword in front of it, right? So you see here, it says await. That means that this function here is actually a coroutine. So we're saying, all right, wait for the results of this coroutine. And now in order to run this function, we can't just run it the normal way. We have to use this async.io package, which is part of the Python standard library now, and say, hey, run this asynchronous function. So it's a lot of things we have to add in order to turn our functions into coroutines, in order to work with coroutines, but we do get a big benefit from it. So let's look at that benefit. And here I'm actually just going to open this demo. So here you can see I've got async.io, and I'm also using HTTPX for making a call to a web URL. And I've got this coroutine here, which I've marked as async. And what it does is it just fetches this URL and gets that, does an HTTP GET, and gets a response. That's all it does. And then in main, what I'm doing is I'm using this async.io task group functionality in order to basically send off 2 requests to a to these coroutines and send them off and then wait for the responses to come back. So let me go ahead and run this so you can see what happens when we run it. So you notice that it says, okay, fetching this URL /3 and then fetching this URL, which is /1. But then with the received, and this is coming from here, it actually received that second URL before it received the first one because that one was slower. And this is what we can see with async. If I had done this without async, it would have gone off, gotten that, and then come back, and then it would have been really linear, right? But when we're using coroutines, we now have the ability to send stuff off concurrently. So this is we're getting concurrency. So we're sending off these 2 requests, and we're doing it with concurrency so that if this one returns faster or returns earlier, we can actually get that return value first. And that can be really powerful. It can mean that we can write code that's more efficient, that can do things in a shorter amount of time because it's able to actually send off these requests, both send off both requests, and then they can come back at different times. Let's look at that another way. So here we have the function fetch URL. We go and we fetch the slower URL, right? So what happens is that Python goes off and starts making that network request and then pauses. And while it's pausing, it can go to this other and send off this other request for fetching a URL, which is a shorter request. And that can happen while we're waiting for this request to come back. This whole flow can happen as well. And then finally, the slower requests come back. So this is what's really powerful about concurrency is that if the Python code is blocked because it's waiting for a network request like it is here, it's able to work on another coroutine that is waiting and then be able to get more work done while it's waiting, right? So before we would just be completely blocked. We'd have to wait for that network request to come back. We'd be, unable to do anything else. But here with async, with concurrency, while we're waiting for that network request, we can go and send off another one and get more work done, right? We're able to get more work done. Okay, hopefully that makes some sense. And basically, once we're using async, we can get a lot of benefit from it in some situations, right? So if we're doing IO operations, so if we're opening files locally, if we're reading the files, writing the files, if we're doing database calls, like a local Postgres database. All of those are operations where normally Python would have to wait for the response from the system, and it would just be sitting there waiting. And then the other thing that we just saw was network requests, right? If we're making a network request, and especially if that network request is slow, which happens with slow APIs, like modern API requests to large language models can be very slow. You can be waiting for seconds for them to come back, right? If you use async while you make that request to the, the slow hosted LLM, then you can do other stuff while you're waiting for that network request, right? So async is very helpful in those two situations. Now, async is not helpful if our code is doing CPU heavy operations or GPU heavy operations like math. So if we were like running our own LLM locally and, having to do all the math there, well, then that's actually the Python, that's actually Python code, like, it's actually like working there, right? It's doing work, it's not waiting. So then we wouldn't get the benefit from async. But there's definitely a lot of situations where we do get benefit from async, and that's why it's so compelling. So now that we talk about async, let's talk about how we use async with web apps. So first, how do we traditionally write web apps? There's this thing called WSGI, which is the Web Server Gateway Interface, and it is a standard way for web apps to interact with servers. So that means, if you're using Flask or Django or some other framework, they can all interact in a similar way with a WSGI server that can work with your web server, right? So a common setup would be have like Nginx, and Nginx could handle both static files, and then it could send all the dynamic routes off to your WSGI server. And then your WSGI server, the most popular one is gUnicorn. So gUnicorn can run your Flask app or run your Django app. It can run any WSGI compatible app because it knows how to do that. So it's going to forward all the requests to your web app in a common way. So that's how standard web apps work before async. Now, with async apps, we have ASGI, the asynchronous gateway interface, and this can handle both sync and async routes. So, here, once again, we have a web server like Nginx, but it's going to forward the dynamic routes to an ASGI server like Uvicorn, which is the most popular one. So it's the only one I put here. And then that will forward the requests to the ASGI web app following this ASGI standard, right? So maybe that's FastAPI or Quart or Starlet. So what that means is that if we are using async in our web app, then we get the ability to handle many more concurrent requests, right? So this is very similar to diagram what we had before. So let's say we get in a request for API/generate answer, and then that goes off and makes a call to a slow LLM. While it's making that, it can handle another user request. So here it's actually handling 2 user requests and doing that concurrently. And so it's able to handle more than it could have if it was just a WSGI web app. It would have to handle it linearly. So that's what's really powerful about ASGI web app frameworks. Now that we understand async, we can look again at our framework options, and now it becomes easier to pick, right? We want to use async for modern web apps because we're probably going to be making database calls. We're probably going to be making slow network calls. We want to have the ability to have concurrency. So that means we're not going to use Flask. However, we could use Quart because that's the async version of Flask. So that would get us the concurrency. We could use FastAPI because that supports async. We could use Starlet, which of course supports async because it's the underlying framework of FastAPI. Django's the interesting one. It actually has partial support for async. So it would work to make async LLM calls, but it's not fully supported in the ORM calls. So we wouldn't get the async benefit from our database calls. So that's kind of a question mark there. Which one should you pick? This is a really hard thing to say. It's hard to compare all these, but I do have a blog post where I attempted to compare them. But generally one way of thinking about the frameworks is in terms of how opinionated they are and whether you want to work with that opinionated nature or if you think you'd be struggling against it. So generally I would say FastAPI is the most opinionated because it is designed for APIs and it has that in mind. It also has a pretty big ecosystem. You're going to find lots of tutorials about how to do FastAPI because it's so popular. Starlet, I would say, is the least opinionated, fairly flexible, has support for WebSockets, could be a good pick for some sort of WebSocket app. Quart's kind of in the middle. If you are coming from Flask, easiest to port to Quart because you just stick async in front of things and pretty much works. And it does have an ecosystem of plugins similar to the Flask extensions. So that's one way of thinking about which frameworks to pick. I've got a few more ideas in my post there. In general, I would say they're all great picks. I think they're all good picks for different situations, and I've used all three. So I've used Starlet for an app that uses WebSockets. It was a good pick there. I've used Quart for quite a few apps that have both front ends and back ends with templates. And then I've used Fast API for similar apps, especially ones where I really wanted them to be very API centric. Today, I'm going to be demoing Fast API because that's the one that I used for the demonstration. But once again, they're all good picks. Okay, so we've picked our framework. It's going to be Fast API. Now we still need to pick a Postgres driver and ORM. So let's start with the driver. We can look at what are our options here. So these are the three most popular Postgres drivers. The traditional one is PsychoPG2. However, that doesn't support async, so that's off the table because we really want that async functionality. There is a successor to that is called PsychoPG3, but has a package name of PsychoPG, which is confusing. But it is actually the sequel to PsychoPG2, and it does support async, and that's fairly popular because if you're coming from PsychoPG2, then it's going to be fairly straightforward to go from PsychoPG2 to PsychoPG3. And then another option is Async PG, which came about because of PsychoPG2 not having support for async at the time. And if you look at the download stats, you can see that all the drivers are relatively the same amount of popularity, right? Most people are still using PsychoPG2. Most people haven't moved to using async yet. But the two async options are pretty much equal in popularity. So how do we reason about it? One thing would be performance. There's various blog posts and stats that compare performance. A lot of them do see better performance out of async PG, and that could be a reason to pick it. However, you do want to verify that you see those performance gains for your own uses of the drivers too. So for example, someone was telling me that async PG, some of the performance gains are not compatible with PG Bouncer. So if you are using PG Bouncer, maybe that will sway you toward using one or the other because you won't have as great performance gains. In this case, I did go with Async PG, but once again, PsychoPG3 could also be a great fit. So now we've got the driver. Finally, the ORM. Now, the question is, do we even need an ORM? And generally, I do like to use an ORM. I like the abstraction most of the time where I can use a Python object instead of raw SQL. It's nice to have IntelliSense and have type annotations and all that. That's quite nice. I like the portability where that in theory, I could switch between different database backends more easily. I like the security for sure, right? I'd never want to accidentally have SQL injection, and generally ORMs make it, much more secure, much harder to do accidental SQL injection attacks. And then I also like migrations, making it easy to add a new column, run a migration, and have that reflect in my database. Now, I don't always use an ORM because sometimes it can be hard to use that level of abstraction, right? Because as soon as you start using an ORM, you have to translate that SQL query that you know how to do into something that works with that ORM. And sometimes that actually can be really tricky. That being said, I still like starting with an ORM and giving it a go. SQL Alchemy is by far the most popular ORM, dwarfing all the other ones. You might consider SQL Model if you are working with Fast API because it was made by the creator of Fast API. However, last I checked, it doesn't support async, so I won't be using it in this case. So we're going with SQL Alchemy, which does have first-class support for Postgres and support for async. Now we've got our whole web app architecture put together. We're doing Python with Fast API, with Async PG, with SQL Alchemy. Let's check out and see what this looks like in an application. I'm going to be showing you this demo, which does RAG with a Postgres database. It works both locally with a local Postgres, with a Llama if you want to use that. And it also works in deployment with Azure, OpenAI, Azure Postgres Flexible Server, and container apps. And you can get the code for it from the repo linked on the slide. So let's go ahead and check that out. All right, so here I've got it running locally. So I'll go ahead and show you just what the full running application looks like. So I'm asking, basically, I'm a user that's asking questions about products in a database. And this is like basically like I'm asking questions of an outdoor shop. So pretend this is like, REI or your favorite outdoor products website. And, we get back a response that says like, oh, we've got 2 climbing gear options under 30. You can check out this one or this one. And here's all the information. And here's some references, right? So this is what's known as RAG, Retrieval Augmented Generation, which is a popular approach to using LLMs in order to answer questions about our databases. Okay, so this is working. So how does this actually work behind the scenes? Let's take a look at the relevant code. So first, when we set up the Postgres engine, we have to use async PG. So that means we are going to use this special database URI, which says that we're using the async PG driver. That's how we make sure that we're using the async PG driver with SQL Alchemy. And then with SQL Alchemy, we are using the create async engine, which ensures that everything's going to be doing async. So that's our driver and ORM setup. And then we can declare the models using SQL Alchemy classes, right? So here I'm using SQL Alchemy 2.0, and I'm describing this item table and saying like, okay, here's my ID. It's got a brand, it's got a name, it's got a description, it's got a price. It also has embedding columns. These are using PG vector so that I can have vector embeddings for each of these items so that I can then do vector search. And I've got ones for different models so that I can switch them out local versus prod. So that's how we can use the ORM in order to describe our Postgres table. So now I can go and check out the FastAPI docs. So these are the auto-generated docs that FastAPI will make for you out of all your routes. And this is one of the things that people love about FastAPI is that it produces your OpenAI API.json, and then we can make these docs based off that OpenAI API, and it's just made for us, right? So here we can try out an ID and see, okay, this is, that row from the database. Great, that worked. And if we look at the routes, this is what the route looks like. We say, okay, we're getting that ID. Then we're sending off a query using SQL Alchemy. And this is the, the ORM query language here where it says, okay, we're going to select the item where the ID equals this, get that, and return it back. Now, going a little fancier, we can do a similarity search using those vector embeddings. So we say like, okay, give me everything that's the most similar to that product, right? And remember that was a boots product. And so we got back a bunch of boots, shoes. Okay, so those all look pretty similar. That was using vector similarity. So if we look at the code for that, what we see here is that I start off with getting the target item. And then here, what's interesting is that I decided to just straight up use async PG with a SQL query, because in this case, I found it easier to write the SQL query than to use the ORM. So this is one of the examples where I like to start with the ORM, but sometimes I will, go lower level and do a straight up SQL query because it's shorter. It's easier than trying to translate it into the ORM language, depending on what I'm trying to do. So you still have the option to go into SQL if you need it at times. Okay, so that worked. And then we can do a search. So here I can actually type in a query. So I want climbing shoes, and I'm doing both vector and text search. Okay, and then we get climbing shoes, we get running shoes, we get a climbing harness. It's not quite a shoe, but it's related to climbing. And that one is a little more effort. And here I've got a whole class for it. And so once again, in this case, I am using SQL because I'm doing a very complex hybrid search, which is combining vector search and full text search and then coalescing them together and, getting those final results. So I execute that and then, turn that back into SQL Alchemy models. So this is another interesting mix where we're doing both SQL and using the SQL Alchemy where it makes sense. All right, so those are the basic API calls. And then there's a final API call, which is the one that's used by, the actual front end. in order to answer these questions. And so that does the search and then sends it off to an LLM and answers the question. But there you go. That's basically how it all works. We've got the routes, we've got the driver, we've got the ORM, and we can use them all together in order to create this application. So you can check out code if you want to dive more. So now some final thoughts. Hopefully now you know a lot more about your options and have some ways of thinking about them and realize the importance of async, because a lot of people aren't thinking about that right now. I just want to really make sure people are thinking about async and the benefits of it. But there's, of course, many other things to consider besides that, right? You always want to think about security, how well maintained some things are, how nice the community is. The Postgres community is super nice, right? How accommodating they are, how great the tutorials are, how extensible they are. So many different decisions go into picking your technology and stack. And it's important to, know what's important to you, know what all the options are, so that then you can decide. And if you do decide, pick something and you have an experience with it, I do encourage you to write up your learnings and share them with the community so that we can all learn together. Like, oh, this worked really well for this. This didn't work as well for that. And that'll help all of us to make a decision. Sharing is caring. And that's my talk today. Thank you.
I'm wondering if Pamela was inspired by Simon Willison, right? With his Today I Learned blogs and sharing all of his learnings and expertise, which I used to think he did because he was generous with the rest of us. But then I talked to him about it because he was a podcast guest. And he said he was actually just being selfish. He was doing it for future Simon. So he wouldn't have to look things up in a year or 2 or 6 months when he'd forgotten something.
Yeah, it logs for yourself. I think when you're really getting into the blogging habit, and I guess you might have this all the time, Claire, as well, where you're searching for something and then, one of the first hits is your own blog post. And you're just like, oh,
I guess I knew that.
Claire.
I knew that once upon a time.
Yeah, exactly.
All right. Well,
Very,
big
very
thank you
deep.
to Pamela Fox. She's amazing and she's a good teacher. No wonder her talks and demos get accepted at conferences.
Yeah, this was a good one. This was really fun. So definitely make sure that if you also thought it was fun, to make sure to share that feedback. As you said, sharing is caring. So look for the talk that is building modern Python web apps with Postgres, and make sure you leave your feedback, and you'll get those wonderful socks there in the top right corner.
And if you are live posting the event, be sure to use the hashtag PosetteConf hashtag. Did I just say hashtag twice? I did. It's okay. It's all good. Obviously, the most important thing is to head on over to the virtual hallway track on Discord, which you can get to at aka.ms/open-source-discord. But Teresa is posting some really cool photos of the speakers online on all the different platforms. So if you are friends with or want to support any of those folks, you might get a kick out of those. Oh, there we go. All right. So let's introduce our next speaker, Matt McFarland. Matt is an engineer at Microsoft, on the Postgres team at Microsoft, and he specifically has been working most recently on a new extension for Postgres on VS Code. It just came out a couple of weeks ago. When the demo and the blog post first came out, it was top of Postgres Weekly, top of Hacker News, like all sorts of excitement. Obviously, developers like their tools. Many people like VS Code, and this Postgres extension is appealing to people. So this talk is going to be about introducing the new VS Code extension and, showing us what it's all about. I also like that Matt spent many years working on a geospatial data platform that's powered by Postgres. I mean, that's just one of the things that I think is so cool. And if you've ever listened to Paul Ramsey speak about PostGIS and Postgres, like there's a whole community of people out there, people, organizations, businesses, government agencies that run on top of Postgres and PostGIS together to manage all their geospatial data. So it's a use case that I find fascinating. I think maps are pretty cool. Anyway, I'm looking forward to hearing more from Matt McFarland. Let's do it.
Hey everyone, I'm Matt McFarland and I'm an engineer at Microsoft and a contributor to the new VS Code extension for Postgres that's just been released to public preview. Please join this talk if you're interested in learning about a new tool in VS Code that can help manage and you develop Postgres applications using both standard database management tools and also more advanced Copilot AI capabilities. First up, to avoid any confusion, there has been a Microsoft Postgres extension in the VS Code marketplace for years and years, but unfortunately it hasn't gotten much attention and it was a bit outdated. This is an entirely new effort with a larger scope and more ambitious goals. So if you've come across it before, I hope you'll check out this talk and give this one a try too. So every morning I start my computer and I launch the same set of core tools: email, Teams, a browser, a terminal, and VS Code. Before I've even had time to think too deeply about what I'm doing today, I already know I'll be living inside that editor for a good chunk of it. And I know I'm not alone. Just seen, laptop open, VS Code running, coffee in hand. It's something I imagine playing out every morning across the world. VS Code has become the daily workplace for developers, and it's no surprise why. It's got great extensions, a great pace of innovations, especially GitHub Copilot, which I personally find to be an incredibly productive tool. And Postgres, well, this is not the conference where I feel the need to make a case for why Postgres, but let's just say it's a very popular database. By integrating directly into the world's most popular IDE, we can put our tools right alongside developers' application code, minimizing context switching and working seamlessly with the productivity and development tools that they already rely on. And importantly, with the rise of Copilot and LLM-powered interfaces that are reshaping the way we build software, we want to ensure that those tools are just as informed about your database as they are your code base. So you don't need to read every line here. The point I'm trying to make is that we've tried to pack a lot of features into this first release. Most of these features you'd absolutely expect from a database management tool, regardless of what runtime it is: connections, query execution, results viewing, that kind of thing. But there are also some capabilities that might surprise you: local containerized instance creation, the ability to chat with your database in natural language using Copilot and agent mode. I'm not going to spend the rest of the time of this talk going through slides about all this. We're just going to dive in and show some of these features off in a series of demos. So let's see how easy it is to get it connected, whether you're on a remote or local instance or any managed Postgres service. Most of us aren't working with just one database. We've got dev and test environments, production backends, some local test instances, and maybe multiply that by a few different projects. That can get a little messy. One of the first things this extension does helps you with organizing your connections. You can group them however makes sense: by project, by environment, by team, whatever. Let's say I'm working on a migration project. I'll create a new group for it, call it demo project, and then I'm going to drag a few existing connections in here, maybe a legacy production server and a staging copy. Now I also want to connect to a server that I don't already have a connection to, so let's make a new one for this group. You can do this in a few ways depending on what you got handy. I'll just go to my server group and select new connection. If you've got the details, you just plug them in right here. There's support for all the standard inputs: hostname, user, some advanced settings like SSL enforcement. You specify your port, things like that. You may also have a connection string. This could be in a variety of formats, like a Postgres URI, or even a copy of a pSQL command, the standard PG prefixed environment variables. You could paste that in here. We'll be able to parse everything out except for the password and pre-populate the fields for you. If you've got a flexible server instance in your Azure subscription, you can skip all that and just browse your Azure subscription directly. This will take a moment for me because I have many, many subscriptions. I've got them filtered down. I'll select one. You can also filter by resource group or region and eventually find the servers that you're looking for. For now, I'm just going to grab a pSQL command that I've copied from elsewhere. I'll go ahead and paste it in, and we'll see everything get filled out. I still need to enter my password and save it. This is stored in VS Code secret store. And now I'll go ahead and connect, and we can see that I'm adding this analytics database to my new server group. Great. I'm actually going to jump back in and talk a little bit about some credential handling options that we have too. Obviously, you can use a regular username and password if you want. That's what we just did. But for Azure users who have enabled Enter ID authentication, we're going to handle that for you. It's much more secure than managing your own passwords, but it can be a real pain to generate and refresh these short-lived tokens and then use them for connecting. After adding your Enter account, the extension will be able to generate the token behind the scenes and connect you securely, no secrets to store. This is available using any of the connection methods. Once you're connected, your server shows up right here in the Object Explorer. You can expand it to browse all the familiar stuff, your databases, schemas, views, functions, roles. It's sort of a full visual map of what you're looking at. But what if you're just getting started or you want to test something locally without setting up a full database server? We've made it super simple to spin up a new local Postgres instance using Docker. No terminal, no config. Here, I'm just going to go to create new server, and we're going to land on a screen with some options. Right now, we support Docker-based local servers, but we've got plans to add simple Postgres flexible server provisioning and some other options as well. So select that. First, it'll give you an overview about Docker. It'll do some prerequisite checks to make sure everything's installed and running correctly. If it's not, you'll get some information about how to set up your system. Once we're all good, we just need to give it some basic information to set up our container. We'll need to give it a profile name, just like in the previous connection. We'll also set a container name. There's defaults for a lot of these values if you want to just sort of breeze through it. Add my password and save it. By default, it's going to pull in the latest official Postgres image, but you can customize the image name or the tag or the repository if you've got something more specific in mind, like a container that has some pre-built extensions or something. I'll go ahead and click connect and get this thing created. Great, and you're up and running with a local database, already connected without having to leave VS Code. Now that we've got a few connections here, and especially on my small screen now, it's getting a little bit crowded with connections. So you can filter the connections to just those you've connected to and stay focused on whatever you're working on. So whatever you're dealing with, production infrastructure, test environments, local scratchpad, this extension gives you a way to stay organized, connect quickly, and work the way that you want to, and hopefully where you want to with the rest of your application and development tools in VS Code. Next, let's take a look at what happens once you are connected and ready to run some queries in the next demo. So now that we're connected to a server, let's explore it a bit. Sometimes you're dropped into a database you've never seen before, and it helps to start with the big picture. Let's visualize the schema. I'm going to minimize the sidebar here so we can get a better view, since I've got a particularly large schema that I want to showcase. There's a legend which shows all the color-coded schemas in the database. They correspond to this diagram, which you can pan and zoom around for some quick understanding of the relationships and find a table that you're interested in. Let's use this one. Once you spot a table that looks interesting, you can also find it back in the Object Explorer. You go through, you can expand your trees, the tree of tables, you scroll down. When you find it, you can select top 1000 to do a quick peek at that data, sort of a lightweight way to see what's in the table without having to write a query. Of course, you often will have to write SQL queries, and the extension adds some nice functionality to assist you here. We're just integrating with standard VS Code editors, which means all your usual extensions and tweaks are already applied. But we are supplying PGSQL syntax highlighting and schema-aware IntelliSense for things like table names, column names, functions. Here, I'm showing all the tables in my production schema. You'll also see GitHub Copilot completion suggestions since I have that extension installed. And I think that's pretty useful, but remember that those completions aren't necessarily schema-aware, so you have to pay attention. I'll just finish out typing this query and see how it does. We have a few other features that you might also expect. You can select a single query out of a file of several. Just execute that one by selecting it. Here, I'm going to use a keyboard shortcut to execute, Shift-Enter. This is something you can configure in the VS Code settings. We also have snippets, which are templates for some common queries you might need. Here, I'm going to use one for listing all the tables in a schema. Just tab, it autofills, and we're just going to change that to the production schema. You can also toggle on and off the explain analyze features without having to change the query. So toggle that on, execute your query. You can see the analyze results. Go back, toggle it off, rerun your query, you get your results. So it's a nice way of, again, without having to rewrite your query. I will draw your attention to the bottom of the screen where we've been seeing our results show up. These stay sticky with the active editor, and they'll reload as you tab between different query editors. You can also pop them out into a different orientation if you prefer, based on your monitor size. And since this is VS Code, you could even drag that out of the window and put it as a floating window in a different monitor if you want. You can also filter and sort columns right in the results view. This is a quick way to do some exploration of the data without needing to rewrite the query. Great. If you need to export your results, we support CSV, JSON, and Excel formats. Here it's asking me for a save location, which you can't see on the screen share. But if you give a minute, you'll see that the CSV export is saved and loads up. I'm going to do the same thing with JSON. And you can see that this is data type aware, so your values should be formatted correctly. We support large result sets, so even if your query returns tens of thousands of rows, you should still be able to scroll and interact smoothly. Back in the editor, you can always see what server and database you're connected to up here at the top lens area of the editor. We also have the same thing in the status bar. Hovering over either will show you a few more details. You can click them and reassociate an editor with a different database or different server connection using either of those. Here, I switched it to a different database. Obviously, I'm getting an error that table doesn't exist. We're looking for feedback, especially on how to communicate connection status, because we really want you to feel confident to know what you're executing your queries against. So these are all nice, rich editing and viewing experiences, but a lot of folks appreciate using pSQL on the command line. We integrate with pSQL directly from our Object Explorer. Just go back and find the database that you'd like to connect to, right mouse click and launch pSQL directly into the VS Code terminal. This is already authenticated using the credentials that you provided, whether that be passwords or enter tokens, and it's scoped just to the selected database. We don't actually currently bundle the PG binaries, so this will only work if you have them installed on your system already, but if you do, it's just a click away. So whether you're exploring a new schema, editing queries with Copilot support, or dropping into a pSQL session for a quick command, your basic workflows should be covered. Let's finish by moving to the last demo, which introduces some capabilities for more advanced workflows using GitHub Copilot with agent mode. The demo is going to focus on agent mode experience, which honestly is pretty interesting, but there's also a registered chat participant as part of the extension, where you can simply chat with natural language to query and modify your database. My colleague, Rob Emanuel, who's the lead on our Copilot efforts, has already recorded this awesome demo, so I'm just going to let him take it away.
Hi, I'm Rob Emanuel. In this video, I'll show you how easy it is to build a database-driven app using Microsoft's PostgreSQL VS Code extension and GitHub Copilot agent mode. Let's jump right in. We see here a Docker Postgres server that I set up with our extension, which we call PGSQL for short. I need a new database for my app, so I simply ask GitHub Copilot agent mode to add it. The agent uses PGSQL tools to connect to the server and create the database, prompting me to confirm modifications. For this demo, I'll select Allow in this session, letting Copilot use the tool without further confirmation in this chat session. I'm building an app focused on brewery data, so I ask Copilot to import data from the Open Brewery DB project, a community-driven open source dataset. Copilot downloads the CSV, creates a table, and loads the data into my database. Every query executed by Copilot gets logged to the PGSQL query history, so I'm able to see exactly what Copilot has run. Next, I ask Copilot to visualize the database schema, which brings up the PGSQL schema visualization tool. I notice this dataset includes latitude and longitude, so I ask Copilot to convert these into a PostGIS geometry column. The change updates in the visualization immediately, enabling quick iteration of schema design. Now that the data is in Postgres, I can have Copilot write and run queries based on my natural language questions. Notice that Copilot effectively uses the PostGIS extension and even directly geocodes Philadelphia. Next, let's build an API for our app. Switching to the O4 mini reasoning model, I instruct Copilot to create a Python fast API-based server that serves the brewery data in GeoJSON format, a popular geospatial standard. Copilot builds the application, including dependencies, and writes an endpoint that uses precise SQL queries, leveraging the full context provided by PGSQL. With just a small amount of off-screen work to set up my environment, I run the API server and test the GeoJSON endpoint, retrieving data for one of the breweries. Now that we have our API, it's time to build the front end. I ask Copilot to create a single-page web app displaying breweries on a map. Copilot generates the front end and modifies the fast API server accordingly. Copilot chose a popular open-source web mapping framework called Leaflet, which can display the GeoJSON fetch from the API. After restarting the server and opening in my browser, we can see an interactive map of all of the breweries in the dataset. Finally, to expand this simple app into something more impactful, I envision a Wikipedia-style platform that enables more engagement with the dataset. I work with Copilot to modify the database schema to support these more advanced features. Copilot updates my schema and offers to apply the corresponding changes to my codebase. But we'll stop here for now. As you've seen, the Microsoft PostgreSQL VS Code extension and GitHub Copilot can empower you to quickly build database-driven applications from back-end to front-end and supercharge your workflow.
Great. Really excited about that feature. So thanks for taking the time and checking out this talk. We've packed a lot into this extension and we're still building. This means your feedback really matters. We want to know what's working well, what's missing, what's frustrating, what ideas you have for where this could go. You can install it now by searching for Microsoft Postgres in the VS Code Marketplace. We're still in preview right now, so if you hit a rough edge or have thoughts while using it, you can run the command PGSQL give feedback right in VS Code. It'll bring up a form. It's really easy for you to just send us a note or send us a thumbs up or thumbs down about how you feel about it. And of course, if you want to open an issue, file a bug, or start a discussion, head to our GitHub repo. It's here on the screen. This is also where you can find links to our documentation about how to use all these awesome features. So we'd love to hear from you. We'd love for you to check this out. Thanks a lot.
Okay, that was fun. Okay, you're the developer tool expert. You tell me, Flor.
This was super fun, and I am really looking forward to trying this out. So yeah, there goes my weekend. Thank you, Microsoft, I guess.
It's only Tuesday. You're already planning for your weekend.
You know, it's a full week. There's all of these live streams to watch. When do you think I find time to also try this out?
This is true. Well, thank you, Matt McFarland. Also, another one of the creators, Rob Emanuel, is on the Discord chat. So please pop on there if you have questions and you haven't asked them yet. And of course, there are the links for the surveys that you can do at any time. Surveys are open until, I guess, a week from today. Is a week? How is a week from today, Tuesday, the 18th of June? How does that work? Isn't today the 10th?
It's not. I can assure you, Tuesday is not the 18th, but that's okay.
Okay,
Apparently, it is open until the 18th, so more than a week.
Okay, well, just get it done by this weekend. How's that? Or get it done before you forget what the talks were about. That's what you should do. All right. Let's dive into our next talk. Who's doing the introduction? Oh, it's you. You've known Lukas forever.
Lukas and I go way back. That's true. Yeah, absolutely. So really fun to see him in the lineup for this conference as well. Lukas is the founder and CEO of PG Analyze and the author of PG Query, which is a Ruby extension to parse queries, and many other tools as well. He really loves working with Postgres statistics and visualizing them. That's maybe why he came up with PG Analyze. And in best practices for tuning slow Postgres queries, Lukas will walk us through what he has learned tuning slow Postgres queries over the years. So there's a little bit of archaeology going on here as well as with Tomas before. Lukas has been on the Talking Postgres podcast before as well with you, Claire, detailing his journey into Postgres monitoring. And he was on there together with Rob Thread, who is also in the Discord channel active right now. So definitely a shout out again to have a look at the Discord channel. But yeah, if you want to check out that podcast, you can listen to it on talkingpostgres.com. But right now, we're going to listen to Lukas's talk.
I'm Lukas Fittl, founder and CEO of pgAnalyze. We're going to talk about how to optimize slow queries in Postgres. Specifically, when you have an explain analyze output and you don't know how to interpret it, I'm going to give you a few tips and tricks and a better mental model for working with slow queries in Postgres and how to fix them. All right, let's dive in. So there's 5 things we're going to talk about today. First, how to debug why a query is slow. Second, how we can benchmark queries with explain analyze with the buffers option. Third, how planner costing works and why it really can never be perfect. Fourth, we talk about join order and how parameterized index can greatly affect query plans. And last, we'll talk a little bit about how we can guide the planner to the right plan. So generally, I think it's important to have a good sense for how you go about debugging, right? Like what a good debug loop is that you can think of. And usually I start in debugging when I'm saying, well, is a query always slow or is it just sometimes slow? Typically, here we have a query that has 1.4 seconds of average execution time, but the outlier took 14.6 seconds, right? So this is usually a good starting point saying, well, why did it take 14.6 seconds in that one case? Oftentimes, I/O time can be the problem. So I/O time might be, a particular node just taking either loading more data or maybe the disk is overloaded, and that greatly influences, of course, the total runtime of the query. And unfortunately, especially in the cloud, I/O latency can be pretty bad. Postgres 18, which is the upcoming Postgres release, will make some of these things better. But for now, on most production systems, we'll have really inefficient I/O on some of these cloud provider network storage options. Also, sometimes what we see is not necessarily I/O being the problem, but the plan having changed, right? So a query might have a good query plan and a bad query plan. For example, maybe an analyze ran recently and changed the internal statistics, or other things caused the plan to change. And so really where we're starting with, we say, well, we had a slow query. It's slow. What can we do? So we start a benchmark query with explain analyze, which is basically just put explain analyze in front of the query. We form a thesis on what to change based on that explain analyze. Then we try out a change, which might be rewriting the query or other optimizations. And then hopefully, what we're trying to get to is that we actually made the query fast. And then we figure out a way to make that change permanent, right? This is a loop that people go through day to day all the time with Postgres, right, as they're debugging slow queries. So this shouldn't come as a surprise to you if you've had a slow query in your life before. But what I want to give you is basically better tools of working in each of those steps. So just in case you're not familiar, I want to repeat maybe the most important things about how to interpret explain analyze. So explain analyze, right? We just, either put explain without the analyze in front of a query, explain analyze, or then explain analyze buffers. In the upcoming Postgres 18 release, buffers will be the default. So if you just run explain analyze without specifying buffers, it will automatically be set. You can do buffers off if you want to turn it off. Now, an explain output without the analyze just gives us the query plan that Postgres wants to use, but it doesn't tell us anything about, the actual execution statistics. For that, we have to add explain analyze, which in this case shows us that the query executed in 307 milliseconds of runtime. It also tells us things like, did a particular plan node perform, worse than expected? Did it remove a lot of information after, for example, scanning the table and such? And then when we add the buffers option, or again, if you're in Postgres 18, then you'll actually get information like I/O timings and how much data was read. This is really important because it helps you understand whether the slowness of the query comes from the amount of data it's working with, that it had to load from disk, if the data was in the cache, and such, right? So it's really important information for debugging. Now, when we see buffers, what we mean with a buffer is an 8 kilobyte buffer page. Basically, the internal storage of Postgres is structured this way. So each time you load data, even if you load just a single row, you'll have to load a full 8 kilobytes of buffer page from the disk or from the memory. Now, the number of how many rows you have per page is greatly influenced by table bloat. So if you have a lot of dead rows and then your table bloats and you have a lot of empty space in your table, that greatly influences how effective your scans are. And so it is important to watch these buffer counts if they're unexpectedly high. Also, the other thing to note is if you see a hit counter in the buffer's output, that means it's a cache hit. That's generally a good thing, but it can be confusing because the problem is if you have a nested loop, the loop loops over the same basically data over and over again. What can happen is that it basically double counts the same buffer block. So in this case, for example, it might have been that there were only 12 buffers uniquely loaded, but 1,200 buffer accesses occurred. And so you've got to interpret these hit counters when you see them. The other thing to know with explain analyze is that it has overhead. So when you run a query without explain analyze, and it's a query that doesn't work with a lot of rows, usually the measurements are pretty similar, right? However, once you have a query that's very slow, in this case, the query just measured from the client side takes 340 milliseconds. But if we measure the query with explain analyze in the picture, without timing, which means no per node timing information, it's similar, right? It's 404 milliseconds. So we added a little bit of overhead here. But where it gets really bad is if you have timing on and the buffers option on, then Postgres basically measures each repeated access to the plan node, and that just takes a lot of time. And so when you benchmark, explain analyze will give you the insights into what's going on, but you should always run it without the explain analyze also to get the true performance, basically, without the overhead of measuring this. Now let's talk a little bit about planner costing. So planner costing is basically the mechanism that planner uses internally to decide which query plan to use. So, core mechanism here, right, is like we looked at, we have a bad query plan, we found it, explain, analyze. Now let's form a thesis on what to change. That thesis has to interact with how the planner, comes up with a plan. And so, as Tom Lane said in the presentation many years ago, ultimately the planner's task is fuzzy, right? So there can be many valid plans for the same query, but it's not always clear which one is the best query plan. And so basically the planner has to find a good query plan, but it also shouldn't spend too much time or memory finding it. And it also needs to support the extensible aspects of Postgres, right? And especially that last point means sometimes, Postgres has to do more work to figure out which data types, are being used and such, which index access methods exist. And so some limitations exist because the planner is extensible, but then also, wants to consume finite CPU and memory. So most important thing to know is the planner does not find all possible plans. It actually discards plans that look bad pretty quickly. Also, it doesn't change plans when expectations don't hold true. So if your row count is off, then it doesn't fix that. It doesn't rerun. And also, it doesn't know if past executions of the same query had a bad plan that performed badly. It will happily keep doing the same slow query. So really, cost estimation is how the planner makes decisions. Ultimately, garbage in, garbage out applies here, as Tom said in the mailing list comment some time ago. So basically, if you put bad data into the query planner, as in bad statistics, you'll get a bad query plan. Now, quick information here is we can look at the cost on each of these plan nodes. The cost basically has a startup cost component, which is the first row you're fetching, and the total cost is if you fetched all the rows with that particular method. Right? In this case, the index scan, if we basically scanned for all those rows. Now here, we estimated that there's 10,000 rows being fetched, which is the output of that plan node. Then we also, the planner also estimates how wide each of these rows is. But what is cost really? Cost is not really a specific unit. It's more a currency that the planner uses when it does its cost-based search, right? So it doesn't you could argue that maybe what it means is the cost of sequential scan. So one of the core things, if you look at how Postgres internally costs a sequential scan on a table, it basically multiplies the sequential page cost, which is set to 1 by default, with the number of pages you're looking for. So if you have a table that has 8,000 pages, the sequential scan cost will be 8,000 roughly. So you could say that that base sequential scan cost basically is what all the other costs are based on. Right? Most importantly, what's the cost of an index scan? Well, the cost of an index scan is dependent on which index access method you're using. So if you use a B-tree index, it's going to be different than if you use a hash or Brin index. And because, again, Postgres is extensible, this passes down to the particular index access method. For example, in the case of a B-tree index, we have the BT cost estimate function. That function ultimately tries to figure out how selective is the part you're looking for in the index with, doing a selectivity calculation, and then it multiplies that with the number of tuples, and then it factors in the regular costs. Now, this function here, this clause-list selectivity function, is one of the key facts that will impact your query plan's performance, or the query plan's quality, rather. So this here basically works from limited information, where it's like you're looking for this, kind of, we have these filters on this table, and you're trying to say, is this, likely to be found, right? Like, am I looking for something that's very unique, or am I looking for something that's very common in a table? And that then drives how selective your query is, how selective your search is, basically, in the table or the index. Now, this, then drives the cost, right? Because the cost basically multiplies with that selectivity number. So, for example, the way we can see the selectivity number is kind of indirect, because it's the total number of rows times the selectivity, right? That's the row number you see in the plan. The most typical issue why you get bad row estimates is because clauses are not independent. What that means is if I'm saying A is 1, B is 1, C is 1, D is 1, and E is 1, then basically if all the A that are 1 also have B1, or there are no C1s that have D1, right? So basically if there's dependencies between those different conditions, Postgres does not know that by default. And so because of that, what Postgres will do is will think if you add more conditions, things become more specific, so it will underestimate the rows. Now, we can improve this by using the create statistics command. So the create statistics command basically tracks additional information, specifically this dependency between columns, that lets us then improve the situation. Another problem on selectivity, though, is join estimates. So join estimates are really complicated and often wrong. I won't have enough time in today's talk to really go through all the details here, but suffice to say, if you want to look for this, look at the Postgres source. One of the things to know about joins is that the most common value lists are being used for that. So Postgres, when it does an analyze run, will collect the most common values in a table. And then if those basically align with, the two tables being joined, that is used to drive, some of the join estimates. But one of the ways you can improve, the quality basically of a join selectivity estimate is you can increase what's called the statistics target. That then increases the number of most common values that are collected, and that way you might get a better estimate of how many rows get returned by a join node. Now let's talk about joins in a little bit more detail. So ultimately, when we talk about joins, we have to think about two tables, in this case A and B, being joined. So here we see a sequential scan on A, index scan on B, and we join those two together in a nested loop join. Oftentimes joins are more complicated, right? So in this case, maybe we join the result of that A and B join with another table C, and then it becomes, ABC as a join. This here, is what we call the join order. So in this case, the join order is ABC. We can also turn this around. So maybe, just to illustrate the difference here, maybe the join on C happens earlier, and then the join on B happens last, and so the join order becomes ACB. This performs differently, right? Because you basically filter things out earlier or later, depending on the join order. This, ultimately drives a couple of things. So for example, join order can influence which scan methods get used. We'll talk about parameterized index scans in a moment. Join order itself also can, just by virtue of eliminating information earlier or later, influence the performance of a query plan. And then join methods, like whether you have a nested loop join, a hash join, or a merge join, also again, our choice the planner makes and are influenced by the join order and the scan methods, right? So all of these are kind of interdependent with each other. One of the things you can do, and we've done some kind of prototyping around this ourselves at PGAnalyze, is you can detect the join order in captured explains. So imagine you use auto explain, you're looking at all the slow execution outliers. You can actually analyze which join order is being used by your queries. And so the one thing that surprised me when we did this is that it actually does change for the same query, right? So you might think Postgres chooses one join order and keeps it, but the reality is that depending on the input parameters, Postgres will use different join orders because it thinks that maybe, the data being returned from one part of the join is going to be less in one case. And so this, like, mapping this out can be useful for, highly frequent, changing queries, basically. The other thing to know about is what we, or to think about is how can we filter on particular parts, right? So here in this query, we have a sequential scan, and you can see that, in this case, we have a hash join. And so the hash join is the one that basically does the, merging of the two, and the filtering happens like on T2. There's no filtering when we load the data. It's really when we join the data that we filter. Now, the most important thing to think about here is that we might have what we call a parameterized index scan, where basically here's a nested loop, and parameterized index scans require nested loops. And basically what happens is that, you first load the data from the one table, and then each of the result outputs from, in this case, T1, gets passed to the index scan on the second table. And so this means that, for example, when our query says, load from table 1 and also load from table 2, and then match up, the table 1 ID with the table 2 ID. Postgres cannot, doesn't know what the value is it's searching for. And so the choices you have here are basically very limited, right? But if you have an index, in this case on T1 ID, on that second table that you want to use, you have to first know the values you're looking for. And so it's going to get the values first from the first table and then put them into the second table to basically locate the actual rows. Another way of putting this, right, is these are basically the same query, just two different plans. Either you have a hash join, and then if you have no index scan that's usable without, the value being known, then you basically either have the hash join with a sequential scan on the left side here, or you have a nested loop join with an index scan on the right side. And the index scan uses this parameterized index scan, parameterized because it inputs the values from the other table. Parameterized index scans must be on the inner side of the nested loop, so this is where the join order comes back, right? If we have bad join order, we're not going to get this. Now let's think a little bit more about how we can guide the planner to the right plan. So when we think about, query being slow, right? And we formed the thesis, we understood kind of the costing, what's going on, the join order, we looked at all these attributes. Now we're trying to say, what can we try to improve this, right? How can we actually get to a better plan? One of the things I like to do is trying to force a good plan and then seeing why Postgres chose a bad plan. So one way you can think about this is you have this query, right? The planner produces, for a particular value, a good plan. But then there's also always a bad plan, ultimately, right? The bad plan has a cost. And what you're hoping for with a cost-based, estimate by a planner is that the estimate models the reality, meaning the bad plan doesn't get chosen because it has a higher cost. Now, what can happen, right, is you might have different input values. So in this case, it might have, different object that you were looking for. And so the bad plan gets chosen because the cost is different, right? And so even though basically it's the bad plan because of the input value having different selectivity, we're getting, the bad plan because there's lower cost, right? So again, this case, the bad plan has cost 300, the good plan has cost 500. Postgres doesn't know ahead of time which plan is going to be better, and so it chooses the worst plan, basically. So one of the things we can do to improve the situation is we can turn off planner features. So planner features are, for example, sequential scans. So let's say we get a bad plan that's a sequential scan and a good plan that's an index scan. Well, we can say set enable seq scan off, which means Postgres basically makes the sequential scan extremely expensive in old versions, or in Postgres 18, this is changed with an explicit disabled plan nodes setting. So it's just visualized a little bit differently. But the fact remains the same. If the sequential scan is the only viable option, it will still give you a sequential scan. It's just extremely unlikely to do that if there's any other way to basically give you a query plan. Now, in this case, what we see, right, is we get the good plan, and most importantly, we know that the good plan has a cost of 500. So once we have the right plan, we can then look at the right plan with the wrong costs, and we can find out where our misestimate is happening. For example, another thing you can try is if you're seeing a hash or merge join being used, but you wanted to use nested loop, you could turn off merge and hash joins and see what the nested loop plan looks like. Now, sometimes this works really well, and sometimes it doesn't work well. And where it doesn't work well is when you have complex queries where maybe you want to turn off nested loops for one part of the query plan, but you want to keep nested loops for another part of the query plan. And so for this, we can use PG hint plan. So PG hint plan basically lets us specify specific parts of the query to be done differently. So here, for example, we have a bad plan with a particular join order that we don't think is good. And so we can, we also know that, there's another plan that worked better. And so what we can do is when we look at the good plan, basically we come up with an idea of how exactly to, force the order. And in PG hint plan, look it up. It's going to take a long time to explain in all the details, but basically PG hint plan has things like, for this table, use this index. For join these other tables, use this order, right? So it's basically prescriptive about how the planner should do things. And so in this case, now we know that, the good plan, for example, had a cost of 1.4 million. the bad plan in this case without the Memoize function had 14 million costs, so that actually would have been fine. It would have been worse, but because of the Memoize feature in Postgres, the bad plan was chosen because the bad plan had a cost of 900,000 instead of 1.4 billion, right? And so now you know that, okay, what happened was Memoize made that difference basically between those plans. So to summarize, there's basically 6 ways to guide the Postgres planner that I can think of right now that I would like to give you on your journey. First of all, if you have simple scan selectivity issues, right? So if you have a problem where the Postgres planner, gives you the wrong row count, look into using create statistics. Create statistics collects, additional information. This doesn't work for cross-table situations, but it works well if you have these functional dependency issues. If you have join selectivity problems, increase your statistics target to increase the number of most common values to help the join, improve selectivity. Sometimes with join selectivity, you can also force materialization, which is another technique I sometimes like to use. Reviewing cost settings can help, right? So as mentioned, these, Postgres settings like random page cost, sequential scan cost, they do significantly influence what the planner does. And so again, one common problem might be that, for example, random page cost is still set to 4 by default. And so random page cost being high means that you get certain like indexes being used versus others. Like there's lots of details to this, but basically reviewing those settings and sometimes lowering random page cost in particular can make sense. Sometimes, we didn't talk much about this today, but it makes sense to understand what particular biases the planner has. So one common situation I've encountered is order by limit. And so sometimes that causes a bad query plan. And so creating multi-column indexes in the right way is a good thing to think about. As mentioned, materialization is a way to fix things. So if you don't want to use a planner hint, which you shouldn't, if you can avoid it, using the materialized keywords for CTEs lets you control which part gets loaded first in Postgres. So that's kind of a neat hack sometimes. And then one trick that I would give on a journey for anybody who runs a multi-tenant app, where you have different customers, but they're all in the same database, right? So you have a shared kind of table for all the customers. It makes sense to basically give more of your tables a customer ID identifier or something that basically identifies the tenant, and then adding explicit clauses and duplicative clauses to your query plans. That seems a little bit nonsensical, but the reason you do it is that the planner basically has more choice in terms of query plans, because it's not forced to use a parameterized index scan. And as a kind of overarching principle, I would say choosing better statistics or rewriting queries is always better than choosing planner hints, right? So planner hints really should be a method of last resort. PG hint plan works. Some people use it in production, but it is not efficient. Like it causes overhead on each query where you're using it. And so I would only use it if you have no other way of fixing a query. And that's basically it, right? Like, so query plan, like optimization isn't magic necessarily, right? Like it is in a sense a deterministic process that Postgres does. And so I would really encourage you to basically experiment, try to get a better mental model of how Postgres comes up with these query plans. And then if you're interested, pganalyze helps you make these things easier. But I do think that there's, a lot of things you can do just with a pSQL shell or, pgadmin and just running explain and having a good mental model of how row estimations work. I'm looking forward to, talking more about this. If you want to reach out to me, feel free to email me, lukas@pganalyze.com. I'm always happy to talk about how to optimize Postgres queries. Thank you.
That was awesome.
Always happy to talk about optimizations. And people can talk about optimizations a little bit more in the Discord channel. And I suggest they do.
And then if people are wondering, yes, the videos are going to be published online on YouTube, ungated, after the conference is over. So in other words, after the 4th live stream, which equates to Thursday for most people, depending on where they are. So yeah, you'll be able to watch this again and again and again if you need to, and pause and replay and back up and do all that kind of stuff, because Lukas is a wealth of knowledge when it comes to tuning Postgres.
Yeah, and he can't even fit it in one talk. I mean, nobody could. And so he's also been sharing some more resources in Discord as well. Really interesting stuff.
And if you're interested in the Postgres Planner, there probably is more than one, but there's one talk that comes to mind to me right now about the Postgres Planner and Optimizer, and it's happening in Livestream too. And it's what's new in the Postgres 18 Query Planner and Optimizer by David Rowley, who is one of the Postgres committers and major contributors, and super, super smart, and should be interesting. I can't wait to see it. All right, so I think I'm supposed to show this slide, which is reminding people about the survey. And there are some special instructions that I'm not sure what to say about them, frankly. Are you? Do you know what to say?
There's special instructions. We don't necessarily know how to put them in words. I know that there is people, when you fill out the survey, make sure that you pay special attention on how to exactly claim the socks. But I believe that our team is putting some instructions in Discord to help folks make sure that they claim the socks in return for them giving feedback.
Maybe a screenshot, a picture says 1,000 words, like that might help. But the key is some of you who've already submitted surveys didn't do the right thing, whatever that is, with the code, and that means you won't get socks. So make sure you fill out another survey and do the right thing with the code, whatever that is, and get your socks. Our team is also very responsible in terms of privacy. And so when you put in your shipping address, as soon as we use it to ship you socks, we forget about it. It'll be gone. We'll do all the right things about that. Okay, let's move on. We're gonna roll another trailer. So this is about Livestream 4, which is in it's in your time zone, Floor. And we'll get a flavor of all the different talks and speakers from these talks. Shall we do it?
Let's go. Let's roll.
Hi everyone, and welcome to the 4th year of Posette, an event for Postgres. My name is Charles Feddersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hello everyone, I'm Marco Slot. I work at Crunchy Data, and I'm gonna talk about a journey we've been on for the past 18 months to build a Postgres data warehouse. So if you're interested in using Postgres for analytics, or you want to know more about what's possible using Postgres extensions, this will be a very interesting talk.
Hi, my name is Derek van Veen. I'm a database specialist at Azure, and I mainly work on a partitioning framework. So, of course, this talk is about partitioning. So if you're managing tables around 100 gigabytes and more, this is definitely the talk you want to see.
Hello, I'm Amit Langote. I work at Microsoft in its Postgres open source team. In this talk, I'm going to talk to you about how Postgres Executor interacts with modern CPU and how that impacts its OLAP query performance. I'll talk about a few things we've done to improve that, and then some architectural directions we could take in the future. So if you're interested in OLAP performance, please join me.
Hello there, everyone. I'm Michael John Peña. I'm a Microsoft MVP and MCT, Data and AI Director at Playtime Solutions. I'm here to talk about building enterprise RAG applications with Azure PostgreSQL. And if you're looking for something about embeddings, vector search, all things around LLMs, this is the right place for you.
Hello, everyone. My name is Péter Farkas. I'm the CEO and co-founder of FerretDB, which is an open source alternative to MongoDB. And today I'm going to talk about turning MongoDB into an open standard and implement it on Postgres. So if you're a MongoDB user, if you're a Postgres user, if you are both, then you might be interested in this presentation where we combine the power of these two database technologies.
Hi everyone, my name is Adam Volk. I'm a Principal Technical Program Manager for PostgreSQL here at Microsoft. Today I'm going to tell you how to travel using row-level security with PostgreSQL and Citus. So grab a towel and join me if you want to learn how to use row-level security with your application.
Hello, I'm Eileen and I work at marketing at DBTune. My talk is titled Setting Max Connection, Building Postgres User Groups that Bring People Together. I'm really excited to be here at Posette today.
I'll be sharing some practical advice on how to create successful Postgres meetups. If you're interested in fostering thriving Postgres communities and creating interactive and fun small and large-scale events, this talk is for you. Now, let's get started.
Hi everyone, welcome to Posette conference. I'm Rahila Sayed. I work as a senior software engineer in Microsoft. Today I will be talking to you about monitoring in Postgres, and also will be explaining a design of monitoring feature in Postgres. This talk will be useful for developers and administrators who are looking to learn more about monitoring in Postgres.
Hello and good day, this is Jan Karremans. I head up sales in Cybertech, but I still think I have sufficient technical background to take you along on an interesting journey on securing Postgres with streaming replication. It is one of the hidden in plain sight cool features of Postgres that might just help you save the day.
Okay. I love it. I love getting the little snippets. All right. And I wonder what it's like if you don't know these speakers. I know a bunch of them. And so that just makes seeing them on camera, especially when I don't get to see them in person at all or very often, it just makes it so special. But I imagine their expertise matters regardless of whether you know them or not, right?
Yeah, but it's still fun, I think, as a conference organizer to see like the lineup of your conference. It feels like your fantasy football team that you've, assembled. I kind of like that. That's really good. And what a breadth of topics too. So there's something for everyone, I feel like, in all of these live streams.
We didn't do the thank yous in the very beginning. Thank you to the organizing team, to the conference chair, Teresa Giacomini, and to the talk selection team. I pushed that to the end so that we could try to stay on schedule. So we will do that in the wrap up because gratitude matters, especially in an open source community, but kind of always. But yeah, I was on the talk selection team. So I reviewed all 230 talk proposals. And
I just want to ask how many were there? 230, that's a lot.
It's a lot. It was a lot of work, but really fun. And it was hard because there were a whole bunch of really good talks that we just were not able to fit into the schedule. So yeah, challenging. Okay, let me go ahead and introduce our next speaker. Bohan Zhang is an engineer at OpenAI and previously was co-founder at OtterTune, which means that Bohan has worked with the ever-popular CMU database professor Andy Pavlo. And in fact, in his bio, he includes that he co-authored a paper titled "The Part of Postgres We Hate the Most." And I've not read that, but now I'm really curious to go find out what that part is. And at OpenAI, Bohan's focus is on scaling the database. So this talk is a customer story, really, about running a super demanding workload on the Azure database for Postgres managed service. And with that, let's dive in. Let's watch.
Everyone, I'm Bohan Zhang. I'm a member of technical staff at OpenAI. In this talk, I will discuss how we scale Postgres to the next level at OpenAI. Specifically, we will talk about how we operate Postgres and the lessons we learn and the challenges we face and how we address them at OpenAI. If you are a DBA operating a production Postgres at a very large scale, you might be interested in this talk. Okay, let's get started. Let's see what we did at OpenAI to scale Postgres. So before starting the talk, I would like to acknowledge my the hard work from my teammates. Thanks Siqing Liu, Chaomin Yu, Chenglong Hao, Ben Rice, and more people in the OpenAI infra team. Thanks for all their hard work to make Postgres super reliable and scalable at OpenAI. A little bit about myself. I am a member of technical staff at OpenAI. Before that, I was a co-founder at OtterTune, which is a CMU spin-off based on many years of research from Carnegie Mellon Database Group. So we basically apply the machine learning and AI approach to automatically optimize your databases, specifically optimize Postgres and MySQL. And before OtterTune, I was a researcher at Carnegie Mellon Database Group, working with Professor Andy Pavlo on the OtterTune research project. Background. So Postgres is the backbone of our most critical system at OpenAI. So if Postgres goes down, many of our key features will become unavailable. So Postgres failures have previously led to multiple self-zero outages, which take down the entire ChatGPT service. So Postgres is super important at OpenAI. So scaling Postgres to meet OpenAI demand is also super important, but it's also non-trivial. It's not an easy task. So historically, we operate on a single primary instance in Azure without sharing at all for a very long time until we encounter the RAS scalability limits. Since if you only have one single primary, you cannot scale RAS horizontally. So in a single primary multiple replicas architecture, RAS scalability can become some bottleneck. So for the re-queries, you can add more replicas to scale rates. But for the RAS, we only have one single primary. So this architecture actually, in this architecture, the RAS scalability is a bottleneck. We did lots of optimization to make it work. First of all, we moved most of the read-heavy workloads to other systems. So we migrate off the write-heavy workloads from Postgres. We also make sure new tables and new workloads are not allowed, which means that we only support the current workload. We don't want the new write traffic to the current setup. We also did lots of optimizations to ensure the current architecture has sufficient runway to support existing read-heavy workloads and future growth. We'll discuss that what optimization we did in the next few slides, but right now, we have a sufficient runway in the current single primary setup. What we found is that Postgres is actually not ideal for write-heavy workloads. I'll discuss this in details later, but for the OpenAI's read-heavy workloads, it can scale really well. So there are some known challenges in the write-heavy workloads. First of all, I think Postgres MVCC design, which is the multi-version concurrency control. Postgres MVCC design has some known issues. It's not very efficient. There are several issues. The first thing is it will cause the table and index bloat. Another thing is that it will also increase the auto vacuum tuning complexity, and also the version churn. Also, there also have the version churn from triple copying, and also it increases the index maintenance overhead. If you want to learn more about that, Andy and I wrote a blog article in 2023. The title is the part of Postgres we hate the most. We discussed the MVC design in details and the issues it has. And also for the write-heavy workloads, it's also difficult to scale to read replicas. One thing is that write-heavy workloads can generate lots of red hat logs. So those red hat logs will be shipped to the replicas. If you have lots of the rats and generate lots of red hat log, the high volumes you need to ship more data to the read replicas. It can potentially increase the replica lag in the read replicas. Another thing is that the problem even gets worse when you have more read replicas, because the primary need to send the same copy of write hat log to many read replicas. If you have many lots of read replicas, the network bandwidth can be a bottleneck. That's why the heavy workload can change in Postgres. So after we migrate most of the heavy workload from Postgres, currently the really heavy workloads are still served by the onshore Postgres in Azure. The problem is how. The question is how. How can we just serve the OpenAI's really heavy workload in just in a cluster with just a single primary instance? We did lots of optimizations here. The first thing is that we try to reduce the load on the primary, because we only have the one primary. We want to reduce the load as much as possible. Particularly, we want to reduce the load from both writes and reads. For the writes, we want to mitigate the write bugs in primary. So the writes, the first thing we did is that we migrated write-heavy workload from Postgres to our systems, and also we reduced the number of writes at the application level, because we also identified some bugs in the application side which generate unnecessary writes. So we carefully optimize the application to make sure it only writes to Postgres when necessary, and there will not be any duplicates or unnecessary writes in the application. The start thing we did is that we also use daisy writes where possible to smooth out the write spikes, to avoid the spikes and smooth it out. The last thing we did is that another thing we did is that we also, when backfilling a field, we also strict limit the backfilling. Usually it means that it may take a week to backfill a field for our table, but it's really necessary, because if you don't limit the backfill, it will cause the write spike in Postgres, which can cause lots of issues. So when backfilling a field in Postgres tables, we will set the read limit on that. That's what we did for the writes. But for the reads, we also offload read queries from primary to read replicas, because we want to offload the read query from primary whenever possible, to also reduce the primary load. Because we only have one primary, if there is a read queries, I think if we can move to read replicas, we will not read from the primary. Some reads cannot be moved due to transactions. So for those queries which are required to stay on the primary, we want to make sure those queries are efficient in primary. Another thing we did is the query optimization. We optimized the queries allowed to avoid anti-query anti-patterns and also avoid non-running queries. So non-running idle queries can cause lots of issues in Postgres. It can both auto vacuum and consume lots of resource. We avoid non-running queries by setting timeout on different levels. We set the idle instruction session timeout. That's a parameter in Postgres, which will kill the queries if it's idle in the transaction for downtime. We also set the statement timeout, because sometimes we find some queries actually idle in a transaction, but the status is active for some reason. So which means the idle instruction session timeout will now kill those queries. That's why we also need to set the statement timeout. In the meantime, we also set the client-side timeout in the application. So if there are some request is longer than the threshold, in the application it will also kill that request. We also avoid OLTP query anti-patterns, because we observe multi-way joins in Postgres queries. And the most expensive queries will join actual 12 tables together. It's super expensive, and here previously we had a surge on search queries, and it actually led to a save in the past. So we want to avoid those expensive multi-table joins queries in Postgres, because it's not a typical LTP queries. To avoid those expensive multi-way join queries, we actually modified the application code to make sure to break down the joins in the application side. So instead of joining 12 tables in the Postgres server, we just did it. We joined in the application, so that Postgres queries will be still efficient. And in the application, I think we optimize on an application level to make sure we don't have such expensive query in Postgres. Another thing we noticed is that users don't write raw SQL queries in Postgres. They usually use ORM, but developing with an ORM can easily lead to inefficient queries, because when writing with ORM, you don't know what's the query generated by the ORM, so usually it has some bad queries. So this requires the developers to carefully write the code using ORM to make sure it won't generate bad queries. Another challenge we face is the single point of failure. Because the primary instance, there's only one primary instance. It can be a single point of failure. So if that single primary is down, if that instance goes down, no writes will be performed. Because we only have one writer, so no writes can be performed anymore. But we have many read replicas. So if one read replica fails, applicant can still read from others. So we have single point of failure on primary, but not for read replica. So in the application side, we make sure that most critical requests actually read only, and they only need to read from read replicas, as they don't need to write or read from primary. Which means that even if the writer goes down, those critical requests can still operate by fetching data from read replica. So it usually will now cause the severe issues to our users. So if the primary goes down, it will be a SAP 2 instead of a SAP 0 or SAP 1 because of the most critical requests can still operate by reading data from read replicas. So in this way, we can mitigate the impact of the single point of failure from primary. So besides that, we also categorize the requests by priority. So the idea that some requests have high priority and some requests have low priority. So high priority requests will have a greater impact on users when they are unavailable. So it will cause SAP 0 compared to the low priority, which will only cause SAP 2. So we categorize the requests by the high priority versus low priority. And the next step is that for the high priority request, we want to make sure we have the dedicated read replicas for those high priority requests to prevent them from being impacted by other like low priority requests. So the idea is that if there are some expensive queries in a low priority request, it will not impact the high priority request. So for example, if there's a spike in the expensive query in the low priority request, it only affect the low priority request because we have a dedicated read replicas for high priority request. So this can help us like avoid the outage, the SAP 0, when there are issues in the low priority request. We also need to read limits. We also have read limits in different places. This is because a search from a single expensive query, as we discussed before, can bring down the entire service. So previously we had some expensive queries running on primary. For example, there was a 12-way join queries, and typically the volume was low, so it's okay in the most of the time. But the issue is that sometimes there will be a sudden spike in one of those expensive queries, and it can took down the entire instance. So in the past SAP, we had such a spike in the 12-way join query, and the CPU usage jumped from 20% to like 99%. And eventually the whole instance was down because of this single query. So we want to have some read limit to help to mitigate this case. So we have read limiter on different level. The first level is that we have is the application level. So we read limit the application level functions to reduce the loads during the peak traffic. So the idea is that for the application requests, we should have read limit so that we don't have a spike from a specific users or specific region. Another level is on a new connection. We also read limit on the creation of a new connection, because it's also super important for us to prevent connection pool exhaustion. So in the past, we saw some like the huge number of connections. It caused several lots of issues. So we also limit the creation of new connection to make sure the connection pool is not exhausted. We also limit for specific query digest. This is because the past the incidents we had, so the whole service was took down by a specific expensive query. So we have a feature to limit on specific query digest. So if the some queries, if that issue happen again, we can block the query entirely or set limit on specific queries so that it will not eat a lot of results and take down the whole service. Connection pooling is also super important, because previously we had some set like running out of the connections from Postgres. So yeah, in the old days we even don't have a connection pool, and it's very easy to have the connection exhaustions. So right now we are using PG Bouncer as a Postgres proxy. It acts as a connection pool, which enables connection reuse. The idea is that the connection can be reused by different applications. You don't need to close and open the connection again and again. So the connection can be reused. This can significantly reduce connection latency. From our experiment, it can basically reduce the connection latency from 50 milliseconds to less than 5 milliseconds. That's a huge improvement for creating connections. It also reduces the number of connections because those connections can be reused across different applications. This is super important for us given we have that 5,000 connection limit on primary, and this is a hard limit on the Postgres instance, and we cannot increase that limit. So we need to use those connections carefully. And connection pool and PG Bouncer help us. And it's also responsible for fill or to fill over. So if the read replica fails, sorry, not fill over, but if a read replica fails, the traffic will be automatically routed to other available replicas through the PG Bouncer. Another super important aspect is about the schema management. Because if you don't do it correctly, you might have some like expensive full rewrite for entire table, which can cause lots of issues. So for schema, we need to do it very carefully. So at OpenAI, only that with schema changes are allowed. So first of all, we don't allow creating new tables or introducing new workload in Postgres, because we don't want to add the new write traffic in this in the current setup. So because the current setup does not scale the rest very well, so we don't want the new write traffic in this setup. We also allow adding or removing columns in tables with the 5 seconds timeout. So any changes that require a table rewrite are not allowed. So for some schema changes, for example, when you alter a column type, it might need to adopt an entire table and rewrite the whole table. It will basically interrupt your production workloads. We definitely don't allow that. So we only allow some that which might have that change, like adding nullable columns or remove column, which will typically finish within a second. We only allow those operations. So for adding columns, we only allow adding nullable columns Otherwise, it may have some like it may cause some full rewrite for the entire table. For example, if you set when adding a column, if you set the default to a dynamic variable, it might trigger rewrite for the entire table. So for adding a column, we also require the column be nullable. We also allow adding or dropping indexes concurrently. One thing we found is that schema change can be blocked by some consistent queries. So in a long-running queries, when the query running longer than 1 second, if those queries are consistent present on the target table, the migration may fail because those queries will block the schema migration. What we found is that so to find those queries, we basically run the SQL on the pg stack activity. The query is the stack star from pg stack activity. We'll query like your target table name and the duration is longer than 1 second. We run this query periodically, and if some queries like consistent present, it means that those queries are actually blocking the schema migration for that on the target table. So if we find those queries, we can either fix those queries in the application, like to optimize queries to avoid those query consistent to avoid those long-running queries, or we can move them to replicas so that it will unblock the schema migration on the primary immediately. That's it from my talk. So overall, I think after all the optimization we did, we are super happy with the Postgres right now for our read-heavy workloads. It's really scalable and reliable right now. I think in the past 6 months, we don't have any sub-zero regarding to Postgres. We do have one sub-zero, but it's just because we have a sudden spike of the write traffic. And besides that, we don't see any sub-zero on Postgres instance. So I think the lesson is that for write-heavy workload, Postgres might not be suitable, but for read-heavy workload at OpenAI, if you optimize it carefully, I think it can scale the OpenAI's workload, read-heavy workload to a very large scale, even with a single primary multi-replayer architecture without sharding at all. Thank you.
Well, that was a lot and useful.
Yeah, and I feel like there needs to be a part 2, like the thing we hate most about Postgres, but you can actually maybe solve it this way. I feel like I need to defend Postgres,
Well, it's always useful when someone walks through the challenges that they've had and then how they address them and how they solve them. And so I appreciate Bohan telling his story. And he also gave a talk, a longer version of this recently at PGConf Dev in Montreal. So there'll be, if for someone that watches this and wants to dive even deeper, they'll be able to go watch that talk as well. And I think that should get published on YouTube in the next week or two, certainly. All right. So, are you
I'm actually going to try it out, as we have had so much back and forth about how these things work. Now I want to see it. Now I'm going to try it out, and I will comment on the Discord and how this works. Yeah.
I think Teresa Giacomini, who is the chair of this amazing conference, just put super crystal clear instructions on the hallway track on Discord with a screenshot of item 7 in the survey that you see if you go ahead and do, I think probably either of these surveys. I'm not sure which one. And then it tells you how to get your code and where to go and drop your code in and give your address so that you can get your socks. Right? Is that the deal? Well, you'll confirm that when you go through the process.
That's the dealio, and I'm giving feedback anyway, so might as well claim some socks.
Yeah, and I don't know if it's item 4 for the voucher or item 7 or what the item number is for the voucher, but it's there. Okay, cool. let's keep going. Oh, it's time to introduce Vinod, and that's on you, right, Flor?
It is on me. I mean, it has my color coding and everything. So Vinod is a partner software engineering architect at Microsoft. That's a mouthful for a title. And is at the center of some of the new Postgres extensions that power, well, first, the new open source Microsoft Document DB project. And then second, also the Azure Cosmos DB for MongoDB managed service as well. And in designing for document databases on Postgres, we'll look at the newly open source Microsoft Document DB solution that is built on top of Postgres. And in turn, by the way, FerretDB, for the people that know, FerretDB builds on top of the open source Document DB project then again. So that's interesting. But the upcoming talk will discuss the architectural design choices that Vinod and the team took in developing PG Document DB extension to Postgres. So let's hear about that.
Hi, I'm Vinod. I'm a partner software engineer at Microsoft and one of the committers of Microsoft's Document DB. And today I'll be talking about designing document databases for PostgreSQL, aka how we leverage the awesomeness of Postgres' extensibility model to build Microsoft's Document DB. Okay, so that is a very long title, but what does it even mean? So what are document databases? At a high level, document databases are primarily a category of NoSQL databases, which are basically focused on scale up and scale out. So the premise is being able to scale out to more than what one machine can do. And so focus on very small, tiny databases all the way to large data sets that can be several hundreds of terabytes. Right? But specifically, these are a category of NoSQL databases that focus on schema-free documents. So JSON, JSONB, BSON, and so on. And because we're looking at scale-out systems, they typically provide a subset of traditional SQL features. So like lesser transactions, joins, and stuff. But over time, they have been adding more and more of these features to provide better distributed transactions and transactions in general, cross-document joins, and better isolation semantics. Now, specifically, what am I talking about Document DB? Document DB is the backend that powers Azure Cosmos DB for MongoDB vCore. This service is running a Mongo-compatible protocol in Azure. And the backend for it is powered by Document DB, which we recently open sourced. As part of open sourcing Document DB, we managed to map some of those API semantics to Postgres query semantics. The interfaces were built on similar contracts to what we had in the service. And one of the things that we wanted to do was embrace the ease of use that we got with our service. In other words, you didn't have to deal with table creation, schema management, and all of those complexities that you tend to do when you're dealing with databases. We also wanted to draw inspiration from some of the other work that we've done internally that on other NoSQL databases in terms of how we do easy index management, dealing with wildcard indexes and so on, and how do we deal with filters, sorts, and things like TTL, which purge documents based off of some expired. And because this was based off of the MongoDB vCore service, we had to use BSON as a storage layer. And this was primarily done from the perspective of type system fidelity and reducing the transcoding cost for I/O. And that's super important when you're dealing with things like OLTP workloads, which are low latency and high throughput. And JSONB technically could have worked as well, just as fine, except we would have had to pay for the transcoding costs. And given that BSON was already binary encoded, we figured it was just as well. So getting into it, we talked about the ease of use of the service and how we wanted to bring that into Document DB. The insert command in this case, which is what you see on the top, is how you interact with the system when you first come in. Notice that you don't have to create a table, you don't have to declare a schema. You just come in, open a shell, and type insert1. And in this case, I'm inserting to a collection that is called cafe, and I'm inserting a simple document. And in this case, it detects that there is no collection called cafe, creates the collection automatically, and inserts the document on my behalf. On the bottom left, you can see the schema that is there for a documents table in Postgres. And as the red pointer shows, there's only 3 columns in the table. There's a shard key and the object ID, which form the primary key that are going to be accessing the document, and the document itself, which is just a BSON blob. We modeled the BSON type very similar to JSONB. In other words, it had all of the properties of JSONB, like toasts and compression and so on, so that we could leverage a lot of what was already built into the Postgres infrastructure. You'll also notice that there's this thing called collection ID, and the table doesn't really match the collection. And we had a mapping table that mapped the collection to the Postgres table. And that was primarily due to naming differences of what was allowed in our service versus what Postgres allowed. Now, let's get into the fun stuff. Like, how do you build queries? How do you think about issuing aggregations and so on in DocumentDB? In our very first generation of queries, when we first started the service, we were looking at it from the perspective of making stuff look very much like SQL. So we had our incoming request. We would translate that to something that very much resembled a SQL query, which is what you see in the first query up there, which is you have a projector, you have a from clause from a collection instead of a table, and you have a filter. And this worked very well initially. But once we started building more and more features, it started becoming more and more cumbersome to debug and figure out where all of these complex aggregation queries were going. For instance, if you look at the group by, there is the max of some expression to extract a value from the JSON, and then you have to, or BSON in this case, and you have to filter it, and then do another group by on some other expression that you have to extract from the BSON document. And again, this is not too bad. But as we started looking into even more complex queries, for instance, this query is called a lookup, which is basically doing a cross-collection join between 2 collections, the orders collection and the inventory collection, and matching the local field item to a foreign document ID, and storing it as a field called match documents. And in this case, this simple 1-line pipeline became this 8-line SQL query. And that was primarily from the perspective of managing, extracting the fields, doing the join, and making sure that appropriate things could be pushed down to various indexes. And this is still fine, but as we added more stages and nested pipelines and subqueries, things started getting very difficult to debug and manage within the service and figure out where we went wrong. Additionally, from a performance standpoint, we were also translating from the incoming BSON that was coming in to a SQL text query, and then to a Postgres query plan on top of that, which added overhead to the query layer. And we couldn't even use prepared statements because we didn't know what incoming user queries were there, and they were fully dynamic. So given that, we built our second generation of queries, where we decided to remove the intermediate SQL text generation layer. And so the query basically looked like selecting a document from the aggregation pipeline, and you provide the actual pipeline declaring the intent directly in the query. And how did we manage to do that? Postgres had an extensibility layer that was built exactly for this. There is a planner hook that is available in Postgres that allows you to replace the default planner that Postgres uses to plan queries. And in our case, when we saw this specific function, and you can see where we query has aggregation function here, we basically expand that aggregation function directly into the query tree, avoiding the SQL query text altogether. In some cases, when the query is simple enough, like a point read, we know exactly what the plan statement is because we already know that we pre-created our tables with primary keys. And in this case, we bypass Postgres' plan altogether and we just direct it to an index scan against the primary key. In other cases, we just delegate it back to Postgres and we get to leverage all of the amazing innovations and improvements that happen in Postgres while just subbing out one tiny layer that generated SQL query text and replacing it with the query tree. And one of the things that we got out of this was we were able to get a 50% improvement in cases like simple scans relative to the case where we basically had to parse the SQL query and send it to the backend, just because we were also able to prepare the outer envelope in the Postgres backend at this point. So we're able to generate the queries. We're able to push it down to Postgres. Now, how do we use indexes to optimize performance for these queries? A little bit of a primer before we get into it. Because this was based off of our managed service, some of the query semantics that we had to reflect came in from that. And one of the interesting query semantics we wanted to respect was when you have a filter, the filter does traverse into arrays within the document. In other words, if you have a filter a.b equals 1, that technically matches a document which has a nested object with a value 1, or a nested object with an array of 1, or an array which has a document of b is 1, or an array with a document which has an array which is 1. In other words, every first generational array is traversed as part of traversing a path into a filter. In another way, if you think about the document A, which is an array of 1, 2, 3, technically that matches all 4 of these filters. A is 1, A is 2, A is 3, and A is the array 1, 2, 3. From an indexing perspective, what this meant is that the indexing must support multi-valued indexing. In other words, every document can technically produce multiple terms that can match multiple queries for a given path. And that becomes important when we start talking about which indexes to pick and how we push down to the index. Additional constraints that we had to work with is we needed to support things like wildcard indexes. Now, wildcard indexes are very popular in document databases and NoSQL systems because they allow for dynamic schema evolution. In other words, you can create one index, and as your schema changes, you don't have to go and revisit which indexes to create and what to manage for performance. Anything that's created in the scope of a wildcard index will still support all new evolutions of the schema. So this is already there in some extent for JSON in Postgres with JSON path indexes, where you can create a root wildcard index against a JSON document, and then you can issue JSON path queries against any subtree within that document. So consider this case in DocumentDB, where you have a filter a.b equals foo. Technically, that filter can be pushed against all 4 of these indexes. In other words, an index on the single path indexing just a.b, a root wildcard that indexes the entire document, a path-specific wildcard that is indexing just a, or path-specific wildcard that indexes everything under a.b. Right? So when each of these wildcard indexes get created, a single index needs to be managing multiple paths and multi-value again. And the other requirement that comes in out of that is that when you author the query, you want to write exactly one filter. In other words, you just want to declare the filter as a.b is foo, and you want the query system to be smart enough to figure out what is the best index to push this down and push it down correctly to the index that satisfies that query. Beyond that, we also wanted things like unique constraints to work and TTL indexes, which are basically indexes that purge old documents based off of some expiry time. And of course, this goes without saying that we wanted all the core query operators to be pushed to the index layer. So what does that give us? We took a look at all of the different Postgres indexes that are available today. Initially, we started with considering the B tree because that's generally widely used in the ecosystem. It supports unique constraints and order by, and it's very popular within Postgres. And this worked fine for unique, but one of the big things that we found was that the B tree layer does not have operator extensibility, and nor does it have multi-value support. And given our requirements for wildcard indexes and how we traverse into arrays, we could not use B tree to satisfy our indexes. So then we moved on to Gist. Gist technically can support unique constraints via exclusion constraints, and it does have operator extensibility, but we once again found that it doesn't have multi-value support, and so we had to discard that as an option. We then looked at the Gin index, which was great because it had really good operator extensibility, and it had multi-value support built in, and it could support our wildcard indexes. And so we started building our indexes initially on top of Gin when we realized we could not support unique constraints in any way. And at that point, we found this open source extension called Rum, which was based off of Gin at some point, and that added support for unique constraints with exclusions into the basic indexing layer. And so given that we had all the operator extensibility, multi-value support, and wildcard support, and exclusion constraints, we picked Rum as the backing index for DocumentDB. Beyond that, TTL was built using another open source extension in the community, pgcron, that allows for periodic running of batch jobs so that it could consult the index for what documents needed to be purged and purge any expired documents. So we have our indexes. We know that you can use the operator class extensibility to push it down. But how does that exactly work? So especially for Gin and Rum, it allows very structured extensibility, but it allows you to author functions that can push any kind of query predicate to any kind of indexing structure, right? And it has 4 extensibility points that we have to consider. The first one is the extract value function, which is called on every insert and update, that allows you to declare how to produce terms that will be sitting in the index. In other words, you get a callback with the document, and you get to produce the exact set of terms that will be stored in the index that you can query later. And you can produce as many of them as you want. Then when a query comes in, the first callback you get is the extract query, which basically maps the query predicate to index terms. So you can see that in the first example here, where you have a.b is in 1, 2, or 3. The extract query can return 3 possible index terms to query for. ab equals 1, ab is 2, and ab is 3. And the Gin layer handles, or the Rum layer handles, making sure that it'll query the index against whatever you give it, and manage the rest of the layer of the query. The next extensibility point that is given is compare partial. And this is an optional check. Not every operator needs to support this. But if you're doing ranges of scans, it will basically walk the index tree and call back and say, does this document match your scan? Or does this document match your scan? And that can be seen in this next filter we have, where we're saying, give me all the arrays that are in a.b, where the size of the array is 5. So in that scenario, you can say, my extract query will just give you the smallest array. And so you can start scanning from the smallest array onwards that is rooted at a.b. And then for every array that comes back, I can just check the index and to see if the array's length is 5. Right? And that allows us to basically just filter subsets of documents and load very few documents in the runtime and do as much work in the index as possible. The final check that we get is a consistency check, which is, given all the terms you asked me to check and given whether they match or not, does the outer row actually match the query? So in the case of in, if any of the individual index terms match, that means the outer row must match too. In the case of $size here, if the compare partial returned true, it must be true, and therefore the outer query matches. And this way you can build extensibility into how you build the index terms and how you query the index terms without having to touch Postgres at all. And this is all extensibility that is built in. So now we have our operator classes. The next thing we needed to figure out was, how do you push these filters to the index? And this may seem simple, but it was actually more complex than we thought it would be. So the very first thing we did was we looked at the simplest thing, where we put the filter, we project out the path that we were going to filter against. And then when we were creating the index, we put the exact same filter there. So when we have this filter, Postgres will figure out that this expression matches the expression in the index, and therefore you can push down this filter to the index. And this is done automatically, given the appropriate off-class definitions. But there was a problem with this. It was unable to work with wildcard indexes because to Postgres, this expression must exactly match what's in the filter. And so the wildcard index that is on the root document could not match the filter on a.b because the root expression itself was different. Another smaller issue is that when there was no index and we were applying the filter on the runtime, you first had to project a.b out of the document, produce a new document, and then evaluate the filter against that projection, which added a slight increase in cost, especially when we were looking at large documents, which we'll see an example of in a bit. So this didn't really work for wildcard indexes. So we started thinking, what can we do? The next layer we thought about was, okay, what if we don't put the filter definition on the left side of the operator and we put it on the right side? So all our filters were where document equals, and then we specified a.b as 1. Now, the index expression here on document matches the filter, And within the index, we put the op class options, which is another layer of customization that we were given within the gin or rum indexes, to specify the paths that we wanted to index. So this first index would only index terms that are below a.b. And the second one will be a root wildcard, and the third one will be only under b.c. So at this point, we figured, oh, cool, like all these filters could be pushed to appropriate indexes. And the runtime evaluation no longer needs that extra projection, which is even better for perf. But there was a problem with this again. Now, our entire index selection process was broken because through Postgres, this expression matches all three indexes, so it's free to choose any one of them. So this filter, technically, which is on a.b, could technically be pushed to the b.c index, producing incorrect query results. So we were still off. And we were still trying to think about what to do next. So then we landed on the third approach when we spotted the support function that is available with every function execution. And this is a planner function that you can register with every filter. And you get a callback during the planning phase with this struct, which has your filter, it has the index, it has the op family that the index has, it has all of the options that the index has associated with it, and you get to return what you would push down to that index fully in code. So in this case, you could also, by the way, declare whether that filter is lossy or not, or whether it can produce an exact match. So we basically built our filters to be $$ equals, which is the func equivalent of the operator you saw earlier, with the document and the filter. And we built our indexes the same way we would before. But now inside the support function, we would introspect into the op class to look at the index path, figure out if it matched the filter, and only if it did, would we push it to that appropriate index. So at this point, our runtime evaluation does not need an additional projection. And with the support function hook, we were able to fully provide an exact match to the index and only push to the index that can be satisfied by the given query. So this sounds all great, but there was still one more problem with that, which is even though it pushed to the index, it still evaluated the runtime functions even after it matched all of the things in the index. And why is that? And you can see the example right here. So I ran an explain for something that is a filter that matches on vehicle ID. And you can see a bitmap index scan on the vehicle ID index, with the index condition being something that got pushed down to the index. But you still see a runtime filter applied here. And it applied it against all of the documents. And given this was a relatively large set of documents, it has to decompress them, project onto it, filter it, and redo the work, which the index already did. And so you can see here that the index time was only 66 milliseconds, but the overall time took 30 seconds for this query. So we had to think, okay, what can you do here? And here Postgres, once again, had an extensibility point that helped us. And to the top right, you can see what went wrong. During planning, when it's about to form the execution phase, Postgres looks at all of the scan clauses that are available in the where clause, looks at all of the index clauses, and says, if the index clause is implied by the runtime clause, then I can strip it because it's provably implied by the index qualifiers. However, Postgres doesn't know about the fact that we use a support hook to introduce an equivalency. It doesn't know that those two are equivalent. And so we had to add the filter in. But there is another hook available in Postgres called a rel-path list hook. And this hook is called after planning and on the base table, after it's done all of the index path selection and everything, but before execution actually starts. And before all the group bys and order bys are figured out. And in this case, what we did was we added ourselves into the hook and we rewrote the expressions that weren't pushed out to the index in a manner that this loop that is removing provably implied qualifiers can then remove it. And so this one additional hook saved us in terms of the performance. And you can see that here. On the top, we have the same explain that you saw before. It was 66 milliseconds on the index and a whole 30 seconds on the runtime end to end. And once we did this rewrite, you can see that the filter now becomes a recheck condition. And a recheck condition is something that is only evaluated when the index says it is lossy. In other words, if the index cannot fully correctly evaluate that filter and it needs a runtime recheck to make sure that that thing really matches. And in this case, you can see that the index took around 63 milliseconds again, and the overall time was only 136 milliseconds because it didn't need to load all of the documents and reevaluate the filter. So once again, we had an extensibility point that was there in Postgres that saved the day. Now, we've talked a lot about a bunch of these hooks that we put in, the index filtering and so on. But one of the things we did is, again, we used Bson instead of JSONB. And the question is, how much of an overhead is that? We also introduced these custom queries, and we had to basically add planner hooks to do the planning. So how much overhead is all of that? So I happened to run pgbench against some simple queries against JSONB, against Bson that is directly run as a prepared SQL statement, and using the DocumentDB wrapper functions. So you can see that they're all roughly within the ballparks of each other. So point reads, JSONB and Bson work hand in hand, and the DocumentDB find wrapper takes more latency, which we are working to improve. But it is in the comparable range for each of these. And it's a similar story for count and for runtime filters, where you're returning a projected field that matches a runtime filter. And while it is true that JSONB is still better, and I don't think we can compete there, but we can get it pretty close, and that is what we're trying to do. Overall, I have to say that Postgres extensibility is awesome. And as we were building DocumentDB, whether it was building queries, whether it was trying to figure out how to push down the queries, whether it was figuring out which indexes to use, whether it was figuring out how to push it to the index, we always found an extensibility point in Postgres that helped us move forward. Thank you.
Very nice. Yeah.
Well, and it's an interesting thing because a lot of people who work with Postgres also work with MongoDB, also work with other databases, but then others don't. And so for those that don't, then this talk might seem a little bit foreign at times. I don't know. That's just my perspective. But for people who are working with multiple databases, who have had to think about Bson support in Postgres. Anyway, I liked it. I'm so glad that Vinod submitted this talk and kind of brought his expertise from the NoSQL world to us here.
Yeah, absolutely. We'll have more document database stuff in next live streams as well. I think live stream 4, we have Peter Farkas from FerretDB. Is that correct?
That's right. That's right. He's giving a talk about Ferret, so which I know is really popular for people. So, and it is built on top of these new Postgres extensions that Vinod was talking about. Okay, let's keep going. You can complete a survey and get socks as long as you do the right thing, getting that code and going and entering it somewhere else. And
in a new tab. In a new tab.
In a new tab. Okay, got it.
I made that mistake. Yeah.
Okay. Well, and the reason the team, I think, designed it that way is so that you could submit your survey feedback about talks or about the event completely anonymously. And obviously, we're going to know who you are as well as your address when you're trying to get your socks. So that's why it's a 2-step process. Okay. Now it's time to introduce Gayathri. So Gayathri Paderla works as a software engineer on the Postgres team at Microsoft, specifically on the Azure database for Postgres Managed Service. And she has worked with data for, 18 years now, including at Infosys and Oracle. She lives in Georgia on the East Coast United States, and also gave a talk at Posette last year about making Postgres inserts faster on Azure. And her focus goes beyond Postgres, believe it or not. I suppose we all have things in our life outside of Postgres and beyond her family. She's also part of a nonprofit called Team Asia. That's a running-based nonprofit organization that's dedicated to sheltering and educating orphaned and abandoned kids in India. So her talk today is titled Boosting Azure Database for Postgres Performance with Azure Advisor. Did I miss anything? I think we're good, right?
We're good. Let's go.
All right.
Hi all, my name is Gayathri Paderla, working with Microsoft as a PostgreSQL performance expert. Boosting the PostgreSQL server's performance using Azure Advisor recommendations is the best way to identify any vulnerabilities your server is going through. You will be informed proactively, and anyone who is moving from Oracle, who is not aware about the internals of the PostgreSQL, for them, this is the best approach to identify their server's vulnerability and get it fixed. With the introduction, let's dive into the topic of today, which is how we boost our PostgreSQL server using the enhanced Azure Advisor performance recommendations. We are gonna optimize the PostgreSQL server's performance using the best practices Azure Advisor has to provide. Moving on, the agenda today we will be covering would be about Azure Advisor, how to set up the Azure Advisor alerts, the different performance recommendations implemented for Azure PostgreSQL Server, different scenarios, which are the different recommendations set up, walkthrough of one specific recommendation, and the conclusion. That's the flow of this talk. Let's go ahead. Coming to Azure Advisor. Azure Advisor is actually a digital cloud interface which analyzes your resource configuration, your usage telemetry, and come up with a tailored set of recommended actions proactively to improve your cost efficiency, performance, reliability, and security of your Azure resources. Azure Advisor alerts are something which you could set up based on the recommendations you receive, so that you are proactively informed in terms of email or message about your behavior of your PostgreSQL servers. In this demo, we will be going through how you could create those Azure Advisor alerts, setting up the action groups, and how you could receive the notifications. Let's get to the Azure portal to see how to create your Azure Advisor alerts. Your Azure Advisor alerts are something which will help you proactively receive alerts on your recommendations for your server on your phone or email. Let's see how to set them up. Go to your Azure Advisor portal and then type in Advisor. On your left-hand pane, you will be seeing monitoring and then alerts. Go to alerts. Click on New Advisor Alert. In this page, pick up the subscription and then the resource group which you want to create an alert for. Here, when you set the alert condition, there are multiple ways to set it up. One is at category level or impact level or at recommendation type. Or you could just not select anything and go ahead, which means you will be receiving alerts for every other recommendation. Most probably, I would suggest you to go ahead and do it specifically for performance, as we are going through that. And then high, at least you are able to catch all the alerts which are coming for the servers with a high recommendation and working on them. So once you select the condition, you could also go by recommendation type, which is just names of the recommendations. All the PostgreSQL recommendations are prefixed with review your server. So you can just pick one of the recommendations and set up an alert just for that one. In this demo, we'll just go by category and impact level. Once you're done with that, you can create an action group which will tell you, like, notify you if there is a recommendation which is triggered on one of your resources. And also, you could set up some actions using it. Let's see how to do that. Here, you could either select one of the action groups which are already created, or if you could create a new one. When you create a new one, you are again selecting the subscription and the resource group. Then for the region, you could either go with global if you have your servers set up in different locations, or you could just go to the specific locations where your servers are located. My server is located in the East US, so I'll go with there. And here I'm just giving it some name and then display name, test alert. And then next we go to the notifications tab. In the notification type, you will see email Azure Resource Manager role and email SMS message. I'm going to go with the email SMS message. Once you click on that, just provide a name. It's optional, but yeah, here you on the right hand pane where you see whether you want it the notification as an email or phone, you could select accordingly and click OK. So here I'm going to go with email, set up my office email ID, and then click OK. Then here is where I was talking about the actions. We have different ways how you can set up an action. So for the alert, if you're selecting specific recommendation type and you know how to handle it, you can set it up using one of these forms and pick that action type and give a name. So whenever a recommendation is triggered, the action is also taken. In this demo, we will just go through how to set up the notification. Then let's click on review and create. Hit create. Once this action group is created, it's connected to your alert. And here you will give an alert name. So here I'm giving it a name as performance related high impact recommendations. I just want those to be alerted for. And then you could either give a description or not, and then pick the resource group on which you want this to be running, and then create an alert. Once you're done with it, you will be informed proactively through your email or phone about the recommendations for the servers which fall into that category. Moving on, Azure Advisor performance recommendations on Azure on PostgreSQL Server for Azure are we have recommendations set up for whenever we notice the scenarios on your resources. When we identify an inactive replication slot or checkpoints which are happening too frequently on your server, or if you have a long-running transaction for more than 24 hours, if you have any orphan prepare transaction which is degrading your server's performance. Similarly, we have many more such recommendations to flow. Those are if you have a high bloat ratio on your server, or your server is approaching a wraparound situation, if your server is mostly at a high CPU utilization, which is greater than 90% for almost consistently 2 hours, and there are some logging parameters and auto vacuum parameter which can impact the performance. So we trigger recommendations for all the above scenarios, and in this talk we will walk you through each of these scenarios and how it impacts and how the recommendation will make your server performant and be out of that scenario. Let's go through that. Inactive replication slot. Replication slots are the things which take care of retaining the WAL files until they are consumed by the replica. If an replication slot is inactive, then which means the WAL files are not being consumed by the replica, and these WAL files remain on the primary server occupying the disk. And it also leads to dead tuples not getting cleaned up. So to avoid getting into a scenario where your disk is being utilized and your dead tuples are not getting clean, in turn, which impacts the query performance and the server performance, we ask you to drop the inactive replication slot. So a trigger is a recommendation is triggered on your server if we identify there is an inactive replication slot, and the recommended actions within that replication or within that recommendation would point you how you could drop that inactive replication slot. Going ahead, let's move on to a trigger or a recommendation which points if there is checkpoints happening frequently on your server. Checkpoints is set up based on two parameters, which is checkpoint completion target and checkpoint timeout. If your server is set up with a checkpoint timeout of 5 minutes and your checkpoints are happening every 5 minutes, then that's a way to go. But sometimes if your workload is too heavy and your max wall size, which is a parameter which lets the walls to grow until that specific maximum size set, and then it automatically triggers a checkpoint, in which scenario the checkpoints become more requested rather than timed. In such scenarios, it impacts the server by using up a lot of the disk I/O, and it uses CPU resources and also degrades the performance of the other workload happening on the server because it's using most of the resources in doing checkpoints itself. So to avoid that, in this recommendation, we walk you through recommended action where we ask you to update your max wall size parameter accordingly. So here to do that, if you go to the troubleshooting guides within the Azure portal, under the IOPS tab, you will be walked through checkpoints, and we provide you some selected queries using which you can find out how much GB is getting transmitted or accumulated between the two checkpoints. And based on that, you can set a higher value of the max wall size parameter so that your checkpoints are not requested. They would be, if they are mostly timed, then your server performance is optimized there. Coming to the next recommendation, which is long-running transaction. Long-running transaction recommendation is triggered if you have a transaction which is running for more than 24 hours, which means it's blocking the auto vacuum from cleaning the dead tuples, using the resources of I/O and CPU, holds locks on the objects for extended period of time, and it also causes to increase replication lag. To avoid all the above scenarios mentioned, we suggest you to go ahead based on the recommended actions. We take you through the PIDs and the duration on how long those PIDs have been active and running. What you could do is terminate that PID to let the server get back to its normal state and perform and improve the server's performance. In this demo, I'll walk you through one of the recommendations so that you know how to navigate through and how to follow the recommendation actions provided, and all the details on the recommendations. If you go to a particular server, either you receive a recommendation alert in your email, or if you go to your particular server and then if you navigate down on the overview page, you will see a recommendations in the taskbar, and you will see all the recommendations which are triggering on that specific Azure resource. Or on the left-hand side panel, you will see Azure Advisor recommendations. You could go to that window also and see. If you go to that window, you will see more details, like what are the potential benefits in implementing this recommendation. So let's go there. And here, if you see, it provides you the name of the recommendation, the category, the potential benefits, and when was this recommendation triggered latest. So let's go to one of the recommendations, which is here long-running transactions. When I go to the long-running transactions, it tells you the recommendation details on when a particular transaction is captured as a long-running transaction. At this moment, we are capturing any long-running transactions which are running for more than 24 hours. And it will impact the server performance by holding the resources and also not letting the vacuum to clean up the dead tuples, increasing the replication log, and holding the CPU and IO resources, which in turn slows down your server's performance. So here we have provided the server name, the recommendation actions, and the reason will provide you with the PIDs and the duration in which those PIDs have been running for a long time. Like for how long are they running? It will provide you that information in hours. So once we go through all this information over here, let's go through the recommended actions. When you click on this recommended actions, it takes you to the troubleshooting guides. Under CPU, if you scroll down, you will see long running transactions. Navigate to the long running transactions. And if you scroll through the bottom of the page, you will be seeing different recommendations on what could be done. Because these PIDs have been running for longer time, I can just use the PG terminate backend command to kill those transactions. So I'll just copy and paste it, copy the command, take the PID and go ahead and run this command to kill the long running transactions. Once you kill the long running transactions, the CPU resources are released, your cleaning of dead tuples will be initiated, and your replication lag will also reduce. Now that you have gone through that demo and understood how the recommendation works and where you can find them, let's walk through the next recommendation we have, which is on orphan prepared transactions. So orphan prepared transaction might happen when you have a prepared transaction running and suddenly your client crashes. What it does during that time is it still holds the logs for that transaction, which in turn blocks the auto vacuum from cleaning up the dead tuples, and also any query performances hitting that table within the transaction is degraded. So to avoid that, we ask you to commit or roll back the transaction. In the recommendation, we will show you for how long that prepared transaction has been holding the resources. And we, from the troubleshooting guides, in the auto vacuum blocker section, we provide you a query using which is table PG prepared exacs. If you do a select on that, and you can find the GID of that orphan prepared transaction, you either commit that GID or roll back that GID to free up your server from that orphan prepared transaction, enabling your server to be performant. Next comes the high bloat ratio. Bloat ratio is the unnecessary space which is accumulated by the dead tuples, which again happens because of the frequent updates and deletes happening on a specific table or a group of tables. So having a high bloat ratio of greater than 80% is when this recommendation is triggered. If your bloat ratio is 80% on a specific table or a database, which means your query performance, the optimizer has to sift through all those dead tuples. So it's taking longer time, and it's you consuming a lot of resources, and also the dead tuples are occupying the disk space. So in such scenarios, your query performance is degraded. So in the recommendation, we ask you to go ahead and perform a vacuum analyze verbose by identifying the tables which have the highest bloat. Going ahead to the next recommendation, which is triggered when you are approaching a wraparound situation. What is a wraparound? Wraparound is a situation when you are reaching the maximum transaction ID on that server. So PostgreSQL uses a 32-bit counter, which means you're allowed to go for a maximum of 2 billion transactions. However, this recommendation doesn't wait for so long. It is triggered whenever you reach the 50% of that 2 billion, which is 1 billion. Whenever you approach 1 billion transaction and cross it, this recommendation will be triggered, which tells you, hey, your server has already crossed 1 billion transactions. And why would you go into that scenario is when you have a huge transaction volume and your vacuuming is happening irregularly. When you approach, or when you are closer to the 2 billion transaction, or when you're approaching the wraparound situation, actually your server goes into a read-only mode to avoid getting into storage full situation. And this also degrades the performance. So it's better we address this situation when you are 50% near to your wraparound situation. So this recommendation takes you through auto vacuum blocker troubleshooting guide, where we check if there are any blockers on that server and remove those blockers, whether it's long running transaction or orphan prepare transaction or any inactive replication slots. We walk you through how you can remove them, and also you could run a vacuum freeze to freeze the transaction IDs for the identified table. So the troubleshooting guide will help you identify those tables, and then you can run a vacuum freeze on those tables to get your server back to a performance state. Coming to high CPU utilization. High CPU utilization recommendation is triggered when you have high CPU or greater than 90% of your CPU utilization for almost 2+ hours. Then this recommendation is triggered. Why do you get into this situation is mostly if you're running inefficient queries, which is using too much of the CPU resources, or you have high number of connections hit on the server. And if you have too many locks, heavyweight locks happening because of the queries which are being run, again, it talks about the inefficient queries here. If your PG stats are outdated. In all these scenarios, you will see that your CPU utilization has gone high. The moment your CPU utilization goes high, your performance of the server, of the queries degrades. To avoid to be in that situation, we walk you through, using the recommended actions, we walk you through the CPU troubleshooting guides, where we identify the different scenarios on identifying the top 5 slow running queries, and which is utilizing your CPU. You could go through the queries and optimize them, walk you through how many connections are happening on the server so that you can plan it accordingly so that you're not hitting as many connections. Coming to heavyweight locks, if there are too many locks happening, then you could optimize and see how you can clean up those locks and progress further. And you could do that by optimizing your queries again. If your PG stats are outdated, where the optimizer is not able to take the perfect optimal plan, that also causes the issue. So run an analyze command and get your PG stats updated. This is how the recommendations would proactively help you. Coming to the next slide, where I talk about multiple recommendations here. Till now, we have spoke about all the high impacting recommendations. Now we'll be speaking about some of the medium impacting recommendations. These are more about the logging. If you enable these logging parameters like log statement stats, log mean duration statement, log duration, log statement, and log error verbosity, all these parameters do extra logging so that you can monitor, analyze your query, and optimize your queries. So if you're really into auditing and optimizing, enabling these parameters is the best way to go, but for a shorter period of time. Once you're done with monitoring and optimizing your queries, we suggest you to turn them back on. So here, if your log statement stats are turned on, we trigger a recommendation. Coming to log mean duration, if it's enabled and if it's set to less than 1 minute, then also we trigger a recommendation here. So log duration, when it's turned on, which means you're capturing the duration of the statements being run. So then we capture that and we keep you informed that, hey, your logging parameters have been turned on and it's set to this specific value, please turn it back on if you're not still optimizing your queries, or if you've forgotten to turn them back off after you're optimizing and monitoring. So once you do that, your performance would be out of, your server would be out of all that extra logging and your performance would be better. Coming to auto vacuum is a process, backend process, which cleans up your dead tuples and updates your statistics. If you're turning off this parameter, which would lead to the accumulation of the dead tuples, statistics not being updated, which in turn impacts your query performance and the server performance. So we suggest you to always keep this parameter turned on. So as part of the recommendation for all these recommendations, the recommendation action will lead you to the server parameter page where you can update these server parameters with the recommended values. Here, with all this information, we are concluding this talk. You could clearly see how you could leverage the Azure Advisor recommendation, identify the different vulnerabilities or the performance issues your server is going through, and using the recommended actions provided in the troubleshooting guides or through the server parameter updates, bringing back your server to a performance state and improve the performance of your server and queries. Thank you.
That was lovely. I can see why Gayathri had a talk accepted this year as well as last year.
Returning speaker. That's very good.
Returning speaker. All right. Link to surveys up on the screen momentarily, but you can also find them in the hallway track on Discord, where you'll find other Postgres people, speakers, community members, attendees. And because Gayathri's talk was about Azure Database for Postgres, I just thought this might be a good time to throw this up there. One of my teammates asked me to make sure that people who are looking to skill up on using AI agents with Postgres on Azure knew about this new series. So there's a QR code and a URL for anyone who might want to attend. I think it starts, I should go check the date. It has not started yet. So the 4-part series is yet to happen. So building AI apps. And then
what time zone is that one in, Claire?
I will go find out. Let me
we'll come back to that. We'll come back to that.
Okay, we'll come back to that in the wrap up, because we do a wrap up at the end where we go over a couple of things that have happened. But let's introduce our next speaker.
Yeah, and you're already alluding to the end, because this is our last session for this live stream at least, but we have 3 more wonderful live streams coming up.
Before the wrap up. Technically, the wrap up might be the last session. I don't know. I mean, if people want to stay with you and me to hang out and look back and reflect, if.
I mean, why wouldn't they, Claire?
I would stay. We have friends.
I'm sure. All right. But for our last program session, I guess then, we're joined by Philippe. Philippe is the co-founder and CEO of ParadeDB, which is a Postgres-based startup building search and analytics capabilities inside of Postgres. Philippe is originally from Quebec in Canada and studied computer science at Harvard. And previously worked at a Microsoft on Azure Windows Server, worked at that, and then also at Whist, which is a browser cybersecurity startup. So lots of activity there. And then in his session, Elasticsearch-Quality, full text search in Postgres, Philippe will describe the current support for full text support, or full text search, in Postgres, and what is missing, and then to talk about solving those limitations with Tantivy, naming is hard, and PJ Search. And in his speaker interview on the Posette website, Philippe answers the question, what other Postgres events in 2025 are you looking forward to with PGConf New York? And yes, I bet a bunch of other people in Discord are excited about PGConf in New York as well. So let's hear it for all of the other conferences that we're interested in. I believe I just said to the other MCs and the producers that my dog has been on her best behavior, but I feel like now I've jinxed it because now she's not anymore. Anyway, joining us from the Netherlands, my dog as well. Anyway, enough about my dog. Really looking forward to this talk by Philippe. Let's roll it.
Hi, my name is Philippe. I'm one of the founders and the CEO of ParadeDB. Today, my talk is titled Elasticsearch-Quality Full Text Search in Postgres using Tantivy. We're going to be talking about how you can do full text search in Postgres today, what it's amazing at, what it's perhaps not so good at, and then some of the ways in which the work that we do at Parade with an extension called PG Search is lifting the limitations that full text search in Postgres has to make it competitive with Elasticsearch and other search engines. Okay, everyone, let's dive in. So we have a quick outline for today. We'll be structuring this talk into 4 components. We'll be speaking about the existing functionalities of text search in Postgres. We'll talk about what they're missing, and then we'll cover how PG Search improves first the full text side of it, and then after that, how it improves some of the aggregates and facets side of it, which you'll see in the talk is a pretty important component of actual full text search. Before we begin, I want to talk about some useful jargon to make sure everyone is on the same page and following along. But there's a couple of important keywords that come up when you talk about full text search. The first one is tokenization. It's the process of taking text and splitting it into chunks that can be searched over, for example, words. There's the stemming process, which is when you reduce a word from its root, into its root form. So, for example, the stem for the word running would be run. Then there's the concept of an inverted index, which is an efficient data structure for storing that data. In Postgres, it's called GIN, which we'll talk about soon. Then you have the concept of aggregation, which might be common to people in Postgres. That's the idea of doing analytics type queries that compute sums or averages or counts. Facets are the application of these aggregation directly to full text search results. So, for example, bucketing different keyword search into different categories. And then lastly, the biggest mouthful of them is Elastic DSL. Elasticsearch is a popular search engine, which is used oftentimes with Postgres. It's kind of the state of the art. And then they have what they call a domain-specific language that enables performing pretty complex searches. And we'll talk about how we bring this to Postgres to give the same expressivity to Postgres users. Before we dive in, I want to talk a little bit more about myself, but specifically about the team. But my name is Philippe. As I was saying, I'm the CEO. I'm originally from Quebec in Canada. I studied CS at Harvard. I didn't take a database class, which I kind of regret now. And if for some reason you decide you're curious to learn more, I did one of those amazing Postgres Live interviews that you can find up the link over there. And you may be wondering as well, what is Parade? So Parade is an Elasticsearch alternative on Postgres, and it's packaged as a Postgres extension. Why it even matters doing this kind of work in Postgres. A lot of you might, if you use Postgres search, you already know the answer to that question. But, just for everyone in the room, today, if you want really high quality search on your Postgres data, you need to go to a separate search engine, oftentimes like Elastic. And so a lot of users actually will migrate to using something like PG Search in the Postgres ecosystem to have better data reliability with transaction safety, which Elastic does not offer, to have better data freshness. You don't need to move your data from Postgres to somewhere else. You don't need data pipelines and ETL processes. We also enable keeping data normalized. Us in the Postgres ecosystem, we love schemas and structured tables. Search engines like Elastic don't offer this. And so oftentimes it's a big compromise. And then lastly, if you have a very update heavy workload, it's very difficult for traditional search engines to keep up with that. That's one of the big assets of doing search in Postgres, because Postgres is amazing at update heavy workloads. And I can't start this, of course, before, without talking about the people that are making this happen. ParadeDB is a small company. We're a team of 6 people. I do by far the least amount of work on this compared to all of the other people there. So Ming is our CTO, and he's my co-founder. Eric, he is one of our main Postgres engineers. He is the author as well of an extension called ZomboDB, which was a precursor to the work that we're doing. And he's also the author of the PGRX framework, which enables building Postgres extensions in Rust. They're used by, I'm sure some of the folks watching here is quite a famous person in the ecosystem. And then Etai is one of the maintainers of the Cloud Native PG charts, which is a popular project. And then Mo and Stu, who are the two recent additions to our team, are two amazing database engineers who previously worked at Twitter and MongoDB and are integral parts of the team as well. And these are the people that are making what I'm talking about today. So let's jump into it. Before we talk about how we make full text search better, let's cover what it is and what you can do today in Postgres. So full text search is the concept of querying documents based on the presence of keywords. You have text in your Postgres database, and you want to find the rows that have cheese in one of the columns, for example. It can be super simple, like the example I just described, or it can be quite complex. You might want to have custom logic about how you rank the results and return them to your users. Fundamentally, it's broken down into two categories. There's the indexing step, which is when you write data to the database, it gets indexed so that it can be searched faster later. And then, of course, the querying step, where you want to search over that data that was indexed. I also want to talk about what full text search isn't. So obviously, in this day and age with AI, everyone is very excited about vector search. There's a popular extension in Postgres called pgvector that I'm sure most of the people here have heard of already. Full text search is not a substitute for vector search and vice versa. In fact, they're complements. And so now that there's this big advent of vector search, there's even more demand for high quality full text search to be able to match not just by semantic meaning, but also by specific keywords, which is very important in a lot of workloads. And oftentimes the two are combined together for most of the workloads that we work with to give something called hybrid search, which is sort of the best of both worlds. We're not going to be talking about vector search today. There's amazing content you can find online about it. Okay, so enough housekeeping items. Full text search in Postgres. There's three things that you can do to do full text search in Postgres today. The first one is the like operator. It's by far the simplest operation that you can do for full text search. The second one, and when people say text search in Postgres, that's really what they mean, is the TS vector full text search capabilities. Usually they're combined with a GIN index, which we'll talk about as well. And then lastly, there's kind of a nice cherry on top that you can add with an extension that was actually brought to upstream core Postgres some time ago called PG Trigram, which allows doing some sort of higher, slightly more complex workloads on top of TS vector, for example. So you want to do search in Postgres. You have a Postgres database, and no matter where it is hosted today, these options are all available to you in upstream Postgres. With the like operator, the syntax is the following on the screen: column name like pattern syntax. So an example query might be something like select from users where name like John %. This will match things like Johnny, John, Jonathan, Johnson, and so on. It's super simple. That's a big plus. However, it has a few limitations. It's pretty slow. So if you have really, somewhat limited needs and you don't have a very large data set, it can work fine. It's also very limited. You can't do complex things. So for example, in this case, this would match Johnny, John, Johnson. You don't really have control over like which result will come first, what result will come second, and so on. That might be pretty important to you. And then it doesn't have any scoring capability, so you can rank it, kind of like what I was mentioning. But for some people, it's sufficient. The bread and butter of text search in Postgres today is the TS vector and GIN index. So you can use something called a TS vector data type. What it does is it stores the tokenized TEM representation of text. So if you remember from the the keywords that I was mentioning initially, it will mean it will take words, split them into their specific words, and then split them into their root form, like from running to run. And then the results can be ranked using TS rank. What TS rank does is it implements an algorithm called TF-IDF. What that stands for is term frequency, inverse document frequency. In less jargony words, what this means is if you have a term that is there more often, probably this document is more relevant. So if I'm searching for cheese and there's a specific row in my Postgres that has cheese 5 times, another one has cheese 1 time, well, probably that row is more relevant. However, it also means inverse document frequency, which means if that keyword is not very often present in other documents, it should have a more important impact on the score. So for instance, a word like the or it or she, those words are very, very present. And so, probably in every single document, every single row. So we don't want them to influence the score very much. And that's it. That's actually pretty simple. You can then create an index on top of these TS vector columns with the GIN index that helps improve performance by avoiding doing full table sequential scans. And that gives you the ability to do full text search in Postgres. You can specify keywords, you can specify how you want them ranked, you can order them by score using that TS rank function. And that starts to give us the ability to do pretty complex searching over Postgres. And in fact, there's a lot of companies today that implement this to do their search, including some very large companies that are actually familiar household names. However, if all of you have used Google and Amazon and all these search engines, you know that oftentimes there's a feature called autocomplete, right? You'll start typing something and then it sort of guesses what you might be meaning to say. Or maybe you'll mistype your keyword and it's still able to find what you're looking for. You can achieve a little bit of that with something called PG Trigram. What it does is it's another extension built in that gives you the ability to group your text into groups of 3 characters. So for example, if I keep cheese, the trigrams for cheese are going to be CHE, HEE, EES, and ESE. This allows us to do some basic autocomplete logic on top of it. So if I were to type CHEES, well, probably I mean cheese, but it's actually going to be able to match this keyword with these groups of 3 characters and guess that the word I'm actually meaning to type is cheese and start returning results to users, even if they make some mistakes. And that's pretty much it. This is what you can do in Postgres today in any of the databases that are deployed around the world. There's a few things that are missing, though. One of the things that's missing is BM25 relevance. BM25 is an alternative algorithm to the TF-IDF algorithm that I mentioned. And if there's any of you that are curious, I encourage you to pause right now and think, okay, based on the TF-IDF algorithm that we described, what could you do to sort of gamify that system and make sure that you can tweak how the results will be returned in perhaps an non-optimal way? That's what most search engines in the world implement, and that's pretty important. Unfortunately, Postgres doesn't support it. It also doesn't support very powerful tokenizers and token filters. People write text, in languages of various kinds. You might be, storing source code. You might be storing medical codes, things like that. And so being able to have specific filters and that can apply to how you want to split the text based on what it is very useful. And Postgres has a pretty limited functionalities there. The third thing that it's missing is this elastic language that I mentioned to create complex logic. So for example, you might want to boost the results by certain fields. Let's say you're Spotify and you want to make a song searching tool. Well, maybe there are songs that match exactly the keyword that a user is typing, but there's another song with billions of streams, and perhaps that song is more relevant, and so you want them at the top. So in real world search solutions, people will build really, really complex logic to be able to achieve what their business outcome. And in order for that, you need a way to represent those queries. And Postgres has pretty big limitations there. And then lastly, it's very common when doing search that you want to do some light analytics over it. Your Amazon, you want to bucket the results by 3-star products, 4-star products, 5-star products. Or you might want to say, oh, I want to tell you how many results were returned, right, on Google. You search and the front page tells you 10 or 20 results, but there were 120 million results. That needs to do some counting. And if any of you guys have tried to do a count star on a Postgres database before, it can be quite slow. Sometimes, many, many minutes, which obviously is a big problem. Those are the 4 main things that are really missing to make Postgres a really state-of-the-art search engine. Before we cover, how we solve these, let's talk about BM25 specifically. So I bet you didn't expect to see math today, and you don't have to look at the equation from too closely, but there's essentially 2 things that BM25 does on top of the TF-IDF algorithm in order to solve the limitations. The first one is it takes into account term saturation. If I keep the example of searching for cheese, maybe I have a row in Postgres that has the word cheese mentioned 5 times and one that has the word cheese mentioned 1 time. probably the one mentioned 5 times is more relevant. However, what if I have a row in Postgres with cheese mentioned 999 times and one mentioned 995 times? Well, now, probably they're both very, very relevant to the user. And so what term saturation does is it makes sure that actually you'll see on the curve here, as the word gets repeated more often, it kind of tapers off its impact on the score. That's really important so that the search engines don't end up containing documents that just repeat the same keyword a million times to rank at the top. That wouldn't be really what we would want. The second thing that it takes into account, well, it's cut a little bit here, but this says factors in document length. And so if I have longer documents, more text in a Postgres row, well, probably it's just more likely to have the occurrence of the keyword, right? Just because a document or a row contains more information doesn't necessarily mean it's more relevant to the user. And so we also want to take into account the average size of the documents so that we can normalize by that value. And that's it. This is the state-of-the-art algorithm, the TF idea that Postgres implements with these 2 cases taken into account. And that's what all popular search engines that you see around the world today implement in order to rank results to give to users. Unfortunately, Postgres doesn't have these capabilities, and so you can sort of tweak the quality of the results, perhaps negatively, and that will impact the user experience. And so that brings us to PG Search. So PG Search is a relatively new Postgres extension that's coming in on soon 2 years old. It's built on Rust using the PGRX framework that I mentioned. Eric, one of our team members, has been building in the community for the past several years before any of this started. It uses a full text search library called Tantivy. We'll talk about that in a minute. And it's there to solve these 4 limitations: slow faceted queries, BM25, better tokenizers, and a powerful query language that can be used to create queries. Tantivy, the search library that we use inside of PG Search, is a Rust-based library designed for search and really optimized along all of these facets. It's inspired by a project called Apache Lucene, and Lucene is what Elasticsearch and a lot of other search engines around the world use to build their search functionalities. It supports fast full text search. It supports fast faceting or fast aggregates, like I mentioned. It supports BM25 scoring, and it has the ability to do this columnar storage and inverted indexing to have really high quality, have really high performance results. What we do with PG Search is we take this library and we integrate it within Postgres on top of the Postgres storage system, the Postgres buffer management system, to make it like a true first-class Postgres citizen extension that feels no different than any of the other ones that exist, but has these capabilities built in. Tantivy, one of its big benefits is it's super fast, super fast. In fact, it's about twice as fast as Lucene, the original project that is used all over the world. The way it manages to be so fast, this is a bit outside of the Postgres scope, so I'll cover this quickly, but it uses immutable segments, which means when you write data inside the index, things get written really quickly. This makes indexing much faster. It does memory map files, which we actually put on top of the Postgres blocks. And then it's written in Rust with vectorized execution, which allows taking advantage of the hardware to actually run queries and run processing in parallel. Okay, this is beginning what I think is the most exciting part of the presentation. How did we actually build PG Search? How did we solve these limitations and sort of reconcile the differences between Postgres and between this Tantivy search engine? There's 4 key components that enable the work that we do. The first one is we have a custom full text search operator called the @ or the triple @. For those of you that have written TS vector queries before, you know the operator for TS vector is the double @ or the @ operator. So we feel like it's kind of the continuation of that work. On top of this, we have our custom Postgres index that we call the BM25 index. It's similar to the GIN, but it uses the Tantivy indexing. Then we integrate our own query builder API to give this powerful query writing capabilities. And then lastly, and the coolest part of it, is what we call the custom scan, which allows us to define how the data is being read from the Postgres table and fed into Tantivy, our search engine. So let's go over all 4 of them. Excuse me. So the custom full text search operator, this is the bread and butter and kind of the simplest part of it. So all it does is it resolves true if there's a match between the text and the keyword. You can put it in any Postgres query, including with other extensions, including with joins, anything like that. And here's an example of what it looks like. Select star from mock items where ID is less than 10 and description is keyboard. What this is saying is you're looking for the keyword keyboard inside the description field, and then returning all the results where the ID is 10. It's less than 10. Pretty simple. Just by adding this, we now have the ability to do full text search with Tantivy internally and all of the optimizations that I mentioned. However, if we were to just leave it at that, every time we would run a full text search query, we would need to scan the entire table. So if you have hundreds of millions of rows or billions of rows, it's going to be really, really slow. You might know this is called a sequential scan. In order to speed this up, we create a new index using the Postgres index access method that we call the BM25 index. It works exactly like a B-tree or a GIN index. It works with updates, vacuum, scan, everything that you expect out of a Postgres index. There's only one exception, which is we only allow one BM25 index per table today. And so if you have multiple columns that you want to search over, you need to put them all into the same index, and this helps with performance optimization and making sure that the Postgres planner will actually run the queries against this index. This ensures that when you run these triple add queries, they're actually going to execute on this index instead of scanning the whole table, and that speeds up performance significantly. The third thing that we add is called the Query Builder API. So this can go on the right-hand side of the triple add operator, and it makes it easy for us to construct queries that can then be passed down to the search engine in the form of complex JSONs. They can be JSONs, but they don't have to be. This is an example of what it looks like. If you take this query here, I'm saying select star from mock items where the ID is this following complex query that says, okay, description matches shoes, but we want to boost that by 2, and then description matches running. So what are we doing here? Well, we're looking for running shoes, basically. You can imagine an e-commerce use case. What we're saying, actually, we want the value of shoes, to be doubled compared to the values of running. So you might imagine from a business selling shoes that if they run out of running shoes to show the users, well, probably that user is more likely to be interested in a different pair of shoe than they are to be interested in something that's running related but isn't shoes. And now we're starting to give our customers or users the ability to bake business logic that's proper to their use case into how they're using the search queries. This is really, really important, and unfortunately something that's quite difficult to do in regular Postgres search. And then the last part that is perhaps the most exciting in my opinion is using this custom scan API, which allows us to take control of how the query is executed beyond the where at clause. There's 3 things that are enabled with this that brings really good developer experience to using something like PG Search. The first one is predicate pushdown. The second is BM25 scoring, which we need to talk a bit about. And then lastly, it's these fast facets and aggregates. So how do all of these work? Predicate pushdown. Let's look at this following query. Select star from mock items where the description is keyboard and the rating is less than 5. If we didn't use a custom scan, because we have the at and the and predicates, we would need to actually do 2 scans of the BM25 index. But given our index already contains both columns, given it's a covering index, it would be so much less wasteful if we could do a single pass over the index. Well, this is what we can do with the predicate pushdown. This is an example you can see here, where actually we're taking these rating and description predicates and we're pushing them into a singular Tantivy query, which get executed on the search engine internally to Postgres directly, without us needing to go and do 2 different scans. Okay. The second thing that allows us to do, and that's a really powerful piece of it, is scoring projection. So if I take this query, select star from mock items where the description is keyword. Well, in my mock item table, I don't have any column for BM25 score. So I need to find a way to still give that to the user so they can be filtered and ordered by and so on. The custom scan allows us to do this projection. So what it looks like is you will have a query like here that says select description, rating, category, and paradedb.score. What will happen when you do this is the scores will be enabled as true. And then when you have your result set being returned by pSQL, you will see a fourth column called paradedb.score, which will actually tell you the computed VM25 score for all the results that are returned. And then you can start to order by, ascendant or descendant of the value of the score, for example, and use that to decide which results get returned to the users. Here's an example of exactly what I was talking about. So select description, rating, category, paradedb score. And you see we have the description, the rating, the category, and then the score is projected here. And in this case, we're limiting to 5 and scoring by descendant, so the top scores are at the top. So this is an example of searching for shoes or the rating being higher than 2. So you can see the shoes are here at the top because the keyword is present, so that influenced the BM25 score. If you combine all of these together, you start to have a pretty powerful way to go and do this search capabilities in Postgres. However, there's one big piece missing. What if I want to tell my users the number of results that would have shown? That's when you need these fast facets or these fast aggregates. So let's look at this query here. Select count ID, description from mock items where the description at keyboard limit 10. If you have a really big database, it's going to be very slow. Fortunately, in our search library, we also have the ability to store data in columnar format. Columnar format allows us to do much faster aggregations. So if we index fields as what we call fast, it means Postgres will actually compute these fields in batches. And that allows speeding things up a lot. We can even do the MVCC visibility checking of Postgres, which is a whole interesting topic in itself, on a per page basis or per block basis. We can also parallelize the processing of these, which means internally there's multiple Postgres parallel workers that actually process each of these batches. This gives us a sort of column-oriented vectorized analytics or faceting engine. And if some of you are curious about these types of tools, there's a lot of analytical databases that exist in the world, and that's kind of how they're built and how they can achieve really fast analytical performance compared to a more traditional row-based database like Postgres. PG search through Tantivy actually brings some of these limitations back into Postgres so that we can also do this here and have really fast aggregates and really fast results for these text queries. And that's it. That's how it works in a nutshell. There's a couple of use cases. People find new ones every day, but the main ones that we see are customers that don't want to migrate data off to a separate system like Elastic, especially if they have update-heavy workloads like in e-commerce or finance. It's very common for them to struggle to do that data migration. And so PG Search helped them stay in Postgres. And everyone here at Posette is very excited about Postgres, obviously. So that's something that we just want to enable people to do and keep using the database that we all love. And that's it. That's all for me.
I'm so glad that Philippe joined us.
Absolutely. Talking about cheese all the time. And I get a little hungry. I get a little peckish. I'm not going to lie. It's approaching 11 p.m. for me. I could use a snack.
The Postgres ecosystem, which I suppose is driven in part by the extensibility of Postgres, just continues to amaze me. And all these startups that have cropped up in recent years, 2 of which have been acquired in recent weeks. Some big acquisition news in the space. But obviously, as a founder of ParadeDB, I mean, Philippe is basically operating in this space that allows all this innovation and builds on top of Postgres and kind of carries things further. And I think it's wonderful. So I love seeing it happen. We have a slide about surveys. We have it all figured out now, right? In the survey itself. What?
Yeah, we do have it all figured out, and I've tried it a couple of times. It works. It totally works.
All right, just make sure when you fill out your talk surveys or your event survey to grab the code and then go to the other page, drop the code in, enter your address, all of that, so that you can get a pair of socks. That's the only way to get socks, is to actually give feedback, useful feedback, obviously, because that's what people need to get better.
Yeah, and we've reached the talks per live stream now, right, for this year, which is nice. So there's only 11 to pick from and give your feedback for this live stream, at least.
Yeah, so if you squirrel this away and you come back for another live stream tomorrow, you'll be like, wait, I don't see the talks from what I just watched. And that's because there's a different URL and different QR codes, and we'll share them in each live stream. So thank you, though, because we have been getting feedback that people are acting on this, which is wonderful and much appreciated. Also, gratitude to all of the speakers, the ones on today's live stream, as well as everybody else. 3 more left to go. This conference would not exist without all of these people and their expertise. And a lot of times, I don't know about you, Flora, but like, when do you create your conference talks? Like, I can't get it done during my normal work day and with meetings and discussions. Like, for me, it ends up being something I work on at night or on the weekends. And it's a lot of blood, sweat, and tears, usually.
Absolutely. Yeah. And then preparing for recording as well, because I feel like recording a talk is so different from giving a talk live as well. So, there's just other things that you want to be thinking about. So yeah, a lot of work goes into these.
Like right now, I'm looking at the camera, but a lot of today, I'm looking down here at my screen because I want to look at you and I want to look at this.
I want to look at you. Yeah.
What if I were looking down here, like, or over there? And yeah, so it is, you have to do a little bit of work to figure this out. So big thank you. You can learn more about all the other speakers. And just to highlight what's next, thank you again. You can obviously go ahead and attend the upcoming live streams, 2, 3, or 4.
Or all of them?
Yeah, that works. That works if you don't want to sleep. I think Teresa Giacomini may be at all of them. Join the Discord as well if you haven't gone over there yet. There's some nice chatting going on with the speakers. Obviously, give us feedback. And then you can replay this live stream. It's if you go to aka.ms/Posette-ls1-YouTube, that will show you this live stream. So all of the talks will be published individually at the end of the whole conference, so therefore on Thursday. But before then, the individual live streams are available on YouTube as they happen. So that's what's next. And if we just want to peek at what's going to happen in this same time slot tomorrow, live stream 3, you can get kind of, everything's kind of fine print. It's hard to see, but just go to the schedule page, right? Go to posetteconf.com, click on the schedule in the top nav, and then you can get there fairly easily and see what's coming, see if it's relevant to you, or go to the Ultimate Guide blog post. That'll work too, and we'll share that link in a minute.
I even feel like that might even be the next slide, is it not? Oh no, it's not. Look at it. It's us wrapping up. That's nice.
Yeah. So now we start the official wrap up. Shall we do it? Let's go.
Let's go.
Okay, so this is what just happened. Really, really appreciate these speakers. Appreciate everybody coming onto Discord. Appreciate you, Flora. I know it's nighttime for you. There's no more sunlight coming in the windows behind you. And it's just a dream to work with you. And I really appreciate your energy.
You've seen it go dark behind me. But, like, props to the ring light that keeps us all, that keeps shining a light on me. No, this was great. 11 talks by 12 speakers was really good. Again, like, I feel like every year, this is such a great conference. I really enjoyed myself.
And then go check out the schedule page, or after the event is over, obviously all the talks will be published individually, but there is a playlist that connects all 42 talks together. And that URL is on the screen right now, aka.ms/Posette-playlist. It probably doesn't work yet, or probably points to something from last year, or maybe to posetteconf.com. But it will work on Thursday as soon as the 4th one is over.
Exactly. That was the question in Discord. When are they going to be live? But on Thursday, you can view all of the talks again.
And I always feel a little bit superficial when I bring up swag, because what matters, I think, is how learning from all these speakers about the various components in Postgres that they are expert in, how that saves us time. Like, that's what matters, right? I mean, whether you're a DBA or a developer, someone that's building something on top of Postgres, whether it's open source or in the cloud, like, the most precious thing any of us have in the world is our time. And so getting better, getting faster, getting more efficient, I feel like that's a gift. But people like socks and they like stickers and they like swag. Look, I've got a sticker right here on my water bottle from the Talking Postgres podcast. So hoping somebody will stop me on the street or in a cafe and say, "Hey, what's that?"
Oh, is it? They will stop you and say like, "Are you Claire Giordano from the Talking Postgres podcast? Thought I recognized your voice." That's what's gonna happen.
Okay, so that did happen at PGConf in Prague. It was really
That is
weird.
so fun.
And no, here's what's embarrassing about it is somebody came up to me and said, "I recognize your voice. I recognize your voice. You're from the pod." And I didn't know what a pod was, which is just absolutely embarrassing. I'm like, "Oh, that's a nickname for a podcast." Anyway, so yeah, doesn't happen often, but it was,
Anyway,
you know.
To come back to your yes, it's great that we're learning a bunch of stuff, but swag is also fun, and I think it's fun that you're offering some swag for a virtual event. So normally, you join an online event and you have nothing to show for it. Now you have some stickers or potentially some socks if you've submitted some feedback to show for it. So definitely should be mentioned.
And I hope everybody gives feedback, and the socks are pretty cool. Now, the socks will run out at some point. So it's obviously a while supplies are limited type thing. And it's possible that we might run out. So yeah, don't wait till the last minute to do your surveys and to give your address and all of that. Okay, so perspective. This was Livestream 1. There's another one happening morning tomorrow European time, right? Morning Wednesday European time, and then morning America's time on Wednesday, and then morning European time on Thursday. Does that all make sense? I think it does.
It makes total sense.
Okay. So 42 talks, and here's the ultimate guide. So I wrote this blog post, and maybe it's not a good name. I don't know. Maybe it has too much hyperbole, but I worked with Daniel Gustafson to divvy up all the talks in useful, I hope, categories, subcategories, and tags, just to make it a little bit easier to find the things that might be interesting to you. Because I don't know how many people are going to listen to all 42 talks. Obviously, Teresa has, but I think people are going to pick what's relevant to them. So the hope is that these buckets and these tags, which are fine print and kind of hard to see, but dive into the blog post and you can read it and see if it's useful.
Absolutely.
Have you read the blog?
I have, since you pushed me to read it earlier in this live stream. No, I think it is very, very useful to just pick and choose the ones that really, speak to you. So yeah, I am definitely going to check out a couple more of the ecosystem talks. Those are my gem for sure.
And one of the things that is so cool in this community is that, yes, I work at Microsoft. Yes, this is an event organized by Microsoft, but our content is not just about Azure, although it is partly about Azure. There's a lot of open source content. There's a lot of ecosystem content and people participating from other companies. And I think it's pretty amazing the way the Postgres community comes together and collaborates across all these boundaries. So it's part of what makes me enjoy my work. All right. Upcoming Postgres events. There's something here that's near and dear to your heart.
I mean, there's multiple here that are near and dear to my heart. Of course, I cannot call any favesies, but if I need to call one, it is my own event. No, we have a couple of really fun events coming up. Like one of them is pretty soon already, Swiss PG Day. Then it feels like there's going to be a bit of a summer break, July, August, and then we'll be back in September with a bunch of events again. One of them being PG Day in UK, and then September 9, and then a couple of days later, we try and the two organizing teams try and make sure that those are situated quite closely together in terms of times and dates, so that you can visit both and you can just take the train from London to In this case, Rotterdam. It says Amsterdam on the slide. Doesn't matter. Rotterdam, Amsterdam, they're close enough. In any case, if you're a sustainability person and you want to take the train from London to Rotterdam, it's a straight train there. So yeah, that's happening. And I mentioned it earlier on the stream, but like we might have some people that have joined us since we published the schedule for PGDA Lowlands today, because we do conference-driven development. Like Posette is on, we need to have a schedule, or we need to have something new to say. Then there's PGDA in Naples in Italy in September, like end of September. The CFP for that one is still open. So, like everyone who's been watching all of the talks today and thinks, I can do that. You should totally do that and submit to the call for papers for either Napoli or PG Down Under, which will take place in Sydney, Australia in October.
I know at least one of the people on the talk selection team for PG Down Under, and that's Thomas Monroe. And if I could only go to PG Day Napoli, I would just be in heaven, right? And I would make a trip to Sorrento, and I would eat all this great Italian food and learn a lot of Postgres. But I will not be there this year. But I'm really happy that there is going to be another event. I think is it the second year for Napoli? Is that right?
It's the first year for Napoli, but it's a different name. Doesn't matter. I've been practicing my Italian on Duolingo the last couple of weeks. I really needed to brush up. Yeah.
Got it. And then Swiss PG Day, if you live nearby and you can make it there, a number of years ago, I gave a talk at that conference, and it's just a fabulous location in Switzerland. So, but this isn't all. There's also these two really much bigger Postgres events that are going to be happening. PGConf New York City, that I think Philippe got mentioned in Philippe's talk, or around Philippe's talk.
Yeah,
that's happening.
Philippe mentioned it in his interview that's an event that he's really looking forward to. Yeah.
And that schedule hasn't come out yet, but it will be soon. And then PGConf EU, the CFP just opened like yesterday, and it'll be in Latvia, and it closes the end of this month. So if you are interested in submitting a talk, now is the time.
Yeah,
so
be quick about it. Yeah.
Good to keep track. And then I think around Lukas Fittl's talk earlier today, I mentioned that he does this great series called 5 Minutes of Postgres on YouTube, and people have really enjoyed that. He'll go and take something that just happened on the mailing list or a blog that just got published, and he'll dissect it and explain it in 5 minutes or less. And it's, I think, a really valuable service that he provides with that. I know Michael Christophides. I saw him on the Discord chat earlier today. He's one of the co-hosts of the Postgres FM podcast, which is cool. But then I'm a host of a podcast in the Postgres space as well, which is one of my favorite parts of my job. I love it.
Yeah, and it's a really cool podcast too. And I'm glad that it's longer than 5 minutes, because sometimes, especially the people that you invite and the topics that you cover, definitely need more than 5 minutes. I'm not referring to myself there. Maybe like I've just been too verbose in our podcast. But I've been really enjoying this podcast that you've been putting on. Really a great body of knowledge there.
It's evolved over time, and it started off as it was only supposed to be like 2 or 3 episodes long, and it was called Path to CitusCon. And then people liked it so much, we continued. And the goal is to help people understand the people who work with Postgres, why they do what they do, how they got there, what their journeys were, what you can learn from them, and figuring out your own journey with this database, either as a user or as a developer. So it's really quite fun. Let's see, we've got more live streams coming up, and I just want to give a shout out to these amazing people who will be helping to co-host and host the upcoming live streams. So Boriss Mejias, who was a speaker today, Melanie Plagueman, who was on the talk selection team for the conference. I always mispronounce his name, Dirk van Veen. How did I do?
I think it was pretty good.
Okay. So fabulous Postgres speaker, a customer, also a Posette speaker. Thomas Monroe, committer, Postgres contributor, works at Microsoft, and Adam Vogt, who works on Azure Database for Postgres. So they'll all be joining you for the upcoming live streams. I want to say thank you also to the organizing team. So these 8 people have worked so hard to get us here, and their work is not over yet. There's still 3 more live streams to go, but big shout out to Teresa and Aaron, who I've seen today here. I think Linda's been here on the Discord as well, and Pooja. So thanks to Bill Gay, Amma, Jeremy. These conferences they don't happen by themselves, especially not in the open source world. So a lot of time. And yeah, have you been on talk selection teams, Floor? You have, right?
I've been on talk selection teams before, and you mentioned 230 different talk submissions. That's a lot to go through and to come up with a schedule that really covers like all of the topics that were covered today, but also we've seen in the trailers like all of the new the other live streams, all the topics that they cover as well. So that's great work that you've done there. So thank you to our talk selection team as well for their amazing job. Yeah.
Daniel and KK and Melanie are just awesome and really approach it seriously and with diligence and reviewing the proposals. And we were just blown away. All right. So if you're not following PosetteConf yet on social, if you do, go to use social media. Not everybody does, but we are on all these platforms. And so feel free to give us a follow, and then you'll be able to stay in touch with what happens in the upcoming streams with the other speakers and the upcoming talks. And with that, I want to say thank you, Flora, for joining me today and being part of this. I really, really appreciate it. And I want to say thank you to everybody who watched and attended and stuck with us through this wrap up too.
Yeah, we did it, people. And thanks again for inviting me to be your co-host for this one. I had a blast.
Thank you. Ciao. Bye, everybody. See you at the next live stream. Keep on postgressing.